Good morning and welcome from my personal behalf to all of you for having come to the AI Impact Pre-Summit. We are doing it along with our partners from ISB and D Labs and Avinya. We are very grateful to their participation in making this event happen. As you probably know, this event is a pre-event for an event that's going to happen in Delhi next month around 17th to 20, where, in last September also the government of India has announced AI Impact Summit, first time in the Global South. So there are hundreds of events that have taken place. Actually, 2 days ago, IIT Hyderabad has done one on social impact. Since CCMB is a biology institute, our focus is on healthcare. So reimagining health, as you know, probably AI is the most talked about topic all over the world by everybody, right from anybody to anybody. So it's something that we understand the power of it. So keeping that in mind, the government also looks at it as a three verticals, not our three application areas: people, planet, and progress. The people is obviously given, some people compare AI almost to nuclear power. The power of it is so pervasive, one has to be very careful in handling it. So when we talk about applying AI to people, one has to look at inclusivity, and also one has to look at dignity, because we know the power of AI, what it can do in terms of looking at our personal things. So dignity and inclusivity is very important. And also planet is very critical. As we know, the things are not going in the right direction. So how do you maintain the sustainability is another kind of focus of this AI Impact Summit. The third one is, of course, the progress. Because AI is so powerful and almost is agnostic, it is relevant to chartered accountants, to scientists, to astronomers, to anybody. Everybody gets affected by its presence. So it's important these aspirational things match with kind of balance and equitable to everybody, for the planet in per se. So it is this particular conference, or the pre-summit, or the national conference, is to bring in all these elements together and make sure that everybody understands the complications and the benefits of this AI and use it in a way that benefits all. It should be equitable. So one of the things that we look for in this particular conference, Reimagining Healthcare, we call it ILAN, is to see how AI, as you know, probably India is one country where there is access to good healthcare is poor. So can we use these tools to make this the so-called very well-developed healthcare systems that are available in metros equally accessible to the poor or inaccessible people? So this is one of the ways where we wanted to promote the last mile delivery of healthcare in many places. So this is something that we hope to bring in some kind of ideas and put them together, and also come up with some kind of suggestions that we are obligated to bring it to the government, and then see what kind of mechanisms that we can develop or come up with, so that the government is more empowered to execute them, because they come from the ground, from a ground level like us. So this is something that I just wanted to say here. And again, on my personal behalf, I welcome each one of you and for being here, and hope you will have the rest of the day that kind of makes our understanding of AI in our lives much better, and also come up with kind of measures that would make it much more beneficial, because there is also the dark side of it. So it's very important for us to be aware of all these things. So hopefully we'll have a very good session, and fortunately we have participation from excellent people here today. I hope all this leads to a very good interactions, and I request all of you to participate in whichever way you can and get benefit out of this gathering. Thank you very much.
Thank you, Dr. Madhu. And let me just introduce myself. My name is Ritika. I am the head of corporate relations. So I'm going to hand over the events for today to the Master of Ceremonies, which is Tejaswini. She is the science communicator at AIC-CCMB. On to you.
Thank you, Ritika. Thank you, Dr. Madhu. Now, I'd like to invite the CCMB Director, Dr. Vinay Nandikuri, for his address. Dr. Nandikuri is widely known for his work on tuberculosis. His research bridges fundamental science with real-world impact, particularly in public health. Thank you, Dr. Madhu.
Good morning to all of you, and welcome to CCMB. Very nice morning, not very cold, not very warm. Just came from Delhi, so I can see the difference. AI and healthcare is something that basically, few years ago we would not have imagined. The way AI has kind of changed the way diagnostics happen, the way detections happen. Right now you wear one watch or certain other detectors on you, and you can monitor glucose regularly, and you can see the glucose, the utilization spikes, so you can actually monitor your diet accordingly. Things have changed drastically, and I believe it's only the start. If you think of diagnostics per se, in the diagnostic space, AI is going to be very, very much useful and going to become really the thing. You can go now point of care. Eventually, we can detect antimicrobial resistance. I'm very sure in about a year or two, we will have fantastic methodologies to figure out the microbial resistance in the case of tuberculosis too, which is a slow-growing organism. Even before the treatment starts, we should be in a position to say whether the patient is going to be resistant to the following drugs, and accordingly choose the treatment that the patient can take. And the chest x-rays can be analyzed by AI ultimately to tell what level of infection they have in the context of tuberculosis or many other things like pneumonia. So AI is going to be very useful in the context of healthcare, and personalized medicine is where we are going. If it's not now, 5 years, upper limit 10 years, everything is going to be personalized. How a person reacts to medicine can be predicted. So this is a starting point, and it is also the time where we actually interact with the startups, and they already understand the change in the ecosystem, and they are the ones who are actually there more than the researchers. And very soon, researchers started understanding it, but they use it more for their solving the scientific questions, right? So everybody is using AI. Structural biology heavily influenced by AI, and the way structures are solved nowadays. You talk about not even solving them, right? You can predict a structure. So you can do many things. Structural biology, even the basic biology of many of the other things that we do, is heavily influenced by the kind of technology that is available, and something that we all as researchers have to adapt, and you people as startups have to adapt and use them for developing better and better tools that are going to be useful in the context of healthcare. So I believe this summit are the ones that are going to be following the big summit that's going to follow this. These are the kind of gatherings that are important for all of us to get a clear idea on how this landscape is going to change, or is changing and is going to change. And I believe that this is where the future of medicine is. 10 years from now, 15 years from now, things will be very, very different. The way we do research is going to be different, the way we do diagnostics is going to be different, the way we actually find solutions for the problems that are identified are going to be different. There will be the way artificial limbs, the vision, hearing, everything is going to be influenced by those people who are hearing impaired or even the visually impaired may be able to see, and that is already on, where you can actually have connected to neurons, and you can actually see using the AI what kind of visuals which they were blind person could not see. That's already on the way. So things like that, every aspect of our body, the way it gets controlled will be understood better, used better for solutions. So many of these things are going to change, and I can see that. And I can visualize how it's going to change. But point is, these are the places where we are going to talk about how this is going to influence the change. So these summits or these kind of conferences are very, very important for all of us to understand how the ecosystem is. I mean, just to very, very briefly talk about it, you guys are in an institute which is approximately 47 years old, and it's going to be 50 very soon. In about 2027, it will be 50 years old. And this is also an institute which has a leading biological institute in India. Even now, it is one of the top 5 biological institutes in India. And this also is an institute where DNA fingerprinting was first time developed. This was way back in 1988. So we would love to be part of this particular transition that is happening in the healthcare. And AICCCMB, which is the Atal Incubation Center, which is part of the CCMB and started around 7.5 years ago, is actually gives us a different worldview compared to what we do in this end, which is the research, and also keeps us in touch. And it also provides opportunity for the students of CCMB or any of those who are associated in one way or the other, faculty who are associated with CCMB, to actually change their ideas from, something like lab to what can be used in the real world. So AICCCMB has been, majority of the incubators are not associated with CCMB, but it is something that provides us the opportunity. And with this, I would really like to say thank you for all of you for being here and for being part of this discussion. And welcome to CCMB once again.
Thank you, Dr. Vinay, for this visionary glimpse into the future of healthcare with AI. Next, I invite Mr. Sarvesh Singh. He's the Director and CEO of Telangana Life Sciences for his special address. Mr. Singh spearheads initiatives to further elevate Telangana's leadership in biopharmaceutical manufacturing, vaccines, medtech, AI-driven healthcare solutions, and innovative infrastructure. Mr. Singh, please come to the stage.
So good morning, everyone. It's an honor and privilege to be part of this summit where we are discussing on reimagining healthcare. I would like to thank Dr. Vinay, Dr. Madhu, and entire CCMB team for putting together this great show. I interacted with a couple of startups before this, and the ideas and the solutions which they have is definitely something which is worth pursuing in the future. So, So I think the first and foremost question is that why healthcare needs AI now? And I think answer is very simple, because if you look into governments across world, and especially for countries like India where population is huge, there are a lot of deaths which are happening because of chronic diseases, right? A lot of deaths are happening because of NCDs, right? You can also see that there is a lot of data being generated in the process. So there is a lot of data which is being generated from hospitals, labs, then you see data coming from wearables, data coming from sensors. Patients themselves are generating a lot of data. So humanly it is not possible to contain the cost and process the amount of data which is being generated and tackle all these chronic diseases and NCDs. And I think that is where AI can play a key role. And this is the right time because now there are a lot of tools and technologies which are available to process that enormous amount of data, which was not the case if we say decades ago. So now on one hand there are tools and technologies to collect the vast amount of data, there are tools and technologies to store that much amount of data, and at the same time there are AI technologies which are available to process and make sense out of that data. So I think that is the reason because of which this is the right time to use AI. If we look in terms of opportunities which we have our way, there are three key opportunities on top of several others which we have. One is that if we start using AI tools, there is an opportunity for early detection and screening, right? So like breast cancer, cervical cancer, then for several eye diseases and for several cancers, right, to look into those images, you can use AI in order to do the detection and early screening. Second is that nowadays you can see that there is crunch of specialists, right, especially in the rural population. And even if you go into bigger cities, the people who are specialized in a particular disease, they are bombarded with a lot of patients. So there is an opportunity to implement clinical decision support systems, right, where you can use AI tools to train the system, and then that can be used even by a person who is not a specialist in a particular therapeutic area. So there is a huge opportunity which we have. There is also an opportunity to use clinical decision support systems in our ICUs, because several times we see that in ICUs there is not much attention paid to the level which should be paid based on the criticality of the patient. So CDSS is an opportunity. Third is public health intelligence. So we were looking at one of the stalls, they were having some solution on AMR, right, antimicrobial resistance. And one of my colleagues, he said that this is going to be the next epidemic or next pandemic, right? So there is a lot of opportunity to use some of this public health data to make the decision making using AI. Now, whenever there are opportunities, there are some bottlenecks because of which we are not able to leverage the opportunities which we have at hand. So these are 5 problems which needs to be solved on top of several others which we have in order to successfully implement AI solutions. So first one is data quality and interoperability. So majority of you or maybe all of you are well versed with the healthcare data. So if you look into the hospitals, not just in India but across world, the data is messy. Each hospital has their own hospital management system, they have their own standards in which they collect data. Payers, they have their own standards for collecting data, right? The clinical research organizations, they have their own way of collecting data. So till the time data is not being collected in a standard format, and till the time we do not have interoperability of data where we can take data from one hospital to the other hospital, from one clinic to the other clinic, it will be very difficult to take AI to scale. AI will remain in pilots. So this is one of the bottlenecks which we see. Second bottleneck which we see is the trust and validation. So whenever we are talking of healthcare data, we are talking of patient lives. So it's not about the accuracy, it's also about the trust. So there are a lot of steps before you can actually use AI. So you'll have to conduct a clinical research, you have to show that this solution actually works, it has to go through regulatory pathways, right? After that, you can bring that into a live scenario. So this is the second challenge which we have. Third challenge which we have is on bias and inclusivity. So majority of AI models which are being developed today are being developed in Europe, US or in other Asian countries. So the type of data which is being fed in order to test those models is either American, European, or other Asian countries' data. When you try to implement those AI solutions in the Indian settings, in the Indian context, then those models fail. So there is a huge opportunity for people sitting here in the room who are running several startups or trying to make products to train your data in the Indian context on the Indian patient population, so that we can get rid of bias and we can have more inclusivity for the Indian population. Fourth issue which we see is the cyber security and privacy. So the way we are building security measures, on the other hand, there are thefts which are being built and to get into your ecosystem. So there is a good opportunity for startups which are working in the cyber security space to see how they can make this whole data more secure. There are two data types which are quite sensitive. One is your health data, other is your finance data. If it gets leaked, there is a huge repercussion which the data owner may have. So there is a huge opportunity for working on more solutions on the privacy area. And as I said that there is a lot of data which is being generated. So we need to develop AI tools which can take care of these things as well. The last thing is the implementation reality. So whenever you implement any AI solution, and if that disrupts the workflow which a company has, chances are that you will be able to do only pilot and POC. So you'll have to see that how you can integrate your AI solutions in the existing workflows so that it goes for a wider adoption. Because most of the time, from the companies, people who are involved in testing all of these things are the ones who are veterans in the industry. So they do not want their workflows to be disrupted. So that is one of the things which you need to take care of. So in order to leverage those three opportunities, and once you take care of these 5 challenges which we have, I think there is an opportunity to collaborate. And I would say that the way government of India or the people in India have built digital solutions in UPI, Aadhaar, and other data types, I think there is an opportunity to build a bio AI stack in which you can have data from research institutions, because they are doing a lot of research in deep science. I was speaking with Dr. Vinay and Dr. Madhu, and quite impressed with everything which is happening here in CCMB and AIC-CCMB in terms of the research which is happening. So there is an opportunity to build a bio AI stack where we can bring all the deep science data which is coming from these research institutions. There is an opportunity to bring hospital data in the same ecosystem, because that is where actual research is happening on the real patients, either for the clinical trials or in the open space for the regular patients. There is an opportunity for startups to be part of the same ecosystem so that they can test their products to see whether it is translating that deep science into the realities on the ground or not. There is an opportunity for hyperscalers to provide the cloud and compute solutions so that large and huge volume of data can be processed once we bring this in the real world. And then there is an opportunity for government to be part of that ecosystem so that they can build the policies which supports this entire innovation which is happening. So I think there is a good opportunity to build this bio AI stack, and I would say that Telangana is well positioned, because I was speaking with Dr. Madhu and Dr. Vinay, and they were saying there are 48 research institutions, there are 20 plus incubators, right? There are a lot of pharma manufacturing which is happening here, right? If you look in terms of overall India, 50% of export in pharma is happening from here. 1/3 world vaccine is being produced here. We have got Genome Valley, which is the largest wet lab plug and play facility. We have got medical devices park. We have got all these research institutions very nearby, like CCMB is there. Then we have got ICR, National Institute of Nutrition. We have got Center for DNA fingerprinting. So many research institutions they are in there, right? So I think Telangana has that rich ecosystem in order to build this bio stack and then scale it at national and international level. So I would like to close by saying that future of global healthcare that will be shaped by countries that combine innovation, execution and storytelling. India can and should lead the future. So thank you so much, and thanks for giving me opportunity to speak at this August gathering. Thank you.
Thank you, Mr. Sarvesh. I now invite Dr. Vinay Nandikuri on stage to felicitate Mr. Sarvesh Singh with a memento. Oh, you. Okay, Dr. Madhu. Sorry. I now invite Dr. Udaya Dintyala, the chairman of Cognitive Biotech, to the stage for his address. At Cognitive Biotech, Mr. Dintyala develops specialized e-learning solutions using the power of advanced AI technologies for children with autism spectrum disorder. Thank you, Doctor.
Previous slide is there. This is the starting slide, and third one is video. Be here in case the video doesn't play. You can help. Do you have a mic or I speak? Nice one.
You can use changing slides.
That's fine, thank you. Good morning, everybody. I hope you are able to hear me well. Yeah, good. Are you able to hear me? Okay. Yeah. My name is Uday Kumar Dinchala, and before I'm a technologist or a head of AT&T India operations at a point of time, worked a lot in AI. I am also a father of a person with autism. I don't know how many of you know about autism. Autism affects the kids in the early age so that their communication ability gets impaired, and later on that foundation deficiency leads them to be dependent on the society for a longer time. So he's my son, Ram Dinchala. Today, this guy is a taxpayer. He works for Capgemini. Earlier, he worked for Amazon. And his final year startup is, final year project is how to use AI for autism intervention. Okay. I'm also part of the Global Health X, which is a global health tech venture studio formed with a lot of doctors to democratize healthcare. Dr. Ravindranath Kancharla of Global Hospital does it. After my retirement from AT&T, I fully focus on it without any profit motive and trying to do the right thing. In the next 15-20 minutes, I'm going to take you through the theme of how you can connect a problem which affects every human being to AI and a little bit of quantum computing at a later point of time so that the young minds here can use it. Also, the older people can give me suggestions how we can do better for the world and for the country. So as I talked about it, if you see the continuum here, it starts with early intervention at a very young age on the left-hand side. And then it goes on to do a whole lot of therapy between a therapy center and the parent. They keep on moving. Imagine a kid got diagnosed with autism, and he stays in Siddipet or Karimnagar, the experts may not be there. So he keeps on moving between the therapy center and the home, aided by parents, and a lot of therapy is given, and it costs a lot of money. In developed countries, it costs anywhere up to $100,000 to $300,000 a year, and India up to 3 lakh to 4 lakh rupees a year. And if you don't do the early intervention, these guys will be dependent on you for lifelong. We went through this cycle. My wife left her job and stayed with him, though he's an IT professional. I continued to earn money for the family because we need to support. At the end of the day, I can guarantee you one thing. Just like if you run every day morning, you become slim. If you do early intervention, trust me, the kids will be much more focused. They can deliver excellent value for the globe. You know Elon Musk by any chance? Have you heard about him? He's a little bit of autistic. Bill Gates, little bit of autistic. Thomas Alva Edison is autistic. In fact, his school teacher told him he's stupid actually. So you need to have a little bit of a faith on these guys. If you do proper early intervention, it does not rocket science. You can do a lot of things. So what we did in cognitive biotics is, because the theme of the conference is how AI can be leveraged. On one hand, you have artificial intelligence and quantum, etc. On the right side of the equation, you have a poor person suffering with something in India or anywhere in the globe. How do you match these two aspects is the story I'm going to talk about today. So that we can do more such things. I saw excellent startups outside. We will be happy to support them. Some of them, actually, I already told our group, they may take a closer look at the startups which are exhibited outside so that we can do a lot of things. Because we owe it to the planet, gentlemen. Knowing AI is not great. Knowing genetics is not great. Knowing quantum is not great. Making some poor person feel happy, a parent sleep in the night is very important. Like the way I sleep well in the night because of my son has done better, I can contributing back to the society. We have a lot of such parents we need to help. That's the theme with which AI has to be approached actually. Yes, there will be challenges. We'll talk about it. So what we did is a gamified learning system, because gamification is the best way to learn anything actually. Powered by AI, enables personalized and evidence-based therapy. We've submitted research papers and all which we talked about. I'll play a short video here.
Across the globe, the rise in neurodiverse conditions like autism, developmental delay, and intellectual disability has outpaced the number of trained therapists. This mismatch places a heavy burden on families and therapy centers. Introducing Cognitive Botics, an AI-powered digital learning platform designed to support neurodiverse children and empower their caregivers through therapy at home. Like this young kid on the spectrum who enrolled for therapy at NEPID. With Cognitive Botics, she progressed from simple attending lessons to complex problem-solving tasks. Even her parents attest to her being more engaging and responsive.
All those things. So based on the program, she's improving day by day.
Just like them, many other parents have shared how they've seen remarkable changes in their children's behavior, improvements in focus, communication, and even how quickly they're picking up new skills. Even therapists have noticed changes in their children who consistently use Cognitive Botics. At its heart, Cognitive Botics brings parents into the therapy process. Through co-viewing, families participate in sessions, enhancing connection and continuity. The Parent Corner provides training, tips, and guidance, while the Child Corner offers structured learning through gamified content, augmenting and assisting therapists and parents alike. With customizable individual learning plans, AI-based pose and gaze tracking, speech recognition, interactive animation AI games, and real-time progress reports, Cognitive Botics is transforming access to therapy, anywhere, anytime. At Cognitive Botics, we're transforming autism therapy with clinically validated, AI-powered solutions. Endorsed by institutions like NEPID and selected by the India UK Health Tech Accelerator, our work is backed by research and peer-reviewed science. With a passionate team of clinicians, technologists, and therapists, we're creating personalized digital therapies that deliver measurable progress for every child. Overall, Cognitive Botics is on a mission to address the critical factors of anywhere, anytime accessibility, unbiased and equitable learning opportunities, time saving for both parents and therapists, an increased reach to serve a global community, structured digital content for effective teaching, and comprehensive progress measurement. Come, join us today, and let's make your child's therapy more effective at home.
So, one of the core concept is using the product so that the parents with non-English speaking skills like Telugu or Arabic or Spanish or anybody should be able to use the product. So we made the product in multiple languages and we can make new languages as well. You'll not be surprised to know that in US every 1 in 32 kids have autism, and in California latest figures say 1 in 12. And the kind of money a simple county is equal to a kind of district in India. San Diego County alone spends close to $12 billion a year on autism services and neurodiverse services. America, $465 billion is the total societal economic burden, with 3-year waiting list for therapy. UK, 18 months waiting list for therapy. So this is a beautiful product now currently being tried in UK, Canada, and we'll shortly enter US as well, so that we can make a parent sleep well, which is our Prime Minister Narendra Modi's vision of Vasudhaiva Kutumbakam, or helping the whole globe with the local products actually. It has cutting edge AI stuff because AI for adults is different, AI for kids with autism is different, because you need to build customized speech models to detect. If, for example, if I ask Professor Madhu to say hello, he'll say very easily hello. But if I ask autistic kid to say hello, he may say hello. Or when you are a kid, all of you are kids at certain point of time, right? When your mother said, say mama, what you used to say? You never said mama. You used to say ma, like that. But your mother used to encourage you. She knows that you're coming closer to mama, or you say, Neelu kavali, Neel. Even then your mother used to prod you. That kind of speech detection capabilities we have built using phoneme technology. The poses technology again customized for the kids, and we have done virtual reality, all kind of things, and we have built advanced video analytics models to detect abnormalities when the kid is playing at the home. All these things are woven into the product. It's a very complex technology which goes into, and it is scientifically validated too. This is a AI-driven video analytics product also as an addendum to what we have, and it uses generative AI kind of a technologies, video analytics, to find out the flaws when the kid is playing in the home or going through a therapy, so that we know how he is improving actually. Nobody need to maintain handwritten notes of how the kid is doing. I think I'll ask you one question. If I want to tell you an important concept to you, do you like a kind of a story or a big textbook to you? Obviously a story, right? Today using generative AI, a whole lot of tools are there. It's not new. But we can create a story with your own kid's face. Other day I saw one company trying to sell books actually. You just send your kid's picture. With your kid picture, they make cartoon actually and send you a kind of a printed document actually. So you can show him becoming a doctor, show him becoming an astronaut kind of a thing. We have such product where the autism kid's picture is given, like the way it is given here, sorry. Like this. And this kid with picture, it's able to produce a kind of a thing how you go to school actually. It uses classical generative AI story actually, okay? But it will help the kid to become better, faster and better and cheaper. Needless to say, one of the biggest moat, Dr. Sarvesh talked about it, one of the biggest moat in healthcare industry is you need to fit into the system. Also, it has to have clinical validation. Without clinical validation, I did an MVP, it doesn't work in healthcare world actually. So we went to the cycle. We are registered with KHDA in Middle East. We have Arabic product to the Arabic markets. We have signed an MOU with Government of India, and 1.5 years back we got validated with NIPID in India. Our papers of 12-month studies of improvement in the kids are published in major European journals and presented in major European conferences. And our product is given excellence in healthcare startup, and also NHS UK. NHS is National Health Service, where there's 18 months waiting list for autism therapy. That means, imagine you have a kid with autism. They'll say, hold on. For screening, it's a 6 months, therapy 18 months kind of a story. Okay, by the time you lose your valuable time. Our product is, they felt it very interesting. They selected us. With their money, we went there. Now we are trying to enter the UK market, try to help UK population through and European population too. Long way to go, but a baby steps. I want to thank you. And the last slide I would like to share with you, I'll take a couple of minutes here. On the left-hand side, you see something called mathematics, AI, and quantum in industry and life sciences. I'm very close to education field. I have very keen interest in how do you leverage our young population. Okay, around 20 years back, if you know a little bit of a computer and a Word document and click and drag, you get a job in Hyderabad, IT, you make some money, right? But today it's a different world altogether actually. They expect you to know many more things actually. The brains are great brains we have, beautiful brains in India. It's very important to find out how engineering and life sciences in each area, civil engineering to biotech, they can use an AI algorithm or a quantum algorithm or a mathematics behind it to deliver value. Normally what happens is some American company or European company have a beautiful idea in life sciences or engineering, and they will come with something, then they will put a center here. Our guys will work on technology to solve it. I think we are entering an era, with high respect to all of you, I feel we are entering an era where we need to use our young brains to give them more challenges, like the way AIC Madhu Garu, I know a lot of good people are there here, youngsters. We need to tell him how these 4 different lanes, mathematics lane, AI lane, quantum lane, and a real engineering and life sciences lane, all these 4 will come together to solve a $1 billion problem. So this book, I just wrote it when I was in US for 2 months doing something, and hotels you have plenty of time. If anybody want to have a copy of this 160-page book, it's a draft still, but it has a lot of what are the 10 top algorithms in quantum and top 10 algorithms in AI and top 10 mathematical equations behind them, and then how they will be used in civil engineering, mechanical engineering, biotech, life sciences. You want to have that one, a copy of it at a lucid level, let me know. I'll be more than happy to send you. Here is my email address. Number 2, I also represent Global Health X. I'm a director on the board. We do a venture studio in Hyderabad. We do support. And any of your startups have something, you can always send on Global Health X website, not to me personally, because I don't do work full time there actually. Yeah. This is with this thought process, I would like to conclude. I thank Madhu Garu for inviting me. How AI can be used to help a parent in the remote areas, as well as leave with a thought that, trust me, with our young minds, if we give the right problem to solve, they'll make tons of money for India, and it'll be a great thing. Thank you very much.
Thank you, Dr. Uday. I invite Dr. Madhu to felicitate our speaker.
Thank you, sir. And I'm running the
Yep. Thank you for your patience. So our next speaker, Mr. Paneer Selvam, has been. He'll be coming at 3 o'clock, so we'll have his address then. For now, we'll move on to the next session. The first theme is infrastructure, compute, cloud, and sovereign platforms. Just a quick note that each talk will be for 20 minutes, followed by 10 minutes of audience Q&A. So we'll have plenty of time for questions and discussions from you guys. Our first speaker is Dr. Vinod Jani. He's the Scientist F at Center for Development of Advanced Computing, CDAC. He'll be delivering his talk on ICE, which is the Integrated Computing Environment, which is a scientific cloud for life science. Please, Dr. Vinod.
Scale to play. Yeah. Click it. Change. Change. All right. ठीक है उधर आ रहा है फिर से बंद करके चालू करो नीचे
So good morning everyone. I would like to thank the CCMB team for inviting me over here and to give a presentation. So I would be talking about ICE. So it's an integrated computing environment. It's a scientific cloud. What we have developed completely indigenous at CDAC Pune. So I come from CDAC. It's a government body under Ministry of IT and Information Technology. So before going into the ICE, so I would be like to give a glimpse of the activities what we do at CDAC in bioinformatics group at CDAC. So CDAC is basically known for its HPC, high performance computing clusters, but a lot of research is being done at CDAC. So we at the bioinformatics, bioinformatics group at CDAC, what we do, so we are managing a dedicated HPC facility called as BRAF since last 15 years. So it's a HPC facility which we give completely free to academics for running their genomics, molecular modeling, simulations, all the jobs. So it's a completely free for the academic, these clusters. We do a lot of research in the area of computational genomics, specifically in the mycobacterium genomics, cancer multiomics, population genomics, metagenomics, and antimicrobial resistance. So we develop. So we are completely in silico labs. So we collaborate with the hospitals, with the academic institutes to get the data, and we work in the collaboration with them to help them to analyze the data. And plus we work on the open source data which is available for the various research in the computational genomics. We have a very strong team in the molecular modeling. So there, whatever studies through the computational genomics, whatever we try to identify, what are the mutation, variants, we try to map this mutation variants on the structures, and we try to map the complete picture. So whatever is happening in your genomics, how it is mapping to the structure, and how it is affecting the binding of the drug. So for example, if we are talking about the antimicrobial resistance, so suppose there is a mutation because of which the drug is because of which the pathogen has become an escape pathogen. So what are these mutations? We try to map on the structures, and we try to look at how that is affecting the binding of the antibiotic to that particular protein also. And we have a very strong software development team. So along with this whatever research we are doing, so in order to map it to the HPC, because when you are analyzing genome level, population level genomics data, or when you want to do simulations, so you need HPC level, so the softwares which can work on this HPC. So along with this software development team, we develop softwares, we deploy on this, and we make it available for the academic user at free of cost. Now, why we have developed ICE integrated computing environment? So, so all of you might be aware that initially when this NGS was recently came, so it was very costly to do the genomics. But now with the advancement in the technology, you are able to generate vast amount of genomics data. Now each of you might be generating the data, or each of these academic labs are generating the data, but that data remains at their end. Okay, so it's because it becomes difficult to share the genomics data with different labs, because the data which is generated from these genomic sequencing studies, so that's in GBs or TBs. So that is one of the major issue. Fragmented genomics data. So suppose if there are around 5 labs which are in India, you can see that many labs are working on this mycobacterium or cancer genomics. But each of these labs are working in their own institutes. Whatever data they are having, that remains at their own institute. If you think of a centralized repository for India only, if you think of such a repository, so that data can be made available to all of you. So many people, other people who cannot generate the data but can make use of that data. So that is the major challenge, another challenge. The same is with when you are talking about this genomics data, structure data also, and this lies in the agriculture also, medicine also, and environmental science also. So this same applies to this data also. And second thing, when you are working on this huge amount of data, so the biggest issue is the tools and the database, where to store the data, and what are the tools which we can use, and how we can make the inferencing. Because most of the wet lab people or experimental people or startups, or they feel that they don't want to take a headache of storing the data, because when you are having an infrastructure at your end, it becomes very difficult to manage that infrastructure, because it adds to the computational cost, electricity cost, cooling cost, and you need have a bigger area. So they try to avoid that things. So keeping all this in mind, so what are the challenges? So I told you that setting up a server is a high investment. Secondly, if you have a server, if you go home and if you want to access because of the security reason or some other reasons, you are not able to access that from outside the institutes. Another thing, suppose if I take an example, so suppose there is there is a startup which has around 10 people, okay, and if they are generating a data, a particular sort of data which is in the GBs, and suppose they are working at the different places. Suppose one is working in the Kolkata, so they have formed a team and they have started one startup. So suppose one is working in the Kolkata, another is working in the Delhi, another is working in the Hyderabad. Now if the Kolkata person is generating the data that is in the GB, and if he want to share with the Pune and Hyderabad person, so it becomes very much difficult for him, because he has to upload the data, he has to share the data, another person has to download that data on his local machine and he has to do the analysis. But in order to avoid this, this computing solution, what I will be going through in the next slides. So how we have taken care of this thing, I will be talking about thing. Another thing is the software installation. The cloud platform which I am going to talk about, you can install your software, means already there are preloaded softwares. Just by one click, that software is made available to you and you can directly use that software. And another thing is redundant downloading of bioinformatics data. Generally, whenever we do the genomics or any other studies, we do a comparative study with the already available data. Okay, so every time if lab A is working, they download the data. Lab B is working, they download the data. So can we have a centralized repository where you have your own data plus these databases, so you can do a direct comparison. So taking all this into the mind, we have developed this integrated computing environment. So it is a scientific cloud. So it's a the Atmanirbhar Bharat, it's a completely indigenous solutions which has been developed from the scratch at CDAC, Pune. So it's a most important thing when we talk with the hospitals or clinicians. They are very much afraid of sharing their data because of the security reasons, and if the data get lost and all that things. So we have taken that into the consideration to make it very secure and scalable also. So suppose today you are require only around 10 cores or around 20 GB of RAM for your work. But tomorrow if you want more number of CPUs or more number of more RAM, so that also we have taken into the consideration. And it provides a single stop solution where you can have your data, where you can do the computation of your data, where you can do the inferencing of your data, where you can do the visualization of the data, and upon that if you have all this together, if you want your website to be hosted, you can host that website also on this platform. And it provides ease of access, so you can access this platform from your institution laptop or desktop, from your home, from your computer, mobile also you can access this thing, and you can submit your jobs through mobile also. So suppose if you are at work and if you are traveling also, you can do whatever research you want to do, or you can look at the data which has been generated by your collaborator. So it's a simple and user-friendly interface. It's a unified platform for the secure storage, analysis and visualization. It supports both genomics and structural data. So you can do the analysis of both genomics as well as the structural data. And where AI related tools also we have currently on these things. We have the pipelines also, advanced bioinformatics pipeline. So generally, whenever you are analyzing the bioinformatics data, it's you have to run multiple tools. It's not a single tool. So we have made a pipeline, entire pipeline. You have to just upload your data and do a single click. So 10 or 20 tools, whatever are there, they run in the synchronous fashion, and you get finally your output, and you can visualize that output. Multi-part upload. So I was talking about the upload of the file. So hundreds of GBs of files can be uploaded. So we are following this S3 protocol. So here your file gets divided into the chunks and it gets faster upload. That thing is that, so GBs of files can be uploaded in a very faster time. Simple interface for compute requisition. So suppose today you require around 5 CPUs, tomorrow you require more CPUs, so you can request for more CPUs also. Control file share access, I will be talking about this, and hosting of tools and website also. So these are the features. I will be going on each of them one by one. So storage, container repository, virtual hosting, compute development platform, AI platform also we have, sharing and collaboration, pipeline, and HPC acceleration. So first I will be talking about the storage, what the storage provides. Now share and collaborate. So I told you about that. If you have a team of around 10 people, and if one is generating the data, and if he wants to share the data with the rest of the 9 people, with single click he can share the data. That thing. Just he has to upload the data. Once the data is, so as the data gets uploaded through multi-part file upload, the data gets uploaded in a very faster manner, and he can share the data with 9 of these collaborators just by right click, and the data would be available to all the 9 users. The data is it's a secure storage, data encryption and rest. We follow at rest and transit, and along with that you can have a tagging also. So metadata along with this data you can have, so it makes the data searchable easy. Now this so it's a ICE Cloud. So URL is icecloud.in. So you can log in. So when you log in, you will find that there is a storage page. So you will be having here 3 drives: My Drive, Shared Drive, and Public Drive. This is your personal drive where you can upload all your data, and it remains to you only. Whatever data you upload, it will remain to you, and nobody is able to see that data. And this is the shared drive where suppose you have uploaded suppose your partner has uploaded data and he has shared with you, so that data will be available into this. So suppose if your partner has uploaded the data in the My Drive, and he will right clicks and shares with you, so that data becomes available to you within fractions of seconds. and there is no need to download. You can directly start working on this data on this platform itself. And there is a public drive which hosts all sorts of databases which are present, so like NR databases or whatever databases there. So all public database we are hosting over here in this day. So you can make use of that database also, no need to download. Everything is available on this thing. Just you have to log in and start working on this thing. I will be talking about this container repository, the next thing, important thing. So the software installation, so that's a big headache for most of you. So what happens if you want to install the software, it takes around, suppose sometimes it gets installed in 1 day, or sometimes it takes around week also to install a software. So what we have done, we have made a container repository already available, and almost all the softwares which are required for the bioinformatics analysis, you can see that they are available on this container repository. You have to just click on this play button, and that software becomes available to you, and you can start doing analysis for your things. So we have all the genomics related software, we have quantum related softwares, we have AI related softwares, all the softwares. If you want a programming platform, we have options for that also. So all the things are available in this ICE container repository. So that is this thing. So just you have to go on this image when you log in, and there you can see all the possible images. So these are Dockerized image. So we have from quantum to structure related thing to genomics, AI, and all the libraries available over here. Now I was talking about this dynamic compute provisioning. So here what you can do, so just I will tell you an example. So suppose if you want to run an image or a software in the sense. Now suppose if you know that my software will require only 5 processors and around 10 GB of this. So when you load that container, here you can do the CPU allocation. So it's a dynamic thing. So here you can give 2 to 5, 10, whatever means how much your software is going to require the number of CPUs. So you can provide over here, and how much GB of RAM it is going to take. So you can provide over here. If it is GPU enabled, so you can provide here GPU. So, and just you have to click. So that environment will be available to you, and that you can run that software. So, and another important thing is the pipeline thing. So I will, so in the bioinformatics you have multiple tools. So I already told about things. So we have enough core pipeline that we have made available for various tools. So you have to just upload the data. You can see that so many tools are there. So you do not worry about these things. So all of these are connected one by one. You have to upload your data, and you will get final output over here. And that too you can visualize on this platform. Virtual hosting, this is the most common thing most of the startups require. So if you have your content for your website ready, you can host your website within half an hour using this ICE Cloud platform. So we have already means domain name and all the things are taken care over here, and you can get these things. So for some of these startups already we have hosted the websites, and within half an hour it was at the backend you can connect to the databases also, and whatever data you have you can store in that databases also. AI empowered these things. We have these images for various Jupyter notebooks. So all the libraries which are required for this are already present in these things. And what it helps, because suppose today if you are using any of these libraries, tomorrow if your Python gets upgraded, so you face the issues that the data, the results are not reproducible. So here you can have a version for each of them, and because of this your data would be reproducible. So science requires that thing, reproducibility of the science. Another thing is the personalized AI environment. So most of you are using AI or ChatGPT and these tools, but most of the time if you are generating a code out of it, or you are debugging your code out of it, it becomes an open platform. So that code is available to anyone. But if you want that to be secure, so using this ICE Cloud, you can have your own personalized ChatGPT-like environment, and whatever you will do over here, it will remain to you only. It will not go into the outside platform. So that's the beauty of this ICE platform. So here just how you can load these things. So just you have to do the launch. You can give the memory and CPU over here, and you have to create the container. Okay, so your container is created. You have to just click on that password, because that is a control access, and you have to paste and log in. So it's available to you. Now you can start working over here. So currently we are providing, working on this ICE virtual labs. Virtual hosting is completely done. AI tools already CPU and GPU enabled. We have made LLMs along with the LLMS models on this platform. We are providing database as a service, resource and billings also. So currently we are giving at very subsidized rates to startups, and for the academics it's completely free. And we are working on this HPC support also. So you can have, suppose if your job is running on multiple nodes, so that's also we are allowing using this ICE lab. So, and we have followed all the security protocols along with the two-factor authentications. So for storage of the data, for the life science researchers, for computational biology, for biotech industries, so all these people can use this ICE platform. So why this ICE platform was required? Because all you can see that each of these countries, Broad Institute or UK, or they all have their own personalized biobanks for their own country, where they store their own data. As Sarvesh sir was talking about the indigenous data, because I will just take you through one, I will talk about if time permits on the NSM. So just I will take a couple of minutes. So you all might be knowing about the pharmacogenomics. So here the biggest issue is that whatever drugs are being developed, they are developed based on the US or European markets or the data present over there. Now in one of the research, what we observed that, so these pharmacogenes, what are the pharmacogenes? Just to tell you that pharmacogenes are the genes which are responsible for the metabolism of that drug. Okay, so there are two alleles for that particular gene. If one of these allele get mutated, so the metabolism of the rate of that drug get disturbed. Now what we found that there is a one famous drug, warfarin, that is required for the blood pressure. So there we took this open source data of Indian population in the 1000 kb. So that is Gujarati in Houston and Indian Telugu in UK. And we've tried to study the various pharmacogenes. And there what we observed that one of the gene which is responsible for the metabolism of the this warfarin drug was mutated. Okay, because of that, what it leads to understand that because of that mutation, whatever drug doses is being given in the European market should not be given to the Indian population also. The dosage required is lower in the Indian population. So this sort of studies also you can do using this ICE platform. And at the back end, we have this bigger supercomputers like Param Siddhi. It's completely dedicated for AI. Param Airavat, that is also completely dedicated for the AI related things. So it have it's around 410 AI petaflops. So you can think of how much big. So it's one of the fastest in the India, and you can get access to it just by typing at NSM India. So these are the acknowledgement, and this is the team behind the development of the entire ICE, and you can access the ICE at icecloud.in. So it's you can just create your account. All the video tutorials are available over there. Thank you. I'm ready to take questions.
Does anyone have any questions?
First of all, I really want to compliment you for the kind of things you put together, because often people miss is we stop at bioinformatics level, but you went into such a deep level of devising what tools are there and what kind of tools are there, what kind of things can be done, and all that stuff is great, phenomenal. And that too for a startup in lowest cost. We'd like to connect with you,
Okay.
because we want to do such kind of things. We have a lot of connection to the hospitals actually,
Okay.
and really appreciate. It's eye-opener for me.
Okay. Thank you very much.
Hi, I'm Dr. Kishore. I'm representing Pulse Pharma.
Okay.
We do a lot of MD simulation studies and docking studies. So can we do all those things in your platform?
Yes. We have two platforms. One is this ICE Cloud, and along with that we have another computing facility which we call as a BRAF. So there already we are using this platform for doing simulations and docking studies. So already we have tools for the quantum level studies, quantum chemicals level studies also, for the docking studies also, and for the simulations also on this platform.
We will be very happy to connect with you.
Oh,
Thank you so
Thank
much.
I'm Dr. Amresh from Nizam's Institute of Medical Sciences. Congratulations, such beautiful work. We are so proud of it. Incidentally, we did a lot of work on warfarin pharmacogenomics as well, and we've got personalized equations for dose estimations as well. We would like to extend that to other drugs as well, especially blood thinners and our transplant programs as well. So how does it work? Like, as a teaching institute, can I just,
No, for that genomics data is required actually.
no, how to use your facility? Because we would
So
like...
yes, you have to just, as I already told about this thing, this is the URL, you have to just go on this URL and you have to register yourself.
Okay.
It's available to you. So all the tools and all the pipelines are available to you, you can start using.
Oh, that's
and if
it?
you, yes, that's it.
Wow, sounds almost too good to be true.
So it's true, I can show you the demo also.
So, because we do generate a lot of genomic data, we do generate a lot of data on the drugs as well. Of course, we are not so familiar with the computing type end, but I think we can always get some help and collaborate.
Yes,
with someone.
definitely we can connect because we have HPC facility at a backend also. So it helps to analyze the data at a very faster rate. Okay, so we can analyze multiple of genomics data together at one go.
Just a small suggestion for guys like me. Maybe you should have a small social platform where you say that I have this problem and I need help with people who can help me with that. Or, as someone say, this is my expertise for help and I need to connect people like that. Maybe it
Yes,
might also
definitely we will add to it. Thank you for your suggestion.
Hello, sir. My name is Jaya Bharadwaj. I'm from Jolly AI. We are an AI startup. So, sir, we have used Airavat platform and we've trained few of our models and it's a really helpful platform. Now, my question is like how, like you mentioned about the on-cloud databases and so we are currently using AWS or like we switched to self-hosting now. So how does the pricing work, or can startups like directly start using like PostgreSQL or these services?
So you can just log in onto this and start using it. So initially we are giving it at free of cost, so you can start using it. If you find useful and if you want long-term association, we can have a talk on pricing also, but it's negligible pricing. Okay. So for startups, because being the government initiative, so it's a completely, it's a negligible cost only.
Okay. Thank you, sir.
Do you plan to be a repository for some of the major initiatives such as the 10,000 genome project and so on?
Yeah, actually we are already connected with that. So this platform, whatever we have developed, so a part of this software has been already installed at IBDC Faridabad where they are going to host that 10,000 genome data. Yeah. So we are already part of that thing.
Okay, you're part of it. Thank you.
Yeah, hi. Yeah, hi. My name is Ramchandra. So I have the same question as like we are startup with the AI. So what is the prices that you suffered? Because AWS giving a bomb for us, getting the model trained and everything going on. So I see it is very advantageous for us. Bear with me, my tone is having a small impact. And one more thing, like we are working on the phase part of the genomics data, and we are creating a platform for the phase match and phase treatment. So can we consume already existing genomic data which you already have so that we can train the models?
So we are also currently, we are not generating any sort of a data. We are relying on the open source data, or we are working with in collaboration with the hospitals or academic institutes.
Okay.
So if you have your own data, you can use that. And if you require any help if you have any other collaborator who is having that data, we can host that data over here, and you can use that data for your training your model and inferencing.
Okay, thank you.
Thank you. Great talk and really nice to know about you. I'm Annapurna. I'm representing BFI, Blockchain for Impact. So we're a philanthropic organization that is trying to support biomedical innovation. So it's great to know that such a platform exists. And on point of someone mentioned here, I think Sir from NIMS mentioned that there should be a platform where such initiatives should be publicized. So towards that, I want to mention that BFI is building something called as Interconnect, which is an application and a web platform where people building innovations and building solutions for biomedical innovation can come together and talk about potential collaborations. So do check that out. After that short self-promotion, my question to you is, currently all the things that you've built are based on LLMs and deep learning, I'm assuming. Do you also plan to get into other types of AI tools? Maybe small language models or agentic?
So it's if you have your own software solution also, you can host over here. So that's a flexibility provided over here. So some of the things we have already hosted it, and if you have something, you can also host it over here. So it's completely free over there. You can, if you have your tool, you can make it Dockerized, and you can deposit to this hub repository. If you want it to restrict to use for your company only, that is also possible. And if you want to make it at open, you can do that thing. Both things are available over here.
That's great. Thank you.
Yes.
Hello. Yeah, thank you so much. Fantastic information. I'm Rupal Mehta from MedMarvel Solutions. We're based in Pune as well and working on precision brain diagnostics. My question to you would be that, this is fantastic when we're starting as a startup. We are a startup. We would like to train our models and build it for the Indian population and all. But however, when we plan to, expand to other geographies, and want to do a collaborative projects, is that allowed, or what are the nuances for that? If you can just brief on that as well.
So it's available all across the world except China. So you can upload the data and everything can be done from remote locations also. No issues.
Okay, so it's allowed to do on this
collaborative research you can do over there.
Collaborative research, but how about in the commercial setup as well? Like once we are launching the products globally,
okay.
So then could we still continue to host and?
Yes, you can continue to host, but there would be some pricing related things, and that would be a negligible cost again.
Okay, so that's fine. Okay, thank you so much.
Thank you so much for all your questions. We need to move on with the next talk now. I invite Mrs. Ritika Marumpalli to felicitate our speaker.
Mr. Vinod, I think everybody wants to know what is that negligible.
So currently, sir, it's a free of cost, so we are not charging anything. And in future,
Is it? Yeah. Okay. Next, I invite Mr. Sainath Bandkavi. He's the head of solutions architecture for healthcare and life sciences at AWS. He's going to deliver his talk on architecting AI solutions for clinical workflows.
Yeah, just a minute. USB adapter. Okay, morning everyone. I hope you all can hear me now. Am I audible? Okay, sure. First of all, thank you for giving me this opportunity to talk about what as AWS we are doing in healthcare and life sciences domain. And for the next 20-25 minutes, I'll quickly talk about AWS in healthcare, and then I'll talk about how data and AI is helping organizations, or how it can be leveraged to deliver outcomes. So quickly, AWS, we have been the most comprehensive and broadest cloud platform for over 18 years, 19 years now. And specifically in healthcare and life sciences practice, it's been there for almost 9 years now. And the leadership team across the healthcare team have an average of 18 plus years of experience. So what we're trying to say is that, a combination of tech and domain expertise is what is actually helping us have more domain-oriented conversations or domain-oriented solutions to organizations in this particular domain. And apart from this, there are also purpose-built services which are meant for the healthcare domain. Like, you could see some of those on the right-hand side. It could be around comprehend medical, which helps analyze the sentiment, and it also helps transcribe and transcribe medical, which can actually help transcribe the, say, a patient and a doctor conversation. Similarly, AWS Healthcare, which is actually a FHIR compliant data lake, which can handle database structures which are more aligned to, say, what could be the attributes of a practitioner, what could be the attributes of a patient, similarly of institution. So these are some of the purpose-built services which are also available on AWS. And we have more than 200 plus services in AWS, and many of you might be knowing, and it could include compute, database, IoT, AI/ML, analytics, dashboarding. So quite a few services. Out of those 200 plus services, more than 146 services are HIPAA eligible services, which can actually help build solutions which are more healthcare oriented and comply to the regulations. And more than 143 global compliance requirements, which could be HIPAA again, it could be GDPR, it could be certifications from HITRUST or ISO, and also India specific requirements where it is needed. And we work with organizations across the spectrum, starting from the point of care at hospitals to central and state level government organizations. We also work with a lot of private hospitals. We also work with organizations who are startups or ISVs who are building solutions for the healthcare organizations. Similarly, we also work with a lot of non-profit organizations who are again delivering services for the healthcare industry. And one of the reasons why, or some of the reasons why these organizations are using AWS is, one, in terms of scalability, right? I mean, you start with a small volume today, and over time you grow to handle large volumes. It could be, starting from a few MBs or GBs of data going into petabytes of data. And especially when we talk about genomics, the data volumes run into petabytes, right? So that is where you actually need that scalability on demand as and when you grow. Second, in terms of flexibility, when I say flexibility, it could be usage of different kind of services. It could be plain compute, it could be plain database, it could be a different kind of AI models that you want to develop, or you want to use readily available AI models. So there is flexibility to run or use these operations on or services on AWS. So this is quickly about what we are doing in the healthcare and life sciences domain as AWS. Before I move on to the AI topic, one question for the audience. Have you all heard of Sustainability Development Goals? Okay. So which particular Sustainability Development Goal is related to healthcare? Or probably name of that goal? Yes. So SDG 3, which is good health and well-being, is the sustainability development goal which is related to healthcare domain. And the reason I brought this up is that as a country, there is a common purpose that all of us are working towards. All the research that we do, all the solutions that we develop, all the work that is being done is aligned with a common purpose because we want to improve in those specific indicators which are part of SDG 3. Right? And if we have to look at some of these indicators, it could be maternal mortality rate, it could be neonatal mortality rate, it could be life expectancy of birth. So these are some of the, these are not all the indicators, but these are some of the indicators that we as a country are focusing to improve on. Right? Have we achieved the objective? No, not yet. But as per the latest report, we are on track to achieve these. Right? If you take the example of, say, maternal mortality rate, we are at 80 now, but a long-term objective is to be at what? To be at 3.4. Similarly, neonatal infant mortality rate is at around 17, and long-term objective is to be at 1. Right? So the point I'm trying to make is that if we have to achieve this, there is a lot of process improvement that we have to do, a lot of innovation that we'll have to do, and at the same time, the core lever that we all have to use is around data and AI, right? And coming to that, as per a research, only 3% of the data is actually used that we have available. So when we have 3%, that means, it is vast amount of data that we have, right? It could be data from clinical trials, it could be the genomics data, it could be the, diagnosis data, it could be the MRIs or ultrascans, or the variables data, right? There is huge amount of data which is available, but apparently as per this study, 97% of this data is going unused. And at the same time, another perspective is 32% of the organizations are actually able to help realize value out of this data, right? But what about the remaining 97% of the data or the 68% of the organizations which are not able to realize the value of this data, right? So that is where AI comes into picture on how do we capture that data, bring it into a place, and then use AI to build some outcomes out of it or derive some insights out of it, right? So talking about AI, we don't directly do AI, right? Before we do AI, there is a data foundation that needs to be built. So unless you have the right data foundation, you may not be able to deliver the full outcomes of a AI model that you build or the AI model that you use, which is readily available. And when we talk about data foundation, we could probably categorize it into broadly 3 areas. One is it comprehensive. When I say comprehensive, it should be able to handle multimodal data. So when we say multimodal data, we have data in, say, plain text, it could be videos, it could be images, it could be, say, PDF documents, it could be actual databases with, say, tables and, columns and rows. So it should be able to handle the data which is comprehensive enough and obviously open and interoperable, right? So that is where you can actually mix these multiple data sets to build the AI that you actually want. So if you build an AI solution which actually analyzes only image data and a separate AI solution which can analyze only the text data, but there has to be a layer which will actually bring these 2 data sets together and help you federate the analysis, right? And that is where we talk about integrated kind of a data management which you can help you integrate data sets across multi-models, and at the same time, getting data from multiple data sets. Again, it could be a PACS system in a hospital, it could be a health management information system in a hospital. Similarly, there are various other applications which are available. So integrating through open adapters with these systems is something which is also needed. Third, govern. So obviously, security, compliance is an important aspect, right? So how do we handle the governance layer on top of this data? How do we define who can access what data sets? Similarly, if we talk about research institute, you have a lot of data. And some of the research institutes want also to make this data available in a public domain. Do you put it as it is? No, right? You anonymize it, you subset it, and then you put it on a public domain. So how do you handle those governance layers or governance mechanisms to say that this part of the data is to be available only to these people or in a public domain. And in AWS we help provide these services which could actually help you create this comprehensive multimodal data repositories or a data lake, and also different mechanisms to integrate with different EHRs or different systems using it could be API based integration, it could be a queue based integration, it could be a file based integration, and a governance layer which could be around security, encryption, defining guardrails on your large language models. It could be different ways of defining that. And this could be another way of looking at it. How do we enable interoperability and scalability? You have different kinds of data sets with multimodal. How do you bring all this together into a single pane of glass and then do different kinds of AI on top of it? It could be tracking disease progression, or it could be models to detect disease early, or develop medicines faster. Right? And these are some of the services which are available from AWS. If you look at omics data, there is a service called Health Omics. For imaging, there is something called Health Imaging. Similarly, data lake, which could be a plain data lake, or it could be a health lake. Like I mentioned, it is FHIR compliant and also ABDM compliant. And on top of this is what you run different kinds of transformations in terms of getting the data sets that you want to use to run AI. Right? And when I say AI, there could be different ways of running it on cloud or on AWS. One is you have the data, you want to build your own models, AI models. So it could be a image recognition model, right? Or it could be a language model. When I say language model, it could be a multilingual model that you want to run, right? Or it could also be that you want to build your own models, but you want to take an open source model and then you want to fine tune it, right? So if you want that the infrastructure level, then you can run that on AWS. If you want to run it on a managed environment, you can use services like SageMaker to fine tune the models. And organizations also use it to build small language models or large language models which is again used to analyze the data that you're gathering. Third is, I'm sure all of you heard about generative AI, right? Yes? Okay. So generative AI, again, like I said, one way is you want to build your own large language models or small language models suiting to a specific requirement. And at the same time, there are quite a few large language models which are already available in, which are developed by organizations like, it could be Anthropic, it could be Meta, it could be OpenAI. So there are a lot of large language models providers who are there, and you can use these large language models also and run analysis or derive insights on the data that you already have through API calls itself, right? So that means you are not really getting into developing new models, but you want to leverage those large language models to analyze the data that you already have, right? So that is also another option that you can use using Amazon Bedrock on AWS. And next point is, if you want to build AI agents, I'll talk about some of the use cases around AI agents as well. So you can build your own AI agent. So like, for example, there could be one agent which is actually getting patient data. There is another agent which is actually doing some image analysis of, say, X-rays, right? I mean, you could use those agents with a supervisor agent and getting multiple data sets and then giving out an output in terms of a summary of a patient's longitudinal journey. Right? So these are the kind of things that you can actually do. So these could be some of the generative AI use cases which are more healthcare oriented. So one could be a clinical notes from ambient listening. It could be a patient and a doctor conversation which is in an audio mode and listened and transcribed into a conversation, and then you get it as a final result that a doctor could just print and give it to the patient, right? Instead of doctor writing it or someone else writing on behalf of the doctor. So it helps remove the administrative burden from the doctors. At the same time, you capture the data which is needed for further analysis that you want to do. Another example could be around, I'm picking a few, I'm not talking about all of this, I'll just pick a few. Like for example, if you want to do analyze patient level and cohort level records to identify risks. So that means there is huge amount of data that you have, right? So in that, how do you create cohorts? So when you say cohorts, it could be an age-based cohort, it could be a gender-based cohort, it could be a location-based cohort. How do you create those cohorts on top of the data and then run the analysis? And here the data volumes are huge. Like I said, it could be terabytes, it could be petabytes, right? I mean, you need that scalable model to run these analysis models on top of this data. Another could be, a self-service care triage, right? I mean, a lot of us, I'll just give an example. I mean, we go to a hospital, doctor gives us a prescription, doctor writes the medicines to use. And 3 days later, you realize that you have misplaced the prescription somewhere. What do you do? Right? I mean, is there an easy way for me as a patient to just probably get into a conversational layer and say that, tell me what were the medicines which were prescribed to me? Or can you just give me a soft copy of the prescription which was given? Right? So it could be a simple conversational AI which is actually using agents to talk to a hospital's HMIS or PACS and giving me the output. Similarly, if you want to take an appointment of a doctor, how easy is it for you to take an appointment? You call up the hospital and you want to take a appointment for internal medicine, right? And you ask the person on the other side, can you tell me which all doctors are available for internal medicine? The person on the other side will probably name 2 doctors and say that, even though there are 10 doctors available in that hospital, right? But if you want that flexibility, then probably a conversational AI or a self-service solution could actually help, which will tell that, these are the doctors who are available, this is their specialization, these are the times that they are available, and then you just do it instead of, trying to talk to a person who's probably not available late in the night and all, right? So these are some of the solutions which could actually help in patient experience as well using AI and agentic AI. Similarly, the last point in terms of data ingestion or data identification, if there is a lot of data related to patients, but if I want to get all the data related to me at different hospitals, how do I get that? Is there a way of getting that? No, right? Because at some hospital I would have given my wife's number, at another hospital I would have given my number, right? So there is something called, record matching that you can also do with some of the ready services that you can use to say that, what is probability of Synapse data in this particular system versus Synapse data in this particular system, right? So a patient record matching kind of ready services also which you can use instead of building your own AI models. Okay, and these are some examples of how you can architect solutions on AWS. This is a simple example of, say, probably creating a discharge summary which could reduce from a few hours to a few minutes, and it creates a draft of the discharge summary, and then the clinician can review it and give it to the patient at the time of discharge. But important point is serverless architecture or event-driven architecture which can actually scale from, say, a few hundred records to a few thousand records, and at the same time keeping cost under consideration, right? So serverless models are actually, they scale as you use and you pay only for what you're using, right? So that's why you're not spending a lot of money even if your usage is very little. Similarly, another use case could be the self-service care triage that I mentioned, that there could be multiple agents which are actually talking to individual systems and then getting the data that the patient actually wants to understand through a conversational AI. So if you look at this, it uses a RAG, it uses different services. It could be a Postgre database, it could be a pharmacy purchases in the hospital that the patient is doing. So each of these agents can actually talk to those particular systems and give the information that a patient would want to have. Okay. So this is more for agentic use cases for life sciences. It could be a research one where there could be a supervisor agent, and then there are sub agents to get different data sets. Like for example, the biomarker database could be a normal relational database in which you have the data which is needed for biomarker discovery. And there could be another one which is more around getting data from imaging. So this is an agent which could be named as a medical imaging expert, which is getting data related to imaging and then analyzing it. And then the supervisor agent actually orchestrates the data integration between these individual agents and gives the final output. Similarly, it could be around clinical development where you'll have to look at multiple aspects around, what are the regulatory rules, what are the recruitment rules, what are the past clinical trials which are done, and then, give a protocol draft to you, which you can use to further fine tune and run some, a plan for your clinical trials. Okay, and over time, with the way industry is going, there would be a proliferation of agents. There could be agents, sub-agents for multiple of this. There could be multiple agents for, say, drug design, biomarker identification. I've already talked about. Clinical trials. I've already talked about. There could be around market research, where it's actually helpful for researchers who are actually, getting into a specific domain and doing research and trying to understand, what kind of patents are already filed, what kind of research is already happening. And at the same time, they can integrate with the knowledge base which is there within the organization, which is not available publicly. Okay. Evaluations and observability. When you run AI, one important aspect is evaluations. Are you getting the output that you are expecting or not? So what kind of evaluation that you do, what kind of observability that you have. So different kind of mechanisms. It could be text to SQL, like, if you use natural language processing, is it doing the right text to SQL kind of a conversion? Yeah. So this could be a steps on which you can move, build a data strategy, and then you could do population health reporting, machine learning and Gen AI, and some of the use cases that earlier speakers also talked about. It could be around, clinical decision support system, or it could be multimodal, including omics and IoT. Yeah. Okay. That was all from my side. Thank you so much. Any questions? Or I'm around for some more time. We can talk offline as well.
It's for questions.
Sure.
So.
Hello. Yeah, hi. Thank you so much for this wonderful session. And AWS being the global infrastructure, my question would be very specific to, you mentioned that the entire application level where your agents can interact directly with the EMRs and other healthcare systems, right? So interoperability. How do you manage that, or are there automated management systems built into AWS which will help with global data interoperability, particularly when I'm dealing with Indian data from a PACS perspective? Your identifiers in India are different compared to identifiers in UK or US, right? And how do you manage the mapping of those identifiers? Does that problem get addressed by AWS, or companies like us will have to map it?
Yes. I'll split it into two parts, ma'am. One is, as AWS, we provide building blocks which can actually help organizations build solutions, right? So when we have to integrate, there could be some integration adapters which are already available. But in some cases, there may not be any integration adapters already available for, say, some of the HR systems, right? So that is where there has to be some customization which has to be done by the organization. Second part is, apart from the building blocks or the services which are available, as AWS, we also create code samples and we put it out on, say, on AWS samples on GitHub or, AWS solutions on GitHub, which is something which is a code base on top of our services which can be taken, and it comes with the source code. So you can actually fine tune it, customize it based on your requirement. And for that matter, in India, we have done quite a few implementations, and in these cases, either the partner system integrators, they do the customization which is needed for, customer specific requirement.
So, sorry, and one last question. Thank you so much for that answer. And so now that we have indigenous, solutions that we saw earlier, from CDAC and now AWS, would AWS be more sensitive about the overall pricing and working with the startups and provide even, very startup-friendly environments like we have indigenous ones, or how would you position on that? If you can explain a little more, thank you.
Okay, I wouldn't want to compare with
yeah,
others, but
just
in general,
from the pricing perspective.
There are quite a few startups, I don't have a number, quite a few startups in India and globally who start with AWS and who have grown exponentially on AWS.
Correct.
So what we support them is in terms of one, when you use AWS, there are quite a few services which are available or which come with a free tier. I'm sure many of you who used AWS would know that. And sometimes, based on the process, there could be credits as well, which again goes through a specific process. So there are multiple means, and as solution architects, we also work with organizations, startups, ISVs, enterprise organizations to help them architect the solutions which are scalable, secure, cost optimized as well, right? I mean, when you talk about startups, obviously it is about cost. So they don't want to spend $1 million when they are at the beginning stage. So that is where we as solution architects, we help those organizations or startups architect the solution the right way.
Thank you so much.
Yeah.
Yeah, as a startup, way back we are in AWS and we continue to use AWS, okay, because solving a problem is more important, bigger problem. Question to you is, one of the things that we face problem in most of the things is data access. Okay, we can analyze once the data is there, right? The EMRs and DHR integration that you have, what kind of integrations you have, Epic and Cerner and all these things do you have, number one. Number two, for a price, can we get access to the anonymized data from these connections that you have, or on your own you need to live your life?
So on AWS, there is something called Registry of Open Data. So where a lot of organizations have published data that they wanted to make it available on a public domain. So otherwise, we as AWS, neither we have access to data from other organizations, nor we can, give that. But like I said, Registry of Open Data is a good place where, there are data sets which are available free of cost as well as paid. So when you go to that, you could probably run a CLI command and the data comes into your AWS account into an S3 bucket. So what my request would be to look at the Registry of Open Data set to see if there are any, data sets which are available suiting your requirement. I don't have a specific answer now if it's available or not, but yes.
Yeah, because there are companies like Sequester in US, way back, they're from last 8-9 years. What these guys do is they build hooks into all the EMRs and DHRs in US, and for a price, which is paid ultimately to the end user, who gives you data back to you, they give you data back, anonymized data, so that you can choose for clinical trials and research and all the stuff. So ideally, if AWS should have such kind of arrangement with somebody, because only when that engine starts, rest of the things will start. Without data, nothing will start. So probably, I thought maybe you have one solution. For a price, we can get anonymized data. Yeah, thank you very much, Barney, for your answer.
Sure, yeah, thank you. Any other questions?
I think we're out of time.
Sure, okay.
I request Mrs. Ritika Marumpalli to felicitate Mr. Sainath Bandhakavi. So next we have our next theme 2, AI in practice. So this is a speed session where startups who are using AI in their day-to-day operations will be talking about how they are putting AI to use. These are going to be a series of very fast talks, so 10-minute long talks followed by 2-minute audience Q&A. Our first speaker is Dr. Poorna Chandra from Centella AI.
Accelerate target-driven drug discovery.
Yeah, in Audible? Okay. So in 2025, more than 300 AI-designed molecules are entered preclinical pipelines globally. Several molecules are already in clinical trials. So this is reality of today's pharma industry, that where AI not only supporting discovery, it started actively driving the entire discovery process. So this transformation is already materializing across various R&D pipelines across different therapeutic domains. Companies like In Silico Medicine, Exscientia, Benevolent AI. So some of the molecules designed by these companies are already in clinical trials. So AI in drug discovery has officially moved from experimentation to execution. So today I'll share what this looks like in practice, where it works and where it breaks, and how Centella AI is contributing for preclinical drug discovery. Very good morning to all. In the next few minutes, I'll walk through how Centella AI accelerate the early drug discovery process. So as we all know that drug discovery is a very tedious process, very tedious, laborious, as well as it requires huge capital, and it is having high attrition rate. So this is the typical drug discovery value chain, starts from the target discovery till FDA approval. So the entire value chain takes almost 10 to 15 years of time, and the cost $2 to $2.5 billion of investment. And majority of the molecules, almost 90% of molecules are failed in clinical trials. So these are the 3 pain points we are addressing with AI integration. So this is a typical comparison of traditional versus AI-driven approach. So if you look at the time scale in the traditional approach, so it requires almost 7 years for preclinical drug discovery, whereas it requires almost 700 million USD for the cost. And while integrating AI, we can reduce the time up to 25% as well as the cost to 60%. This is a BCG report on AI adoption across value chain of the drug discovery. So if you look at from 2015 to 2024, almost 67-fold was increased, and majority of the share taken by the AI targets as well as the small molecules. How Centella AI is intervening with the drug discovery. So in any specific target or in any given target, to get the hit-like molecule, it requires almost 20 to 30 DMTI iterations, like design, make, test, and analyze. And almost 3,000 molecules we have to synthesize. But with the integration of AI, Centella AI can reduce DMTI iterations 5 to 7, and within 300 molecules, we can get a hit-like molecules. So for any drug hunter or medicinal chemist, there are 2 major challenges they can face for any given target. That is, what to design and how to synthesize. So these what to design, we are addressing with 3 modules: generative AI, virtual screening, and ADMET. And how to synthesize, we are addressing with the platform retrosynthesis, CentSynth. So this is altogether is a proprietary platform of Centella. It's Centella's AI-supported computational and drug discovery engine. It's a cascade platform. It contains almost 4 modules. One is generative AI, where it helps in the de novo design of new drug-like molecules. Virtual screening, we can screen up to millions of molecules within an hour. And we are having almost, we can predict 40 to 50 ADMET properties, and we can help the synthesis of we can predict the routes retrosynthesis. And further, we are partnered with the Microsoft AI discovery program, where we deploy the entire architecture into the agentic AI. We are converting this into agentic AI. So if you just give a prompt, it gives the drug-like molecules. So this is the typical architecture of Cascade platform, where it contains the target due diligence platform, generative AI, virtual screening, ADMET, and retrosynthesis. This is a patented platform. Now I'll show you the demo of how this platform works.
Accelerate target-driven drug discovery with Centella AI. Identify and analyze biological targets with AI-powered insights. Evaluate relevance, feasibility, and downstream potential. Smarter target selection starts here. Centella AI streamlines drug discovery with powerful ADMET insights. Create and manage projects from a single dashboard. Input molecules using smiles, draw structures, or upload files. Validate instantly, run predictions, and visualize key properties. Download results and accelerate confident decision-making. Plan synthesis routes with Centella AI retrosynthesis. Generate single-step or multi-step pathways from target molecules. Explore reactions, intermediates, and alternatives instantly. Smarter planning, faster synthesis decisions. Build your own retrosynthesis model with Centella AI. Train on private, proprietary reaction data securely. customize workflows, generate synthesis routes, and refine predictions. Full control, private data, and smarter retrosynthesis. Design novel molecules with generative chemistry on Centella AI. Define targets and constraints, and let AI generate optimized compounds. Explore, evaluate, and refine molecules in real time. Innovate faster with AI-driven molecular design. Run accurate molecular docking with Centella AI. Upload protein and ligand files, set docking parameters, and start simulations. Analyze binding poses, scores, and interactions in an interactive viewer. Faster docking, clearer insights, smarter decisions. Centella automates complex drug discovery workflows. Define your objective, and the agent plans and executes each step intelligently. From molecule input to analysis and results, everything runs seamlessly. Smarter decisions, faster discovery. Powered by agentic AI. Run powerful molecular dynamics simulations with Centella AI. Set up systems, define simulation parameters, and launch runs effortlessly. Analyze trajectories, stability, and interactions in real time. Deeper molecular insights powered by AI. Accelerate structure-based discovery with AI-driven precision. Upload protein and ligand inputs, configure parameters, and run predictions seamlessly. Visualize high-quality results in minutes and download outputs instantly.
So this is where rubber meets the road. After building this platform, we have selected CDK2 as one of the target to validate this platform. So this is a typical signaling mechanism where CDK2 binds with its cycling partners and helps in the cell cycle progression. So almost 20 isoforms are there for CDK, but however CDK2 doesn't contain any approved drug so far. Among the 20 isoforms, CDK 4 and 6 contains only the approved drugs. So we have curated the information for all the pan CDK inhibitors which are in clinical trials as well as the updated molecules. Okay. Further, we have curated the information of patent space. Some of the molecules designed by Pfizer, Bayer, Novartis. So with this information, we have identified the chemotype, and further we have also selected some of the gatekeeper residues which gives more selectivity towards CDK2 among the other isoforms. So by collecting all this information, we fed this data into our model and adopted structure-based drug design approach. So here we have generated almost 7 different molecules having different chemotypes, and then we have done the substructure search for all these 7 molecules. So almost 150 molecules we have generated, and from these 150 molecules we have applied diversity filters as well as the docking scores, and we have shortlisted 40 molecules for the synthesis. We synthesized all these 40 molecules and executed in biological lab. In a traditional setting, the hit rate would be 5% to get any hit molecule. With Centella Cascade platform, the impact would be 3x we have increased. And the entire program we completed in 4 months and with the 40K USD investment. So these are the enzymatic results. Dinaciclib is FDA approved drug which is having 4 nanomolar, whereas Centella's compound is having 7.3 nanomolar. So to get this hit molecule in general traditional setting, we required at least 20 iterations. However, in a single iteration, we got this activity. So these are different therapeutic modalities that currently we are working on it. So AI is no longer a side experiment in innovation lab. Definitely it's becoming core infrastructure for modern drug discovery. And this is our core team. And thank you. Yeah, happy to take your questions.
Any questions from the audience? Okay, I think we can move to the next one.
So I have a couple of questions. Great presentation, by the way. One is, what is the kind of business model you're looking at? And would it be like a subscription-based? Like, how are you imagining that?
Actually, the platform is ready, but however, we are just waiting for 6 months to give it as a PaaS model. And we are having one pipeline. And the third thing is partnerships. We are 3P is our business strategy: pipeline, partnerships, and platform.
And also for each kind of drug development, like you mentioned that you have different modalities for different kinds of drug molecules, like beat oncology and all that. So based on a potential customer's requirement, can you curate your platform? Is that how it is? That's why you're calling it a PaaS, I assume.
Exactly. We are having a target due diligence platform. So depending upon the target, it curates the information and we fine tune the model. So accordingly, it generates the molecules so that we have a better chance to get the more success.
If I may, just one final point. Do you have competitors, globally speaking?
Yes, in silico medicine and
so how do you differentiate yourself?
For example, a majority of the tech companies are built by the techie guys, these AI platforms. But in our case, I'm a cancer biologist by training, and the founder, he's a medchem. So most of the people, for any given target, simply they fed the information into the algorithm, whatever the hit molecules or whatever the molecules they generated, simply they validate in the lab. But in our case, we do the iterations of target, like what kind of structural information it contains, like does it have any gatekeeper residues, what kind of binding pocket it is having, and apart from that, is there having any chemical space, like what are the different ligands, what kind of chemotypes. So these kind of information we curate and we fed the algorithm. So this is the USP of ours.
All right, thank you.
Just one question. So you reduced it to 40 molecules, and who is going to synthesize them?
Actually, we gave this for a CRO company to make it fast. So they synthesized, and we did the biological assay at San Diego, BPS Biosciences.
Thank you.
Yeah. Thank you, sir.
Next, I would like to call Ms. Bharni Kumar Depuru from Garba AI.
I'll manage it. Thank you.
Full screen?
Yeah. I'll manage it. Thank you. And I'll manage it.
You know how to.
Yeah. Thank you. Why is it not working? Yeah, thanks.
Sir, pointer.
Yeah, no, that's not needed. Hello, everyone. Thank you so much for giving this opportunity to talk here. My name is Bharani Kumar. It's Mr. not Miss. That's the first correction. Yeah, that's okay, I understand. I have 21 plus years of experience. I hold a double master's degree from IIT and ISB. I worked with HSBC, ITC Infotech, Infosys and Deloitte before taking a plunge into becoming an entrepreneur. By the way, I also teach at Indian School of Business. I love teaching. So I've been teaching since 2019 over there as a visiting faculty. And I'm CEO and founder of Garba.ai. Thank you. Because of the increasing stress levels, people are not able to have babies naturally, right? And a lot of people resort to a treatment, assisted reproductive technique called as IVF, in vitro fertilization. What do they do there? They take the sperm from male, they take oocyte from female, fertilize outside to form something called as embryo. This embryo is then grown in the lab setting for 5 days or so, and then embryologists would observe the growth of embryo under the microscope. And they will grade the embryo as grade A or B or C. And if you give the same embryo to another embryologist, they might give a different grading altogether. So there is a lot of subjectivity involved. And then they implant into the woman's womb. Embryo is implanted into the woman's womb. And then woman will realize whether she is pregnant or not after a few months. What if she is not pregnant? They will clean the womb again and cycle 2 repeats. Each cycle is expensive, 3 to 5 lakhs, and it can go up to 8 lakhs as well, depending on the clinic that you choose. And also, it causes a lot of mental stress. And Garba.ai is here to solve this particular problem to a great extent. The success rate of IVF treatments across the globe is around 30 to 35%, which is very less. And how can we improve the success rate? And this is where we have a solution. Either you take the microscopic images or take the time-lapsed images. And then the moment you upload that into our solution will automatically grade whether the embryo is of grade A or B or C. And in this world of IVF, you have different grading systems. One is called as Gardner grading, another is called as Istanbul grading, etc. So our solution looks at both these aspects. It is trained on such data. Also, if your AI solution is just going to do some prediction, saying that, hey, this is grade B, then embryologists or physicians will not trust on the prediction results. So what else should we build? Explainability, right? If at all, the AI solution can also highlight those portions which are forcing the AI believe that it is grade A or B or C, then it is going to instill more confidence in the people who actually end up using this. And what could be a few of the entry barriers for someone else to replicate such a solution, right? The first entry barrier would be getting an ethical committee approval to get the data to train your models. You cannot take the data which is publicly available because you never know who graded those. And you cannot rely on the quality of those gradings. If you take low quality data from internet and try to train that, then you will have a hurdle to get CDSCO approvals. Like you have US FDA, we have CDSCO, right? And I'm happy to say that we are the first solution and the only solution in India in this space to get CDSCO approval. And what else can we do is what we were thinking. And we thought that just embryo grading might not help improve the success rate of IVF treatments. We need to look at sperm quality. We need to look at oocyte quality. We need to look at endometrial receptivity assay, ERA, right? We need to look at the window during which embryo should be implanted into the woman's womb. And then we also felt that images alone might not give you right predictions. So we have included non-image data as well. Don't you think age of the parents matter? Yeah, their demographics also matters. You know, before you classify whether the embryo is of good quality or not, and before you assess all these things. And if you build this as an ecosystem, we believe that your solution will be very robust, and then there'll be a lot of people who will be willing to test and validate your solution. And today as we speak, there are 6 clinics who are using the solution. Once again, we felt that, can I take data only from Chennai? Can I take data only from Hyderabad? Can I take data only from metros or non-metros? Can I take data only from South India? Then don't you think data would be very biased? Right? Hence, we thought let's pick up different parts of the country And even when we pilot and when we validate our solution, we have to deploy the solution in North India, East, West, Central, and South. So that you start getting the data from all these regions, and your data set will eventually become very robust. And I'm also very happy that we are the third largest in the entire world in terms of the size of the data on which we have trained the solution. And we will very soon be number 2, right, on the planet. We also have ISO certifications, and there are a lot of people who are onboarded. I believe post-noon we will have a session from Dr. Sarang Dio, and he is one of our advisors, and this is our core team. And when we did competitor analysis, we figured out that there are a few competitors across the globe, but none of them have the solution built on Indian data. And we are the largest population on the planet. So that is the advantage that we want to take. And the next big thing that we are aiming for is edge AI, so that you safeguard the privacy of the different patients, so that you safeguard the PHI aspects, abide by those. We are taking the solution to the microscope devices. So your solution will no longer be available on cloud, etc. It will be available inside the microscopic devices. And already we are in advanced level talks with a company called as ESCO, ESCO. And before you ask me on what is a pricing model, etc., we are awaiting the manufacturing license. Only once we get that, we can commercialize. However, the clinics where we already deployed the solution, at 6 clinics, there is an agreement that post we get the manufacturing license, it will be converted into commercial license, right? And then we'll be charging. How much would we charge? A one-time installation fee of 3.5 lakhs, and per embryo, it will be around 1,500 to 2,000 rupees. So it'll be very pocket-friendly as well, and we aim to revolutionize the world of IVF. Thank you so much, and hopefully you got some insights from me. And if you have any questions, I'll be more than happy to take those.
Thank you for the talk. I would like to know, in a country like India where the labor cost is low, what are the potential cost savings for these IVF clinics when they employ your solution as opposed to doing it manually with clinicians?
Oh, yeah. So there is a clinic in Chennai. What they were saying is we want to expand across South India. For that, we need skilled embryologists. Where do I get them from? We don't have any formal training in India to become an embryologist, right? So that is where we were saying that you need not worry. You can have one senior embryologist sitting at your main clinic, and then our solution can replace or act as an assistant for the junior embryologists across the different locations. So it will help you scale faster, and the accuracy will be higher. That means a lot of positive word of mouth promotion would happen, and your business will ultimately grow here.
So it's not just the cost, but the accuracy as well that you offer to these clinics.
Absolutely.
Okay, thank you.
That's all the time we have for this Q&A round. Next, I'd like to announce Dr. Pungotai Ramaswamy from Crogene Arogyam for her talk.
I have it in my laptop. No. Presentation.
Any videos of those? Only animation.
No, but I can show you. If you connect my laptop, I can.
Yeah, you can bring it.
Yeah, she can get.
And I am the founder of Croji, a startup company based out of Hyderabad, and we are incubated IIIT Hyderabad. I thank everyone for having given this opportunity to talk about the product that we are developing. First, before I touch base on the AI and ML that we use for the medical device that we are using, we'd like to give you a brief introduction and also the need for using AI and ML in medical devices, especially for mass screening or point of care screening devices that India needs for screening its population. I think, we have been, so we are working on a non-invasive point of care screening device for sickle cell disease by using AI and ML. And we are still in the process of completely, finalizing on this, digitalization of this particular AI and ML. But we have initiated the process. So somewhere we need to make the beginning. So we have started that. Initially, to start with, we were more focused on the hardware part of it, and the product that we are building is innovative in the sense it's little different. We are working towards something different from that of the existing platforms used for the similar purpose in a country like India, where the sickle cell disease is highly prevalent, apart from the countries like African countries, Central Arabian countries, and some of the countries like South American countries, where the sickle cell disease is highly prevalent. And the main reason why we are focusing on this is it's something like happens to the children because of the consanguinity and inbreeding, which is quite prevalent among the population, especially like Indian population, where the tribal populations are affected. And this is very common because of inbreeding. And since we are coming all from basic science research, I'm not going to get into deep into the how the inheritance of this disease happens. So we have been funded by various organizations like BIRAC, Nidhi Prayas, MITI, and we are also with investors like IIIT Hyderabad, STPI Pontac, and with this, I would like to go to the next slide. So the problem, the market, the opportunity we have. So it's a huge opportunity, no doubt. Though it's a social impact product that we are building, there's a lot of opportunity for this to eliminate this disease as per the Indian Health Initiative that was given in 2023, that by 2047 we want to eliminate sickle cell disease from India. So how far we are going to work on this, and if we are going to eliminate sickle cell disease, we also have to be more focused on the carriers. How are we going to eliminate the carriers so that the sickle cell disease is being eliminated? So there being a blood disorder, and it's because of the mutations, the point mutation, the normal cells become a sickle cell. And what are the problems associated with this? And what is the prevalence of it? So definitely it is very high. We can see the map, when you see the demographic map, the Central African countries, India, Central India, and the Brazilian countries where the disease is highly prevalent, and the screening process needs to be very robust so that this could be done on a large scale for a population like India. And is more prevalent among the tribal population, as I said, and the prevalence of sickle cell in India is estimated to be around 4.74 for the people under the age group 20 and 2.5% for the people over 20 years, and contributes about 14.5% of the total global population. So that is
maybe
how
you can go to your technology.
Technology, yes. So having to address all this, we are building a device that is by non-invasive testing protocol using AI and ML. So the domain that we are using is healthcare, medical device. And the existing platforms, when I want to compare why we have come up with the automated system, is the existing platforms for point-of-care screening, uses for the sickle cell especially. When you go to the point of care, it uses platforms where it requires a lot of pricking of the fingers, the reagents to be carried out, and the logistic issues which are associated with it. So all these things we are taken into the consideration before we started with building the non-invasive platform wherein all these things can be minimized. So the solution is a digital system and method for screening sickle cell disease. We are using thermal stimulation using a Peltier. So the thing is, you can see the finger with the LED and the photodiode, which works in the transmittance mode. And we give a thermal stimulation to the epithelial tissue surrounding the arterial wall of the finger and on the test subject, and thereby we induce this physiological change, because the physiological change, what happens in the sickle cell and the normal individuals, they behave differently because of the morphology and the physiology associated with it. So by giving a thermal stimulation, the flow of the blood in the arterial wall, the arteries, the arterial blood vessels will be different. So the thermal stimulation what we give here is, we take the readings at room temperature, we take it at the elevated temperature, around 37 degrees, and then we bring it down to 23 degrees. So that is by dilating and constricting, we are trying to see how the blood vessels are behaving in the normal individuals and in the diseased individuals. When the normal individuals, it changes according to the change in the temperature because of the normal blood vessels, whereas in the case of the sickle cell individuals, they either try to either they don't behave in any different way. I mean, they remain as it is, or they might be, abstaining themselves from not flowing So because of the stacking of the cells, the rigidity and the fragility of the cells. So the key features we use is the PPG system with a Peltier, the temperature operating in the transmittance modes as is shown there, designed for minimal laboratory procedures, enables data acquisition, recordings, and remote sharing through non-invasive sensor-based technology powered by AI and ML. So this is the device what we have. I'll show you the device presentation, the end of the presentation. So we have a probe and a monitor next to each other, and this is a patented technology, and is a portable device with minimal training which is required at the point of care. Completely eliminates the need for samples, reliable performance across diverse environmental conditions, either it's cold or in extreme cold condition or extreme hot conditions, it can be taken, the readings can be taken, and the results are within 4 minutes. And it's robust design with no reagents, consumables or storage. It's a one-time investment. Enables non-invasive data acquisition, recordings and remote data transfer. And we intend to go for the Telangana government and also the Andhra Pradesh government, and it's priced at 1 to 5 lakhs based on the type of orders we get. And as per the 5 minutes times, the turnaround time, we can screen per year around 43,200 people with one single device. So business and models, I just don't want to go deep into that. We either want to go to being a more of for social impact. We would like to go more for B2G and also for B2B, hospitals and healthcare professionals, doctors and ambulance services would be other, apart from genetic and military hospitals. And this is some of the. So how do we take the data? That is how we want to see. These are how the PPG waveforms look. So we get the analog data from the analog. These are the analog data. What you see the PPG waveforms. From the analog data, it gets converted to digital data, and from here we try to do the time domain and the frequency domain. It gets converted into the features. The features which helps in deciding about either they are control or carriers or sickle cell. So these are the control data. When you see when there is a change in the temperature, there will be an expansion of the waveforms, the PPG waveforms. That could be visibly seen on a device, and I can show you the sickle cell data. This is about the sickle cell data, which when you see in the device, it looks more better. And so this is how we try to classify based on the type of the waveforms we get, and from there the analog data is converted into digital data, and then that helps in classifying it based on the conversion from the digital data to the numerical values, and the numerical values tries to do the classification. And so we are using a classified A and ML based models, and use cases. And so see, these are some of the questions we are addressing as of now. And so this is what I've been telling, that we use supervised machine learning for classifications as different categories, analog into digital, and domain. We use the time domain and the frequency domain, as we saw in the different temperatures we do the waveforms, and then that is converted into a frequency, number of times the waveforms gets converted in 30 seconds. The total number of times it is per cycle is around 30 seconds each. For that is from ramp down, ramp up, and heating, cooling. And so we use ML models for using labeled data sets, and we also tried the neural networks, but since our microcontroller is only 32-bit, we are not going deep into that. In future, we'd like to go for more features. more predicative and also for classifications, better classifications. So with this, I will just like to conclude my talk, and these are my teammates, and most of the software and AI and ML are being taken care by Mr. Satish Kumar, works on the software part of it, apart from the hardware. And this is our vision. Let's strive to eliminate sickle cell disease from the population. We have also displaying a product, and if anybody is interested, can come and take a look at it, the demo of it. Because of the shortage of time, I'm just closing down, and I'm open for questions. Thank you.
Thank you, Dr. Ramaswamy. Because of the shortage of time, if someone has any questions, you can catch her at lunch. You'll be available all day, right? Yeah. Thank you. We'll be moving to the next speaker, Mr. Deepak Bijalwan from Blaze.
This is reverse, this is
Good afternoon, everyone, and thanks Dr. Madhu and team to inviting us here. I work for the Blaze, and Blaze is developing silicon. It's called inference chip. So I will talk about the inference chip and other things. So the topic is from silicon to Sanjeevani, right? So if you see today environment, all clouds and other things, but if you want something on device, what you can do. So AI is not a luxury kind of, we'll come back, train the model, inference the model and give the results. On the spot point of care, if you want the result, the solution is here, the AI on edge. It's called a physical AI, right? And it's the present day necessity, not a future. China healthcare is rapidly fasting. They have better chips, better API, and recently they have developed called Health ATM, where you can visit the machine, get your vital checks, and immediately get the results on that. This kind of system, if we can build in India, is a great. And we have the infrastructure, we have everything. But still, the reachability of poor man to AI-enabled doctors is very far. India healthcare realities, the doctor-patient ratio is very, very high, especially in the rural area is so very high, and the reachability is very low. But we have the advantage of the infrastructure, like we have ADAS, API, and other things what government is proposing on the part. The check is here. I need to move a little fast. The time is short. AI doesn't mean that you are replacing doctor. AI means is the assistant. It cannot be a full doctor. It helps the doctor to decide fast rather than waiting for long tests and other things. So good news is tool that works are generally transformative, and it can help. Expertise, it cannot replace the expertise onto that part. The proportion of AI versus cloud is the latency, connectivity, privacy, cost, and reliability. These are the things where people little hesitate to put the data into the cloud rather than make it private, run onto your own mobile phones or devices, and get the result on that. We have 1.4 billion people, 1.3 doctors, patchy internet, everywhere it is not available. The solution is only AGI. The game changes transform healthcare, medical imaging, predictability, forecasting, administrative cost, drug safety, patient language triaging, and other things on your device. It help. And we are not talking about the training models, we are talking about the inference model. Inference model, it can depends like it may be the vision models, your language models, your small language models, large language model and general model generally, they are not prefer things. As we seen the result in the industry, a specialized model on a particular device have much more value than the generalized model kind of these things. Chip advantage is the tops per watt is better. We can have the tokens per second per watt if you calculate onto the inference devices on edge and cloud. The cost is very high. Second is the model size we can reduce. We can do the quantization of model. It's not necessary to take the 32-bit models for training and inference both. We can have the system where you can quantize the model, lower the bandwidth, and make it fast. So cost is less, bandwidth is high, and easy to use for that part. Another thing is medical grade. Getting the medical certification onto the cloud for the models, and models is not kind of one-time model. You have to do the active learning for the model. It's a continuous learning. You have to deploy the model. So getting those things onto the edge AI is much more easier than the bigger models and other things, right? So I'm seeing that within the 5 year, maybe we can produce a lot of AI chips like a geo movement, where we had the internet in early days very costly. Now it is every mobile very cheap. Same way, maybe in the AI in chip or physical AI can be very cheap, and it can be easily deployable to all kind of devices like medical devices or mobile phones or something like that. Ayushman Bharat is one of the ingredients for that, where you can get the chances to put AI into the systems with the edges, and you can have the reachability to every poor in the rural area. Policy need to be updated. We should have AI diagnostic insurance kind of cover in the policies. That is a government job, and hopefully it will be come soon. Other advantage is the stack we have from the Aadhaar, from the DigiLocker, from the ABDM, and from the Bhasini, that is language models. We can integrate together. We can scale the data. We can get the AI quality, better models, trained models, quality data on the edge that can within a chance. Okay, that we can move fast into that. So it is aligning to the principle what we are discussing today, people, progress, and planet. So these are the 5 critical challenges where you are seeing the things: doctor shortage, infrastructure, cost barrier, languages, data diversity. All these can help as a sutra for next gen AI. People, we should cover everybody, should not believe anything. Progress, affordable innovations, sustainability for the planets, and these principles guide every AI healthcare innovation in the Indian AI mission. What didn't work? So, in general, every AI company did not succeed. The failure ratio is very high, and getting the government certifications and other things, 70% of AI healthcare pilots fail, they never scale. So that is one of the brutal reality of the market. So we need a honesty, build credibility, learning from the failure, and scale the product. Key challenges: data privacy, security, regulations, skills development, AI biases, and fairness, interpretability. Biasness means the model which are working for the European country or American country are not working for the Indian conditions, and that is the reality, right? But we can take the advantage of our government schemes and the data what government is collecting from the people, and we can use that to train the model for AI for the Indian conditions and maybe better things. And it can be the template for the world. Right? There is a lot of chances for the export strategies and getting things done because the Asian countries, European countries, African countries are close to the Indian things, and the market is very large for that. It's maybe 50 billion and plus by 2030. We have the hardware, we have software, we have the infra. We just need to build the things. From silicon to Sanjeevani, aligning to the theme, people, progress, and planet. We have the innovations, we have the constraints, we have the diverse conditions where we can build a very diversified data sets, train the models for that. Chips are designed for the power of our tables. We cannot invest 150 watts power for just running the NVIDIA chips. We need 1 to 2 watt, 3 watt, 5 watts per tokens, kind of these things, which can be easily available everywhere in the world. And every edge AI devices from Mumbai to Manila is the saving of the things. So by 2030, hoping that all the medical devices will have the physical AI on the edge. So at Atmanirbhar Bharat, this is maybe the mission where you can deploy the edge AI onto your device at any point of junction, at any point of care. Thank you. Any questions?
Don't have time
Thank
for
you.
questions right now. We'll
Yeah.
move to the next one.
Thank you.
The next speaker is Mr. Priyanjit Ghosh from Logi AI.
The PDF is not going to.
I think it is working. It is working. If you can play the PDF on that.
So hi everyone, this is Priyanjit. I am CEO of Logi.ai. So I understand this is the last presentation before we break in for lunch.
No.
So give me
Do you know what's the newest buzz in town?
I believe
Go.
it will be working great.
Yeah. Advertisement. Yeah, these are the two.
This ad.
I'll play. Where is the? You can play.
There is one more presentation after yours.
There is one more.
Yeah.
Okay.
Okay.
Okay. Wait. I'll change. ठीक है. I check. ठीक है. Just pause it. Just pause this. Just let it finish.
एक्सप्रेस में आप सभी का स्वागत है। आज मैं तपु विलेज पर आई हूँ जहाँ पर हमारे आदिबान के वंग की यूथ विंग ने एक प्रोग्राम
No. Can you just stay here? Presentation. Yeah, just play the presentation. ये ऊपर.
All right. So, there is a lot of AI research which is happening globally, and there is a stat that almost 90% of the AI research that happens in the labs mostly stay till the pilots. So over the next 5 to 6 minutes, because we have a crunch in time, I'll try to focus on 2 case studies which we are working at Logi.ai about how we have taken the actual pilots and taken into a population health deployment across India. So Logi.ai was born straight out of a college dorm room. Passed out from IIM Raipur in 2019 and started this company. And it's an AI-based health screening platform using just these smartphones. So we use technologies like computer vision to take images and do screening, so I'm not going into the tech. But primarily we use this smartphone, and then there is no other device. And all the screening and processing happens using cloud computing, using just the phone. Yeah, next slide, please. So the first case study I'll focus on is about oral screening. And oral screening is probably, one of the most neglected problems globally. So when basically it's a problem that you cannot always see. And if you see globally that it affects almost half the population, more than 3.7 billion people is affected by it. And sometimes if you look at, some of the problems like, for example, dental caries and all, you don't even realize it. So you'll be shocked to know that almost 54% of the Indian population has some kind of caries, but they are unaware about it. So the challenge is basically, to make them aware at an early stage and then guide them to take the treatment at the right point of time. So for that, we have created an AI-based screening solution using just the smartphone. We also have a patent. It's a process patent for this solution, which is granted to us. So this case study is about, what we did with Colgate and the Indian Dental Association. So we have been working with Colgate and the likes of various dental clinics like Apollo and others, even in UAE with Aster clinics. So in this particular case study, there were 3 bodies. So for any AI application to, go to a population health scale, I believe it cannot be just one player. You need the technology player, which is us. You need a ground operations implementer, which was the Indian Dental Association in this case, which provided 50,000 plus dentists. And you need a body which would, provide the funding and provide all the network and all of those things. So these 3 bodies came up together and we implemented India's largest oral health screening campaign, which was called the Colgate Oral Health Movement. This was launched almost around December of 2025 and it ran for almost 6 to 8 months. And some of the data points, we reached almost 18,000 plus pin codes across India, and 50,000 dentists were part of our plan, and 4.5 million, 45 lakh people actually accessed this solution and screened themselves. So how they screened? So every Colgate toothpaste packet had our QR code. Every point, at various retail stores, clinics had a QR code where people would go, just use their smartphone screen and do their screening. And the India's average oral health score that we have found from the data of almost 4.5 million people is 2.6. You can Google after this presentation and you will get a lot of stats. All these stats is publicly available and is on public domain. So I'll play a quick video to show how the solution was. It's just a short 1-minute video. Yeah, YouTube wala. No, first one. Yeah.
Do you know what's the newest buzz in town?
When AI is restricted only till awareness and it doesn't get into action, it doesn't get to the final fulfillment of value that, it promises. So what we believe fundamentally is that AI has to reach the last mile and it should go from awareness to the action. Back to the presentation. Yeah. So what did the AI found from here? So as I told about action, out of the 45 lakh people who were screened using our AI solution, 1 in every 6 individual after doing the screening actually booked an appointment and went to a clinic and got their free dental consultation done. So obviously, AI or any kind of screening platform cannot solve all the problems. Our work was primarily to give that awareness and then let individuals go and take the treatment. These are again data which is already published. So 41% of the individuals were found to be high risk of having cavities, 14% high risk of stains, and 70% of the individuals, so these were individuals between age almost 7 years to almost 60, 70 years, 70% had risk of at least one major health concern. So now when we did this, when we scaled this, we saw that there were other opportunities as well, not restricted to only just oral. And we also came up with a second product line, which was AI-based eye screening platform. Using the same philosophy, use the smartphone, create a screening platform, bring awareness, and try to get the people to take the action and take the treatment. So over here, so just to give a quick background. So we are detecting cataract disease. This is cataract which is caused due to certain age. Now India has the highest number of blind people globally. We all know sometimes India is also known as the blindness capital of India. But almost 70% of those blindness is caused by only one disease, which is cataract. And cataract is completely treatable. Now the issue that happens is people are not aware of this at the right point of time, and hence they don't go and do the surgery. The other problem that happens is that, especially at the rural areas, at the PSCs, at the last mile, there is not enough capacity over there, not enough resources over there, not specialists over there who could actually treat these villagers or people at the last mile. So again, we came up with the eye screening platform. We collaborated this time with a government body called CDOT, the Department of Telecommunications, based out of Delhi. And we implemented our solution in PHCs across Northeast India, across various PHCs, and in Vidisha in Madhya Pradesh. What happened was, in the primary healthcare centers, they were using their own smartphones. They just used our app and sort of downloaded it, and in just 20 to 30 minutes, they were ready to screen an individual. It was so easy to sort of use it, right? So they did not need any other specific kind of training. And almost 10,000 plus screenings were completed. This software was designed in such a way that, it could work in very low resource settings, in very low internet connectivity as well. So what was the impact with this? Again, coming back to the impact. This was in 23. So as you could see that, out of 1,600 people, so this was published. So this individual who got screening on the first day and was found to have cataract through AI, the next day he went and got his surgery done. So that is what I, reiterate, that AI cannot be just limited to awareness and screening. It has to get to a certain action. So out of 1,600 people who were screened at that point in Vidisha village, 53 people actually went. The government facilitated them to the nearest district hospital, and their operation was done in time. This is the impact, which we can create with AI. So can somebody help me with this video? I have a short video, yeah. So this is the last video that I have. Yeah, just play this. So this is a village in Arunachal.
हेल्थ केयर प्रोग्राम रखा गया है किस तरह से आप घर बैठे
comes onto the platform, and then we leverage now onto a single platform. You can see clinical history, video, EG, all signal data. Then automatically, thank you so much for your time. Any other question? Please do come and visit us on our showcase, and we'll be happy to answer questions there. Thank you.
Thank you very much. So that is the end of our flash talks, and now we are at the moment we were all waiting for lunch. So the lunch will be served right where the breakfast was, right beside the tech showcase. I request all of you to take your participant or delegate passes there. That's how we're going to, decide whether you've registered or not. I request everyone to be back by 2:10 so that we can proceed with the next session by 2:15, and everything can go as ordered. You can also use this opportunity to talk to the speakers, have any questions, visit their booths, since we had less time this time.
Without much delay, first I would like to invite Dr. Kavita Vemuri, who is the Assistant Professor from IIITH for her talk.
Why is it two? Why is two of them being shown? One, two. There are two slides. This slide one, slide two. I didn't get your point. No. Each one is a different slide. Okay, this made in PDF. That's okay. Thank you, and thanks to the CCMB team, Dr. Madhu, Ritika, Erin. Thanks a lot for inviting IIIT and very honored to be here. So I'm not going to speak about my research because that's something that is very boring. But what I work on is just one slide that I've just put to kind of say what basically is of interest to me in my lab. So I would look at it from disease conditions, work on stroke, basically any movement disorders. I'm an experimentalist, so my movement disorders, we collect a lot of motion capture data, we do a lot of analysis. AI, ML, all these are for us like bread and butter in those, in terms of English words in our institute. So I won't even say again that we use all these things. What I would want to actually talk about, which I've been saying this for many forums like this, but is actually to throw a problem to the AI and ML community and the biology community and the medical community, every one of us, to say what is it that we can actually take a leverage of this AI and ML kind of a power engine to solve. And that is to solve the next problems that we as a community would get, we as a country would get, okay? So all of you must have heard of the term exposomes. Yes? Yes. So I'm just going to place what I've been reading for a very long time, and just quickly, it was by chance, just a serendipity that I came to know that something that as a pollutant enters the water bodies and fish and eaten would actually lead to a condition in children. It's like the entire village, almost 70% of the village was affected. So I was only looking at it from the brain signals aspect of it. But then we did an analysis to find out where is the source, and it was found from the water. So exposomes is where AI and ML can help us. How are all these connected? These are large data, right? So you have the internal exposome, and then you have the external exposome, genome, and then you have the health outcomes. We are not independent of what's happening in the environment anymore. So we are part of it. So everything that changes there is going to change something in the entire living earth. So it could be any of these chains, right? What we eat, where it comes from, the food, it could be from just from the air, any of these exposures. And this is good data. That means we can actually collect. If we all collect, put together our heads, I'm sure we can deploy enough number of sensors to do this data collection at every point. All of you know this, right? If we actually include the exposome, this curve will actually get accelerated. Yes? So I'm speaking to the experts in this, so everybody knows this curve. And this is your entire graph. So early markers, early biological effects are already something that we are talking about. People in the world are actually, or even in Indian labs, are actually looking at microplastics. They are even talking about it breaking the blood-brain barrier. That is of interest, of great concern, not just interest to researchers, but of a great concern to the world. And the exposures can be anything. I'll just give you a few exposures, but these are what we should be concerned about, which all of us just keep talking about it, but I don't know if we are going to do enough to change it. It affects the aging biology, the aging phenotypes too. Air pollution. There is a lot of data that is there which talks about air pollution actually having almost direct correlations to cardiovascular diseases and other lifestyle conditions. But these are all like correlations. There's no causality at this time. But what we need to establish that is a lot of data. That means an effort to actually go and collect pollutants. So pollutants can't be, I have this, whole of Hyderabad cannot have one pollutant index. It should be at every stage, at every place, and we should actually be collecting this data to actually say what are these pollutants, what is the composition of these pollutants, and get the medical data from the local people, do all the analysis, and this is huge data, right? So I keep using the word huge data because AI and ML started with this big data, bigger data, okay, and then we are talking about very small parts of application to specific conditions. Air pollution, everybody knows. We all only get up in the morning talking about air pollution. So this is, I'm just giving you all the paper references here. These are actually established postnatal and in utero exposures. This is not lab science anymore. This is actually established, right? That means these pollutants are getting into our bodies. So what is the long-term effect of it, and how do we actually even map this across different places, districts, villages? The other pollutants are, of course, what comes from agriculture, the pesticides, the fertilizers, not just for the people who eat. We have had patients who come from the farming community, who come, they have very strange movement disorders. So I look only at the movement disorders, but it seems apparently they have other conditions. So they have unexplainable tremors, so they don't fall under Parkinsonian, dystonia, chorea, but unexplainable. They have sudden drops in their blood sugar levels, and then you trace it back, and they all have either there's a wound through which they actually, some of these fertilizers and chemicals that they use in their fields are actually entering. We don't know. Actually, what I'm saying is just what doctors in hospitals just discuss. I go back and look for literature, and I wish everybody works together to find out every specific fertilizers and pesticides being used, do the whole, put the chemical table for it, and then see what's the effect on the system. It's done. And we have exposures that comes from secondary. We don't have to be in the drainage water for actually to get exposed to it. But there are people who stay very close to it. There are people who are living next to it. And to say that we are isolated from these people and that it doesn't matter to us is actually not a good argument. It's just a cycle, right? So we need to actually address what are the pollutants that are coming from here, getting from secondary exposures into our food cycle, into our space, into our systems, especially for those who are living very close to these places. Everybody knows what happens, stunted growth, premature births, okay? We need the data to actually establish this. Then there is, of course, the profession part, right? Workplace pollutants. We once did one survey on on coal mines. I won't tell you which the coal mines is. And we found major issues with coal miners, okay? Not just limited to lungs, but actually to the brain. And it's all because of what basically their work, where they work, what are the pollutants there. This is established, at least this is being studied across the world. Now we just need to see if we can build this data here in this country to actually make these connections. Solid waste, every city has this problem, every village has this problem. How much of it is leaking into our water system, and how is it actually affecting us? Where is this data coming from? Can we do it? Can we collect this data? And not just cities, even villages. Every village doesn't have a proper drainage system. So how is this water being recycled? Where is it going? Does it get into our plant system? So the challenge for AI and ML community and the big data sciences community is, can we start collecting this data, massive data, and then link it to all the healthcare, and then see if we can come up with, we should be ready for these diseases or whatever you want to call it, that will hit us. Epidemic, pandemic, the names just don't matter. And it will affect the poorest of the poor more. Everything, right from the cleaning, a lot of research is being done across the world, right from cleaning chemicals that we use at home, they're also very dangerous, and of course the pollutants that enter the water streams from industry. Where are they going to, and what are they going to affect, whom are they going to affect? Another thing that, and I'm sure there are good researchers working on it, but this is almost, the recent paper just shows that there is a direct connection. Early menarche, that is when women actually, when girls reach puberty much earlier, that means they're going to get osteoporosis much earlier. Why are they actually getting it so early? What are the other conditions? Not just the internal exposomes, but what is it from outside? Are there any other stressors that are adding to it? Why did it change in the last 2 decades? Why did the aging decrease? We have this as a population problem in a few years. My mother got osteoarthritis at the age of 82, and I have it at 55. It's not a nice condition to be in, right? So that means we have to actually look at external stresses for it, not just internal. So the next 5, my only request, I came here, I said I'll talk because I've been talking about this for many, many forums, is this. As many institutes here, startups, all of you have already got sensors. Can we do this? Can we build this huge model, collect data from different sources, link it? It's okay even if it's a correlation at the very first cut, but later on we can reach maybe a causality. Collect this into large data centers, right? Take everybody's help, make this into a large data center. And data security is an issue, but we are not collecting any data from any individual. We are only going to collect specific regions, conditions, health conditions, what are the antibiotics being used, what are the medications being used. So that's not an issue. And this is a paper that I'm sure most people who are working in this area know more than me, so I won't get into it, but there are actually people working on this, right? So this is a paper that actually does what is the whole life cycle. So there is work being done, and I think AI and ML is the one which can take this multidimensional data and actually speed up this process. And India has unique solutions. It's not that we can take something that works there. India has unique solutions because we don't have proper systems in place. So this is my take. The next 5 years, if we can actually work towards this with all the data that we can actually collect in 5 years, and I'm sure we'll be able to kind of at least answer the questions, if not get solutions. So we have to customize, cure, and do prediction for the next whatever is going to hit us. And we owe it to our children, not just to us and our, what is that called, for investment startups, but we owe it to them. So the only reason I'm coming to, presenting this. I'm not a microbiologist, I'm not a biologist, I'm from physics and engineering and neuroscience. I only see conditions in hospitals where doctors don't know the reason for it. Only thing we collect data is what was your profession before you, what were you doing? We do see some markers. Doctors say, yeah, he smokes a lot, or he's exposed to this smoke, he works in a factory, he works in a chemical factory, he's near fertilizers. But these are all just simple, I would say, anecdotal. If we have large data, if AI and ML can actually be put, actual test for AI and ML is this. We collect the data, we sanitize the data, we curate the data, and then we help these models to do the next prediction of what is the effect of each one of these pollutants on us, right? If we can do that, then healthcare is taken care of in this country. Thank you. That's all I have to say. I would not be able to answer any specific technical questions. Okay, all of you are more experts in this area than I am. All I'm trying to put forth is what is the next for us as a country. Thank you.
Thank you so much, ma'am. I would like to request Dr. Madhu to please felicitate Professor Kavita Vemuri. Thank you, ma'am. Next in line we have Dr. Rakesh Kalpala, who is the Director of Endoscopy at AIG Hospitals. So I would like to welcome you onto the stage.
Madhu Garu to give me the opportunity to talk here. So I think I am there are a few doctors here, of course. How many doctors in the audience? Medical doctors, yeah, sorry. Yeah, 2-3 of them up there. Okay. So I am here not to talk anything more on research, but what has been researched. So that's something which we want to. So let me get on to the topic in specific. Greetings from Center for Artificial Intelligence and Innovation, which is probably not very commonly seen in many of the hospitals across the country. But this is my favorite slide, in fact, of all the slides. And we have to accept that we are all in this, and that's the reason why AI is coming up as a part of our life. So technology-powered healthcare is the future because there are many things which are coming up. It significantly improves the patient experience, which I have been seeing. And then it also personalizes and gives a precision medicine, which again is very important to overcome these chronic diseases which will remain for life once they enter into the body. And also for clinical excellence and affordable care, which will percolate to the rural areas. So I'm giving you this generic slide, but I'll give you the examples of how the things have been evolved in our own ecosystem. So the innovation in action, what I want to tell you in the next 7-8 minutes, is one thing all the tech guys here, all the PhD scholars here, need-based innovation is something which you have to look upon. Don't take a problem statement and then work in silos at your lab level. You come and have a cross collaboration with the tech industry, medical industry, and then only it will be fruitful and faster. So this is something called as AI-powered clinical consultation. So the issue as of now in India, a little less, but more in the Western world is, this is what it is. The patient comes to your office, the consultation chamber. The doctor is busy typing because he has to give the EMR and EHR records, and he will be hardly listening. There's no eye-to-eye contact with the patient and doctor. So, and with people like me having a single finger typing, because we all don't know typing in our schools. So we start typing and concentrating more on that. To overcome this, we at AIG started this called as PRISM, which is Prescription Recorder and Intelligent Summary Maker, where the patient comes and then he or she will narrate his complaints. I ask him the symptoms and history. Then everything will be captured by the computer in front of me, and then I order the investigations and also the prescription. All will be captured, and then at the end of the conversation between patient and doctor, it comes as a sheet which will be given to the patient in report. So patient feels happy because I have eye-to-eye contact. I also feel less burdened because I don't have to type. So this is something which is a big change in the EHR EMR system. Now coming to the another one which is very close to my heart is the fatty liver detection. So this, I think Amresh is here and Dr. Smita is here, so they know as doctors, a fatty liver which detected and undiagnosed, undetected will go to cirrhosis and then into cancers, the liver cancers. So what we usually do is, as a routine conventional type, you have an ultrasound machine, then the fatty liver is given by the radiologist in many of the centers. But that is again subjective. I might be telling grade 1, somebody will telling grade 2. But there is a gold standard scan called FibroScan. And mind you, this machine costs 1.2 crores to deploy, and we charge per patient 5,000 to 6,000 rupees to get the FibroScan. So what we did is, we developed an algorithm which is just taking the patient height, weight, BMI, and 4 parameters. The complete blood picture, LFT, then the HbA1c and lipid profile. And we started running an algorithmic model which is like the FibroScan, and it is comparable to 94 to 95%. As you see on the screen, I'm just running the examples. So this is the value calculated by algorithm, and the next value is the one which is the original FibroScan report. So just for want of time, so as I told you, 4 simple blood tests cost less than $5, that is 400 rupees. And then you get a sensitivity specificity of 94 to 95%, which can be a game changer in the rural population. We have 100,000 data as of now in-house and also doing some community work in the government of Andhra Pradesh and Telangana. This is a heat map which is comparing the markers and FibroScan, which has shown fantastic sensitivity and specificity, which is a need of the hour because fatty liver is the epicenter for the entire metabolic control of the body. This is again in-house development of a detection of sepsis. Many of the patients in the wards or patients who come in, they are having sepsis, but that is something which is masked. So what we do is, until the patient gets into septic shock, we run a few parameters which keep on coming as the patient enters the hospital. Suppose he's in the general ward, suddenly his sepsis increases and then he's hemodynamically unstable. Before he becomes hemodynamically unstable, this gives me a database saying that so-and-so patient in so-and-so ward is having sepsis, likely going to collapse. So then we'll shift him to HDU or the ICU unit. So this is again a big game changer. So this is again which, as gastroenterologist, a hardcore clinician and endoscopist. So this is a polyp detection model. I'm not saying this is the unique, discovery. There are commercially available devices from Olympus and Medtronic, but they cost around 2 crores for installment. This is the in-house polyp detection model annotated by our AI engineers in hospital, and we could crack it in 3 months with hardly a cost of around 5 to 6 lakhs. So this will detect the polyp, which I as a colonoscopist might miss it on my naked eye. So that is something which is in-house Indian discovery, what I could call. But at the same time, on the contrary, all will agree with me, this is a very interesting study published in JAMA, one of the peer-reviewed journals, that they have done a very interesting study in a Polish doctors, Poland, where they did compare the doctors who are picking up these polyps before and after introducing AI. Unfortunately, this is something which people of middle age like me or the seniors, and we have the younger age doctors. So once you have the AI into, so what, as you see on the screen, the physicians who were trained without AI had a better way of clinical pickup, but whereas the younger generation who have got this AI are more dependent on that. So that is something which is a little scary in our field because you need the clinical acumen, but you have to go with the wind and then you have to adapt and adopt according to time. So this is again a very, very interesting innovation. So there is something called as third space endoscopy, where we go through the endoscope and then dig the mucosa and submucosa. So there will be some vessels you see on the screen, which are of course visible on naked eye, but sometimes you miss. So we developed a model where this AI detected model will detect that vessel which is not visible to our naked eye a few seconds before the naked eye could see, so that you'll be ready with the cautery and then don't hit the blood vessel and then prevent the bleeding. So this is again which we are adapting, and this is a live case which has been done in the endoscopy theatres in AG hospitals, and our third space endoscopists are pretty much happy with this as a aided tool. Then this is very interesting. I think Amresh should listen to this. On a simple electrocardiogram ECG, you can pick up whether the patient has got any cirrhotic changes. There is a published study in Mayo Clinic from Rochester, and we have now around 25,000 data, and this is something called a A score, that is artificial intelligence cirrhosis ECG. So this is something mind-boggling. Some people might argue it is hallucination, but even the hallucinations can be turned into a product. That is what I wanted to show you. Again, another research with our ophthalmology department, ocular imaging with liver disease. Again, we are trying to predict some models out of it where you can just see the eye examination and then pick up any disease related to liver. And this is again something which is close to my heart. So this is a public study which we introduced recently. So infant mortality rate and maternal mortality are the maximum in few states of the country. And the main reason for that is undernutrition or malnutrition of pregnant women. I'll tell you a very practical example, and very unfortunate to hear in this. See, what happens is when the pregnant mothers in rural areas, they'll be given this food for every month, they'll be given a quota of food. So earlier they used to give 1 egg per day, but because they can't reach, the ASHA workers can't reach the houses every day, they started giving all the 30 eggs of the quota in bulk in one day. And you know what happens? After 2 to 3 days, all the eggs are gone. It's not that the women is eating. The people in the family are making omelets and burji and then eating it off. And this woman is left with no eggs after 3rd, 4th day. And she has to depend on all those dal and this routine thing. That's a pathetic situation of healthcare in few parts. I'm not blaming the entire India, but it's improving. So what we did is we created an app which has got a food scanner. So what that does do is the mother, when she's eating breakfast, lunch and dinner, she just has to scan the app, and once the app is scanned on the food, what has been shown on the plate, so you will get the nutritive value of number of calories, carbs, proteins, fats. And then she has to just push a button which will go to the entire healthcare system from ASHA, Anganwadi, PHC, and even to the CM dashboard, Chief Minister's dashboard. So if at all that lady misses 48 to 72 hours the adequate nutrition, this ASHA worker will go to their house and then tell, look lady, you are missing your nutrition, so you please buck up again in the next 3-4 days so that you won't be undernourished. And also the ASHA workers sometimes bluff that they have did the attendance. So this lady also can give attendance to the ASHA worker whether she has come to their house and attended the duty or not. So this is something which we rolled out at 4 or 5 places in Andhra Pradesh and also in Telangana. And we are getting a good amount. And we have the dashboard which is there in the central governance office, in the chief minister and the other health secretaries, and also in the AAG dashboard where we have a chat bot also. Suppose the patient is somewhere in the remote place and suddenly she starts bleeding, that is abortion, what we call. Then she will send an alert in the chat bot. It will go to the nearest PHC. The PHC will come and pick up the patient in an ambulance, and then the doctor will treat. So that is the advantage of this. So I am just trying to conclude saying that these are all not innovations which have come up from sky or from the Western world. These are all need-based innovations what we have done, and these all came from a couple of doctors whom we run a course of artificial intelligence in healthcare with Indian School of Business. We had the 2nd edition last November. All the products what I have shown to you are from the group of doctors with a data analyst who was working with the group, and the data has been shared, and we could convert them into these live examples. So artificial intelligence is probably going to get the Nobel Prize, and it dictates its own Nobel Prize. So according to this paper in Nature, so AI told that it will be getting its Nobel Prize for AI in 2050. So just to conclude, so this is a famous picture what I quite often show. The 2008, I'm not exactly specifying the year. So when you want to shoot with a cameraman and a pilot, but now you have the drones. And within 10 years of span, both those two people lost their jobs and this took over. And the man who has who wrote the evolution. So this is a statement in 1809, just imagine. You can read with me. It is not the strongest of species that survives, nor the most intelligent, but the one most responsive to change. So we have to adapt and adopt to the artificial intelligence which is changing. And as doctor, I would say and always say, it is never going to replace doctors, but it is going to increase the efficiency and proficiency of the doctors. I'll stop here and happy to have any questions. Thank you. Oh, after the, sure, thanks.
Thank you, sir. I would just like to ask Dr. Madhu to please felicitate Dr. Rakesh.
Dr. Paneer Selvan, the CEO of Mighty Startup Hub, has joined us, and he will be addressing us virtually. So, just give us a minute.
Whether you can hear us?
Sir, can you hear us, Paneer sir?
Manoj? He's muted.
Okay, I think he'll just join. So can you see us? Can you hear us? What is this?
No, you try madam.
Sir, can you hear us?
He is muted. that way. कहाँ पे? हाँ लगा है ना? हाँ ऑडियो वीडियो को सेपरेट है ना? लगा है ना?
Sir, can you hear us?
Hello.
Listen. Yeah, this showing is muted.
Wait.
I'll just stop. Sir, can you hear us?
Your voice is coming in the sense?
Yes.
Mr. Vikai, I can hear you.
Just 1 minute, sir.
Yeah, sure.
ये चालू नहीं है.
Microphone is there. Speaker, I need to change to
speaker.
Yeah. Sir, now you can speak, sir. Hello, sir. Sir, I am audible, sir?
No, I think no. Go here. Codec. Yeah.
Both are same.
Can I?
I'll join. Otherwise, 1 minute.
Can I join? Can I pick my laptop?
Then we have to change again, no? Settings.
Okay. क्या होगा?
If you're talking, it is coming, no, madam.
Okay, just a minute. Jitu sir, keep the phone to Madhu sir, na?
बस फोटो था नहीं फोटो दे ना लास्ट टाइम
एक मिनट सर ऑन है हाँ
हाँ लास्ट टाइम फोटो दिए थे ना और एक बार फोटो देखो जस्ट फ्रॉम ऑडियो लास्ट टाइम आपको दिख रहे थे ना ये तो डालने के लिए
कौन सा? No.
1 minute, I'll check others.
Yeah.
We have this thing no here. Instead of wasting time. Hello, here something is muted. No.
Speaker is there. V21 is there.
Hello, check.
I think you can try another system.
मिला फोटो
दूसरा सिस्टम ट्राई कर लो ना.
Where is my system? Will get. Yes, sir. Zooming is there. Audio is there.
Audio is not coming. This should be 2VS1.
Microscope. No.
You do one thing. I'll connect.
Give me just yeah.
Do one. You make it on full screen. Mine is this one.
Hello. Your mic is coming.
My mic is on. Shiva, try this quickly. Try this one.
Hello.
It's not. Leave it. You can try this one.
Hello. Sir, are we audible? Can you hear me?
Okay.
But audible, but his audio is coming here or there?
No, it's coming here.
Sir, now? Yeah. Yeah, I'll just check. Just you. Sir, now? Sorry to interrupt. Can you speak once, sir? Microphone is working. Speaker, why it's not working?
चालू हो गया फिर.
No, it's. Sir, no?
Can you hear it?
Sorry. Audio तो on है ना? Why it's not working?
Speaker चालू है. Put my phone on it directly. I'll put my phone to the.
No, madam. Just one thing. I think no, it should work. Sir, can you speak last once?
Yeah. Can you? Hello, can you hear me?
Yes, sir. Yes, sir.
Thank you.
Yeah. Sorry, sir.
No problem. Please.
Yeah, you can see. Yeah. Welcome to Elan, Reimagining Healthcare. So, we're very happy that you could join us virtually at least. Your blessings mean a lot to us. So, I am not sure whether you can see, we have a good audience here, a lot of startups, a lot of delegates from industry as well as academia. So, without further ado, I think we wasted a lot of time in this audio issue, so sorry about that. I think, sir, you can address the meeting.
Thank you so much, and my sincere apologies for not being able to be there in person. We are, middle of the India AI Summit and multiple other events. We have been a little occupied and to be in Delhi. But thank you for making all these efforts to get me to speak to this wonderful audience. So really appreciate the AIC-CCMB team for taking this extra effort for me to get connected to the team, startups and the innovators and the entrepreneurs in the audience. Thank you. First of all, many congratulations on the AI for healthcare, the pre-summit event. I think it is something that is extremely critical, especially given the status of the country in terms of, we have 1.4 billion people and a very vibrant population, but that eventually it will all, we'll all need to focus on good health for this population, which means AI in healthcare becomes a very important imperative. So as I keep mentioning, any technology has to improve the quality of life of people, and that is very, very critical. And no better category than healthcare can achieve that with direct impact, right? And today we are already seeing the impact of AI in the healthcare sector, be it in terms of the molecule predict whatever discovery, or in design of yesterday we were really impressed with some of our startup presenting using AI to design artificial limbs and artificial in terms of designing medical equipments, and more importantly delivering healthcare and access to healthcare at an affordable price for the Indian public. So I think it's very, very important to deliberate, discuss, and focus upon how we can use AI in the healthcare domain, especially that can support in early stage detection. I think there are four things that are very important. Early stage detection and diagnosis, where healthcare can play a very, very important, AI can play a very, very important role. AI-based cameras can detect, identify and detect, maybe, dermatology issues, wherever possible. I know startups who are using AI to detect, tooth, issues. So a lot of interesting startups are being coming up in the AI domain. So AI discovery and diagnostics can be a very important capability that AI can help, and more importantly also the entire the next step of taking the initial stage of stage of care through and information and guidance that can be also delivered through AI empowered tools and capabilities. So that's something that is very, very significant, because if we can reduce the cost of discovery and diagnosis, it will go a long way for the Indian public. So that's something that I urge the audience to work towards. Second is to look at stronger research and development capabilities using AI. India has always led very, very powerfully in the pharmaceutical and in the healthcare space. With AI, we can strengthen that leadership. We take a lot of pride and in delivering the COVID vaccines to the world. We take a lot of pride in delivering pharmaceutical drugs at 1/10 of the cost or half the price into a lot of diseases across the world. So we have the ability to strengthen this dominance in the healthcare through investing in AI-based research and development further. So my humble submission is to for the innovators and in the research and scientists in the room to focus on research and development in the AI using AI in the healthcare space. And last but not the least, the medical devices, which are very important, because today we are importing a lot of medical devices. As you may know better than me, we are looking at MIT how we can support manufacturing of medical equipments in the country, and so that we don't depend on for import for critical medical devices and also day-to-day medical devices. That is something that we are very, very focused on. So I can assure you from MIT Startup Hub, we are here to provide you with all the support, with all the capability, and the CCMB being one of our revered partners in this, we are constantly seeking opportunities to collaborate and support organizations like CCMB and AIC CCMB. To be specific, we want to further strengthen this in the three areas. One is diagnostics and discovery. Second is research for long term, and the third is medical devices, which has an electronic component in it, we are at MeitY, anything electronics, we are interested in both in design and development and manufacturing. So we look forward for a very strong partnership with AIC, CCMB and CCMB as well to drive this partnership to the next level. And with that, I once again congratulate the entire audience being there on this deliberation as part of the AI in Healthcare pre-summit. My best wishes to the team. I'm sure the deliberations will yield a lot of good positive outcomes which are important for Indian society and the health index of India. So we are here to support, we are here to facilitate, we are here to enable as much you need to ensure that we move towards a self-reliant India in healthcare, in medical devices especially, and more importantly, deliver affordable and effective healthcare to the Indian population. That is my what I would urge you all to focus. So my gratitude to the AIC CCMB team for making this extra effort to be part of this. Thank you, Mr. Rao, and thank you, Ms. Ritika, for this additional effort. And wishing you all a very, very wonderful day of deliberations. And thank you. And my apologies for not being able to be there in person, but I'm sure I'll very soon be there in CCMB very soon. Thank you so much. Really appreciate it.
Thank you so much, sir, for taking time and joining with us virtually. Thank you for your kind words too. Next time we are looking forward to meet you in person so that we have a lot of time to, have one-on-one discussions. Thank you so much once again, sir.
Thank you. Thank you.
All right. So as we resume the Theme 3 session, next we have Dr. Kumara Sami Tangaraj, who is the CSIR fellow from CSIR-CCMB. So I invite you, sir, onto the stage.
Yes.
That's for online. Is it? Pointer I use. Good afternoon to all of you. Thanks to Madhu for inviting me to speak. Unlike others, I don't work on AI, but we use AI-based tool to address some of the issue in our own research. So also thank Madhu for giving me the opportunity to read some of the papers which are related to AI. To give you some information about AI, what happened in the last few years. Although today we talk a lot about AI, but it has been there for some time at least. During 2012 to 2016, that's the time that early machine learning algorithm have been started. Of course, that had a very limited genomic data integration. And the deep learning revolution took place during 2017 to 2019 that in fact improved variant detection accuracy from 95% to 99%. Therefore, there's a better accuracy of detecting the variations. 2020 to 2021, alpha folding breakthrough happened that had better looking at the mutation which affect the protein function and at the atomic level. Now, last few years, multi-model AI, that means that includes genomics, clinical aspects, imaging, and so on, so that gives very comprehensive information about AI, about whatever we wanted to look at it. But I'm going to give you a couple of examples where we generated huge amount of data. I'm sure that it is going to be in multifold higher than what I am going to show you. So that means those who are working in the field of genomics is required really good AI to solve some of the aspects which the genomic scientists require. So one is about Genome India. I hope most of you are aware. This is one of the national program funded by DBT. There are about 20 institutes have involved in that. And this consortium have sequenced 10,000 individuals from 83 population. Then you can imagine 10,000 whole genome sequence, how much data we have generated. Of course, you all must have read in the news that last year, Honorable Prime Minister dedicated this and announced that has been sequenced. And he also highlighted that it will help developing precision medicine. So in the early analysis, of course, using manual, we can't say manual because some of the manual are backed with the minimum amount of AI. That showed there are about 130 million unique variations in the Indian genome, whatever has been sequenced so far. So that is present in approximately 5,700 genes, at least one potentially deleterious variant. Mostly they're all heterozygous, but that might lead to recessive disease when heterozygous become homozygous. So this is one aspect. Second is another mission program on pediatric rare disease, where we are aiming to sequence 5,000 combination of both exome and whole genome, 1,000 patients and the siblings and parents and so on. Of course, that is been done by 16 institutes, and if they screen for the known mutation, they don't find any mutation, then they'll send the sample to CDFD. CDFD will sequence the whole genome or exome, and these are the pipelines that will go through, and ultimately is going to generate huge amount of data. Therefore, we require very strong AI-based system. Coming to what is the role of AI in genomics or genomics medicine, I'll just give you some examples of these two, about genome analysis and also about precision medicine. With manual, of course, you all know it takes a lot of time to analyze, but with the help of AI and ML, it is very fast, and so far we are not really aware of that what the sequencing the companies are using. But of course now every company probably using, but I am taking Illumina as an example, where they have Dragon, which helps us in analyzing and call for variants within 15 minutes of the exome and maybe 25 to 30 minutes of the whole genome. You can imagine that if you do manually, how long it would take, but with assisted with AI, it is much, much faster. And these are other examples. I'm sure that other companies, including PacBio, Oxford Nanopore, also will have their own AI-based system. The AI also powered the software called DINA. This is disease specificity fine-tuning via a seamless neural network. This is broadly applicable to all genomic foundation model for more effective VEP, that's a variant effective prediction in disease context. This offers a potential disease-specific VEP method for clinical variant interpretation. And the AI also useful for diagnostics when you have huge amount of data set. It improves the accuracy of the diagnostics and the speed. The tools which are used in AI can analyze data much faster and get the information. And the consistency, it reduces human error and variability in diagnosis. And most importantly, it's a cost effective for diagnosis. If you go on the other side of precision medicine, we all know that pharmacogenomics is coming up in much better way, that not every single individual can metabolize the drug at the same level because of the variations which exist in the genes that metabolize the drug which we consume. So therefore, that now things are being changed, rather than using one drug for everybody, and so the genotype based drug development is being happening. Just to give you an example, that there are certain drugs which are ineffective in most of the people. These are some of the examples. For example, antidepressant drug is ineffective in 38% of the people, asthma 40%, diabetic drug 43%, arthritis drug 50%, Alzheimer's drug 70%, and the cancer drug is the highest. 75% of the people don't respond for cancer drug. So therefore, once you have the genomic information and look at the variants which are present in the drug metabolizing enzyme gene, and that can be effectively used for development of a drug. How many minutes? 1 minute. Okay. So I'll try to go faster. So therefore, you can effectively group the people based on their genotype and develop the drug. And most importantly, what I wanted to highlight here is some drugs gives effect, therapeutic response. There's no response. Another one is adverse effect. That is even more dangerous. We try to give drug to treat the people, but we don't want to suffer them. Right? One example which I wanted to give you, the BCHE, that butyryl cholesterol enzyme, which actually essential for metabolizing succinylcholine, which is given at the time of anesthesia. It's a muscle relaxant drug. And so far what we have known about this is the population called Vaishya. So only Vaishya population so far known to have a mutation which actually not helping in the sense it's not help the people to metabolize the drug, break down. Therefore, most of them will remain in anesthetic effect for very long time. Therefore, it leads to apnea and sometimes paralysis and even leads to death. You can imagine the drug is given for some purpose, but we don't want them to dry. The point which I wanted to highlight here, not only to AI, the other part of it is that it's so far known, it is present only in Vaishya, but now we found 29 population is also carrying this particular mutation in heterozygous condition, but maybe after few generation there may be homozygous, and these 29 population also will suffer. So in terms of analyzing large number of data set, we need AI to predict these things very effectively, therefore we can avoid such kind of information. This is another example quickly to show you that the common drug, clopidogrel, I am sure that Dr. Krishna and others will highlight some of those. The cytochrome P450 gene mutation, which determines the efficacy of the drug, based on the data of 10,000 individuals, we predicted that 15% are poor metabolizer, 45% are intermediate metabolizer. That means only 40% of the people have effective response for clopidogrel. But the data which was provided by one of the companies, about 10 crore people consume clopidogrel every day, and the annual expense is 185 crore. Okay, so this also can be avoided, this remaining 60% of the people, if you have effective analysis of the genome, come up with new drug, we can avoid those things. Then quickly on the other side, I am not going into detail, that these are some of the publication which shows that how AI being used very effectively in the recent past, about risk assessment of diabetes, precision surgery and so on. And these two combinations, precision medicine and artificial intelligence, can help us in personalized care, clinical decision support, early diagnosis and detection, and tracking of the disease prognosis and so on. And just quickly about how globally AI being adopted. There are many countries. India is next to China in terms of deploying of AI, and this is exploring is much less, and some countries are overtaking that. And this is the genomic market worldwide given from 2023 to 34. You can see how exponentially it's increasing. And this is a final slide to talk about what we are expecting from the AI in the future. It helps in personalized medicine, real-time diagnosis, also remote diagnosis, and decision support tools. So with that, thank you very much.
Dr. Madhu to please felicitate Dr. Tangaraj sir.
Online.
జూమ్ అవుట్ అవ్వలేదు బాగా.
ఏ సార్ అవుతుంది సార్, అది ఇంతకుముందు సెట్ చేసాను మళ్ళీ పోయింది. సార్ ఆర్ వి ఆడిబుల్ సార్?
Yes, I can listen. Yes.
Yep.
Am I audible from here?
Yes, you are pretty much audible. Yeah,
Okay.
thank you, sir. Now, I would like to invite Mr. Nishant Verma, who is the Joint Secretary of Anusandhan National Research Foundation, ANRF, who is co-leading the AI leadership at ANRF. We are happy to have you, sir, virtually, and welcoming to address the event, and over to you.
Thank you, the organizers of this AIC, the organizers of this workshop, which is Reimagining Healthcare, the official Indian AI Summit, pre-summit meeting. I'm Nishant Verma, Joint Secretary, recently joined in NRF. Basically, I'm from the Indian Forest Service from Uttarakhand, cadre, and now on deputation to NRF. First of all, I want to thank the organizers for giving me an opportunity to talk something about the activities, about the overview of the activities that we have started in ANRF since its inception in 2024. And then I will be very briefly mentioning about some of the initiatives which have been taken up by the government in AI for healthcare. So these are the 2 points actually I would focus my address on. So first of all, I wanted to inform all the participants who are participating this seminar that since its inception in 2024, ANRF is positioning itself as a key driver of India's science and technology and innovation ecosystem. Within 1 year of its inception, various new programs actually for catalyzing India's research and innovation ecosystem have been started. Just to name a very few programs that some of the programs aimed at uplifting the university and university S&T ecosystem in the form of pair program or PM professorship program, Saral program. There is a program called Saral AI, which is basically AI-enabled democratization of research and knowledge diffusion. And then in the strategic sectors also, we have started some of the mission mode programs, like there's one program which is called Maha Electric Vehicles Mission, which is basically doing research in the EV cell technologies and grid integration. Also, we have started one program called Maha MedTech, and also one program related to AI, which is the AI for Science and Engineering, in which actually some AI models, open source AI models and data sets for national R&D. And we are in partnership with different ministries like METI, UBT, ICMR, DRDO, and also Gates Foundation. So this is an overview about the different activities that NRF is doing. And now very recently, you must have heard that one RDIF scheme also has been launched by Government of India, in which DST is our nodal ministry. But it aims to basically catalyze the private capital also into the sunrise sectors and the RDI intensive technologies. And after the launching of this scheme, it is a two-tiered implementation network that one special purpose fund has been created within ANRF, and the fund will be given to an entity which is called that second level fund managers. They are in the process of being appointed. Various websites and web portal also have been started for this purpose, and very soon we'll be appointing the second level fund managers, which in turn will give to the funding support to the companies, startups for taking research in the sunrise sectors and biotechnology related sectors. So this is in a nutshell about the overview of the activities of ANRF since its inception. On 5th of February 2024. Now, some of the initiatives which the Government of India that we come to know when we are working in this ministry in the AI for healthcare, like you must be knowing that through Niti Aayog, one of the program called National Strategy for Artificial Intelligence with healthcare and priority sector, that has this program actually has been started. And of course, there are some guidelines also which the ICMR has issued for biomedical research and healthcare, which ensures actually the patient's safety, transparency, and accountability. And there is a program, actually, some of the institutions like AIMS Delhi and AIMS Rishikesh, they have been designated as AI Center of Excellence to develop and deploy AI solutions in diagnostics, imaging, and disease management. And lastly, there is one India AI mission also, which is led by MO MITI, Ministry of Electronics and Information Technology, which supports AI research and innovation and startups, which have a specialized focus on the healthcare applications. So, in conclusion, we can say that there's a policy support and there's a support towards development of digital infrastructure and research funding and capacity building. So systematically, actually, we are promoting the adoption of the artificial intelligence in healthcare. The whole objective is to improve accessibility, quality, and efficiency of the health services across the country. So this is in a short uh, nutshell, we can the description of the various initiatives taken by the Government of India in AI for healthcare. So basically, all the initiatives can be categorized into various sectors. One is the strategy and the policy framework. Then there are some health systems which have been started, and I also talked about the AI Center of Excellence, and then support to the innovation and startups also, like government is providing funding, incubation support, and public-private, and also in incentivizing or developing a platform for having private partnerships to encourage the startups to develop AI-based healthcare solution. So this is a short kind of overview from my side, both about the activities of the NRF and also about the activities which have been initiated by Government of India for healthcare regarding AI. So this is what I wanted to do. Thank you.
Thank you. Thank you so much, sir. I'd like to invite Dr. Karthikeyan in joining me in felicitating Nishant, sir.
Yeah, thank you. Big fund which was managed so carefully, and it has made sure that many of the deliverables were met on a timely manner. Probably were crucial in making him step into this new role as the Joint Secretary of ANRF, which is again a very important body that will support research in this country in the coming years, and I look forward to his support and guidance for all the research community. Thank you, Mr. Nishant, for your time.
Thank you very much for giving me this opportunity to at least share some of my thoughts.
Thank you, Nishant sir. Thank you so much for joining us today. And on behalf of everyone here, all the delegates, academicians, and speakers who are here, we thank you so much for your time. And I guess everybody has had got some very good insights from you. We do hope that you will visit us soon in person. Thank you so much, sir.
Yeah, definitely. So can I log out now?
Yes, sir. Yes, sir. Thank you so much, sir.
Okay, thank you.
Okay, you can take it.
Next presentation.
मेरे लैपटॉप में नहीं है.
Okay, thank you, Ritika. Next, I would like to call upon Dr. Girish Verma, who is the Assistant Professor from IIITH, for his talk. Please welcome him.
Yes, yes. They are using. Forward your mic, this one. So, hello everyone. My name is Girish. I am from IIIT. So, first of all, thanks to ICMR for inviting me here. Yeah, it was very nice to see a lot of the startups and other colleagues here. So, my background is in computer vision and machine learning, and yeah, I also have some collaborations with the University of Leicester on using AI to detect defects in eye scans. So let me just get started quickly. So most of one specific problem that we looked at was called foveal hyperplasia. So it is looks at defects that happens in the different layers of the eyeball, and it has to be detected early. So the researchers came up with a grading system, and the question was, can we detect this using AI also? So we came up with a system which this was done in the early before 2020 in fact. So we initially came up with this system which actually gave very good accuracy, and we could actually compare with different doctors of different experience, and we could demonstrate that this system actually works to comparable accuracy to a 5-year experience clinician. Yeah. So of course, older people with more experience was doing much better than the model. So then there was another big problem that we identified when we started deploying the system, which was different hospitals has different devices. So one hospital has a device manufactured by one company, and another hospital has a device manufactured by another company, and you couldn't take one model developed in one hospital and deploy it in another place. So so we came up with a machine learning solution to it called unsupervised domain adaptation. So this ensured that you don't need to rebuild your entire model in the new hospital. With only very less data from the new hospital, you could actually transfer the model from one hospital to another. So so this is some of the data set that we used. So we also had access to this UK Biobank data set through our collaborators, which actually is a large data set collected from a lot of hospitals across the UK. Yeah. And we could take a model which was trained in Leicester and deploy it on other devices, data set from other devices. So we didn't stop there. So this UK Biobank also had data about the genetic data also associated with the eye scans of each of the patients. So you could actually use the model to find out scans which had defects and try to correlate it with the genetic markers. So we did the study, genome-wide association study was done, and you could identify some 40 genes that actually correlated well, and some of them was already known, but some of them was newly identified. So this was some of the study that was done. So at IIIT we did all the data processing, all the AA models training, and we had the clinicians access from the other side. So we did several other works. So one is related to this ocular motility. So ocular motility is measured by a complicated tool like this, which is cost a lot, and we could do this same measurement using a handheld camera, a small simple camera, and this measures how the eyeball moves and if it is synchronized. Yeah? And if there's a synchronization is not there, that means there's a defect, typically with nystagmus and so on. So we also built data set using specific tools. So one big challenge in building data set in the medical field is experienced doctors, time is very valuable. They have only very less time to work with them. So in a short time, you want to build a large data set to get them to annotate things is very hard. So we built a specific tool based on a machine learning method called active learning, which allowed us to build a very large data set with high quality annotation with experienced doctors. So they could quickly annotate a large data set very easily. So just concluding. We have a lab. We have good experience working with this medical data. We build tools for annotation as well as analysis of the data. So one more set. Yeah, that's it. So please reach out to me if you are interested in collaborations. We are actively looking for collaborations to do similar analysis. So thank you. That's all.
Thank you, sir. I would like to ask Ms. Ritika to please felicitate Dr. Girish. So we'll take the Q&A after the speakers are going to speak. So thank you for patiently listening. So next up in line we have Dr. Madhavi Shastri, who is the Executive Director at Schrodinger. So welcoming you onto the stage, ma'am. Yeah.
So, good evening, everyone. So, my talk would be a bit different because I'm into totally R&D. I'm working with Schrodinger, but I'll maybe differ a little bit from some of the points that the earlier speakers made. But yeah, it has been a wonderful lecture session with a lot of image processing and AI stuff, and mostly I would say ML stuff. So here, I would say that I'm going to talk about integrating AI with physics-based methods, which is very important especially in drug discovery. So my point overall would be that AI on its own cannot do everything. You need some science and physics-based techniques, depending on which field that a person is working on. So for example, if we just go back, sorry. Okay, so if you look at the past, when you have to understand any disease mechanism, people would do manual literature search, text mining, genomic proteomic analysis. And so the future would be like automated literature mining and target identification. This is one part which I don't think people have done it anywhere in the world yet, especially in drug discovery, for understanding this disease mechanism until the patient level market data, right from discovery, pre-discovery stage to the DC nomination to the FDA approval to the market analysis and patient analysis. Such a tool hasn't come up yet, and this is where AI can actually help. And then it also helps in discovery of new drugs. Earlier people would use natural products, random screening, then came up structure-based design, virtual screening, then automated experiments on chips, and now the whole drug discovery is done with generative AIs, LLMs and stuff. But again, I differ from this point. I'll let you know why. And then there are clinical trials and marketing the drug. Earlier, there would be small-scale safety trials, efficacy and side effects were tested manually. Now you see personalized precision medicines, faster regulatory approvals, and the AI designed drugs and LLM powered drug marketing is done, and digital and AI powered. So this is going to be the future, but not completely on its own. This is the belief. But I differ from this point, which I see in most places, because I believe science is very important in driving drug discovery. So what happens? So most of these places, despite massive advances in data collection, so they're all mostly depend on a certain concepts like one size fits all, intra-tissue, intra-patient, is not considered, and everything is mostly non-binary, and structure and disease biology. So all of these are still not addressed directly through AI. It needs a scientific intervention. So for drug discovery, physics-based methods become very important because they can help you to understand the mechanistic outcomes and then generalization beyond data. So for example, we have novel drug targets or rare diseases. You don't have data. You need to be able to predict things without having existing data. So anything that is entirely new, it becomes very difficult to use AI or ML techniques. So you would need physics-based. So eventually, quantitative decisions, again, you need physics-based methods. And to risk the reduction in all false SAR and physical liabilities, again, you need to ensure that you reduce late-stage failures. You need to have earlier failures if there is going to be a failure. So that the cost, it is very cost effective and time effective. So basically AI plus physics is the industry reality in drug discovery. And likewise in some other fields as well. Speed without physics increases risk, and physics without AI limits the scale. So AI is needed for large scale, and to understand all of this, you do need some of the methods, scientific methods. In drug discovery, we talk about physics and chemistry. So I'm going to just quickly give you an example of one of the very important programs that we had and where we came up with drugs for autoimmune diseases and all, based on a certain concept, which was about the waters in the pocket of a protein. So the complete binding of a ligand or a drug to a protein to address a certain disease depends on a huge thermodynamic cycle where you have a solvated ligand apoprotein, and then both of them get into bioactive conformation. And this part of the whole thermodynamic cycle is what is very elusive, and people couldn't know how to do it. And here is where, for example, let us look at the waters in the protein pocket. You have waters which have very high energy, unstable waters in the protein pocket, and you have waters which are very stable. The unstable waters, which are more red in color, if you can displace them with a ligand, then that adds a lot to the potency of the binding. So that could be a high probability of having a drug. Of course, there are other ADME and other related properties that need to be taken. So how do you throw this molecule, this particular water out, and how do you calculate its contribution to the binding of a ligand to the protein, so that the delta G is given as delta H minus T delta S. And what you normally see is, so we need to find out the binding of each of the water, the delta G, when it comes into the bulk into the protein cavity. And so H is the enthalpy contribution and S is the entropy contribution. The enthalpy contribution is easy to calculate because that depends on the forces and energy and the potential energy. And they are very easy to calculate through existing physics methods. But it's an entropic term which requires fitting some sort of a machine learning and AI based on large data to fit to a certain equation to calculate the entropy. Entropy, even by the way, plays a very major role in all of these binding processes. So you have an equation which looks like this with all of the distribution functions. Because I'm basically a methodology person, I like to show some equations because I'm very comfortable with those. And then after that, we end up fitting those equations to using certain thresholds to eventually find out the binding free energy of ligand and proteins. So we use this method for one of their systems. I'm just giving you an example. We do it routinely in our drug discovery programs. I'm just giving you an example where we started off on a HCA to human carbonic anhydrase, which actually is expressed in osteoporosis and renal tuber acidosis. And so to do certain calculation, it's very important that the protein system that you find from X-ray or cryo-EM or whichever methods has several issues, like it has bad flips, unusual charges on residues, and all of these need to be addressed before you do any calculations. So there are algorithms to do all of that, which are again based on AI, ML techniques, mostly ML here. And okay, we published this way of doing, and we had some 6,000 citations. I'm the first author on this. And so we looked at certain mutations possible through bioinformatics analysis and did these mutations. This work was all done in Harvard, and the experimental work. And then we tried to see that all of these mutations and the influence on the ligand binding of a mutation in a protein, can we have a method or model which can predict that and actually compare with the experimental data. And we could see that we could compare all of these with experimental data. And what we really found is there are high energy waters in the pocket of these two ligands. And when you do a mutation of a residue, these mutations forces an enthalpically unfavorable rearrangement of these waters. So when these waters become enthalpically unfavorable, then you push those waters out of the cavity, then the binding of these ligands to the protein becomes more potent. The binding free energy is more stronger, and then that helps in discovering new molecules. So using that thing, we had synthesized some compounds, and that is a high energy water, and we see all those molecules which throw this out have a very good potency and binding to the protein. So this was one of the techniques that was used, and then a new company got started. There was a new company, and then it went into huge deals with several pharma companies. So, and then you talk about free energy perturbation. That's a completely a very intense molecular dynamics simulation, several simulations, and we could see that by using this particular data here and combining it with FEP, we could actually correlate the data for these compounds and their binding affinities. So here we are doing a validation of the methods. Now what happens when we have a large number of ligands? And when you have a large number of ligands, the complete data set can be in billions of compounds, right? Millions, billions. So we do active learning workflows based on physics-based scoring, and then you do an ML prediction to actually reduce this data set size to a small set which can be synthesized and then tested in the biological assays and in vivo assays. So, so we do active learning, absolute binding, active learning, FEP+, and okay, that's only the process. So the key takeaways in this whole presentation is, this was one of the I should say methodologies where we saw that water organization controls the enthalpy entropy driven binding. So to discover drugs, it's very important to take the entropy part and the enthalpy part in a very accurate way. Enthalpy is generally taken care of, but entropy is the most difficult part to calculate. And then hydration dominates the thermodynamics for this ligand binding system. And then this was a method that we used. And then to extend this approach to a huge, large data sets, we used the active learning accelerated FEP. So this is an example, and I would say that, oh, sorry, I think I missed one slide. Yes. So this is typically what we do in all of our drug discovery programs, where we come up with compounds that could have a clean ADME as well as binding affinities to take into the clinical trials. So yes, so we use AI and physics-based methods together. They both complement each other. AI cannot replace a complete science or a scientist, and this sort of a method will eventually work. And we should know when to use AI, when to use ML, and when to use other techniques. And that's a very important thing, because we hear a lot of AI and there's a lot of buzz around it, but we need to be very careful of what it can give and understand what it cannot. So this is the key takeaways which I was just talking about. So thank you for the organizers, Dr. Madhusudan and Ritika, to invite me here to talk about all my colleagues in Schrodinger, and investors are David Shaw, Bill Gates, and others. Thank you.
Thank you so much, ma'am. I would like to ask Dr. Madhu to please felicitate Dr. Madhavi Shastri. And finally, in this theme 3, AI in Healthcare Research track, we have Mr. Sushil, an independent consultant on new biological entities, to give his talk.
Dr. Sushil, that's okay. Don't worry. Yeah.
Good afternoon, everyone. It's nice to be here. I'd like to thank Madhusudan Rao, Ritika Marampalli, and YSSV Prasad for having me here. Today, I'll be talking on what is coming ahead, in my opinion, in this field. Although our esteemed last speaker warned us of the hazards of too much AI, I'll include a little bit of science here and there, experimental science, but it'll mostly be AI in terms of foundation models, okay? The premise is that at one time we were like small children learning how to read DNA. We moved on to editing it. And now we are trying to write our own books, become authors, so to speak, for this giant tree of life, okay? The scaling up, so to speak, when you go from starting with just sequences, proteins or DNA, it doesn't matter, to larger scale is that you have to look at the system as a whole. Instead of just studying one gene, which was, I think, the way it was done for many, many years, right from the 1920s. Now we have to start looking at things in a larger way. And I've illustrated two very simple examples. One is of a plastic degrading enzyme, where you have a system where you need to try to do it in a bacterium. That's what we want to, get rid of all our plastic waste. And the way it would be done would be to take enzymes, which have been found in nature actually, that would have to work in synchrony. That is because the first step, which is by PETase, gives rise to a product, and that product itself can inhibit the PETase. So you have to be careful. You have to quickly remove that intermediate in between the harmless terphthalate at the very end and this one. So how do you do this in a constructed system of your own? You have a gene for the PETase enzyme, you have a gene for that, and you want to make a plasmid. Up to there, we are doing fine. But then, how do you make sure that these two work in synchrony? There's more of the second enzyme, so that you make sure that there's not enough of that particular substrate lingering around, okay? And for this reason, you need to go to taking a look at the grammar of the genes. That is, between these two genes, you will have an intergenic spacer, and in that spacer, you want to introduce elements that would ensure that the relative levels of these two transcripts is matched, okay? And that is where we'll be slowly coming towards the foundation models that I'm talking about. Another example, very similar but more closer to human health, has to do with the chains A and B of insulin. if there's too much of chain A or not enough of chain B, then you'll have the formation of inclusion bodies, which you want to avoid. To overcome this, you come out with a method of balancing the levels of these two transcripts so that when they are translated, you end up getting just the right amount of A and B, and you get a healthy batch of this particular product. Genome foundation models are AI tools which are in many ways different from what we are most used to, the transformer models. Foundation models have achieved scales which are comparable to all your chat GPTs and so on, and they operate in terms of very different context as compared to transformation models. It's like comparing a microscope with a 10x lens with a microscope with a 100x lens. The 100x lens may sound better, but very often, especially in the case of things like genomes, you want to take a wider look, and therefore you want to go for a microscope which has 10x. Ideally, we should have a system where you are having both of them. That is, you're sometimes at 10x, and now and then you go to 100x just to take a closer look. That is what the hybrid model, that's EO2, that is there, can be seen. This is just a slide which illustrates the numbers which goes with this in terms of, like I was talking about 10x versus 100x. This is a reflection of what size of the context can this particular foundation model examine at one time. Until recently, it was about 131 kilobases. Now it is reaching 1 million nucleotides. The jump is significant, but that is kind of become expected of this field in the last few years. The progress has been dramatic, to put it mildly. At this size, that is, when you are able to look at something at a dimension of 131 kilobytes, you are able to get much larger features of the genome. You are more or less looking at it as an architectural entity, not just as a sequence. And that is what is going to be of great use in the near future in terms of how we will examine things. I'll come to a few specific examples on this in a while. According to reports, what we are going to have next is whole chromosomes being examined as single entities, but that will be interesting too. Now, DNA is a repetitive structural molecule, and these patterns can repeat over very large distances, actually. And therefore, it is not quite as comparable to a book, a literal book, that is, as most people would like to believe. Because in a book, what happens is that something which is there 60 or 70 pages away, one small difference in a word may not be of great relevance to what you are reading right now. Unless, of course, someone's written a very clever murder mystery or something, and there's a clue buried far away. But in the way in which we look at the molecules that are interspersed through the DNA, you will find that there can be regions which are up to 500,000 base pair away, where if there is a mutation, it will affect the functioning of the gene of interest to you. And therefore, the larger the viewpoint, the larger the context that you take, the better are you likely to understand what is happening. This particular model that I'm talking about, EO2, which is also a genome foundation model, acts like a filter, like a radio frequency filter actually. It's a mathematical filter, and in that filter you can take whatever parameter you want to look at, whether it is a pattern or you're looking at the processing of signals. The models will work towards trying to get you the right motifs or the repeats of the motifs, or able to distinguish junk. I mean, the junk is not a good word to use. Distinguishing junk from the of molecules of interest, or rather base sequences of interest. How does it get applied in the field of cancer research? I've just taken one example from recent literature where they have tried to get this business of trying to look at things, non-coding regions which are very, very far away from the gene of interest, and seeing if you can make a correlation between what is happening. What we know is that the enhancer actually ends up in the physical vicinity of the gene, which is why you end up having this medulloblastoma or glioblastoma kind of tumors. That's because there's been a gross rearrangement of the chromosome, but a sequence will not tell you that there is a gross rearrangement, okay? So what you have to do is to take a look at it from a foundation model, which is examining very large stretches of DNA at once and showing that in the region of the enhancer, which is 500,000 base pairs away in this particular case, there is a mutation, and due to that mutation, there is a powerful switch happening, which ends up in the physical translocation of the enhancer, moving from very far away to very close to this gene, and therefore affecting it and turning it on, and therefore leading to the tumor that we are talking about. Similar thing has also been shown for gliomas, the stem cells of gliomas. Again, it's a case of a enhancer being hijacked, so to speak. Second example I'll just make some point about is viral genomes. Viruses have been in the news ever since we had the COVID pandemic, and a lot of work, a huge amount of work has gone into understanding them and also trying to use them. In more recent past, we have had phage therapy coming into news with more and more antibiotic-resistant mutations being found in pathogenic bacteria. The attempt is to try to use bacteriophages to kill them, except that, if you use a bacteriophage, the bacterium is not going to be very happy. It doesn't want a virus entering it. The virus has devised mechanisms to overcome this, to hide itself from the bacterial immune system, the CRISPR system, but then it may not work. So a tailoring needs to be done, and this tailoring requires you to study the whole virus as a single entity. Again, we come down to what we were talking about in terms of using foundation models to look at the whole genome as a single entity, the whole genome of the bacteriophage as a single entity. I hope I'm not going too fast. Are you all with me here? Thank you. When we have a vaccination reaction, this is something which again has been much in the news. What is happening is that your body is reacting to the, whatever has been injected into you. And if it's a mRNA, there have been a lot of reports that mRNA vaccines are more likely to cause reactions as compared to our old-fashioned vaccines. And therefore, the solution would be to try to make it such that your body is less likely to recognize the mRNA as a foreign entity. How do you do that? You try to retailor the enzyme system so that when you have the sequence of the mRNA remodeled, it should resemble the human system. No worry. So this is a way in which you try to make sure that your system is not going to react to this. Also, sometimes you have these molecules folding upon themselves, which is again an undesirable property. This too can be corrected by using mechanisms in which the whole structure is modeled as a 3D entity, so to speak, using foundation models. Same thing goes for long-range rhythms. That is, you have cases where, like if you take, for example, histone. Histone is where you take a DNA and you tightly wind it around a bunch of proteins, and the repeat is roughly 147 bases on and on and on. Can a system recognize this kind of a repeat and says that this is a point at which the histone is letting go of the DNA and therefore a point at which it can open? This is something which has recently been of great interest, because you know that every time you want to say, go in for trying to find a inhibitor of a particular phenomenon, can you do it by using techniques of recognizing long-term patterns? This recognition does not come easy, and therefore you need to kind of work out signals which will give you an idea of what is going on. In this case, for example, the metabolic control of purine synthesis Purine is used in chemotherapy, and again, it's used in chemotherapy of the tumors that I had earlier talked about, the medulloblastomas. And what happens is that when you take this particular system, you will notice that its control is different in the cancer cell as compared to your normal cell. Your normal cell, the clock protein makes sure, the clock system makes sure that purine synthesis is regulated by time, whereas in the case of the cancerous cell, there's no control. It's chaotic. It's making tumors. It's making this system produce purine for its growth all the time. Okay, so in that context, what happens is that the system tries to cheat and ensure that there's enough supply of purine for the cancer to grow. So how do you control it? Use metabolic inhibitors, but you also know when to use them. In your body, your normal system is not making purine at night, so you use drugs which will inhibit tumors at night. That's an example of how to work. Last is using these same techniques. Can you make a large atlas of synthetic DNA which will give you sort of a library, a database or library of new molecules, of new enzymes, new proteins using existing knowledge. And this is what the syngenome is about. This has also been done implementing the Genome Foundation model EO2. And what you are ending up, and this is actually available online now for people to go and kind of fish around and see if they can find any ways of finding a protein which resembles a protein that they want. Suppose I'm looking for a protein for plastic degradation. Can I use a Go term for plastic degradation? Go into this database of 120 billion base pairs totally, each roughly 5,000 bases each, because the average protein is 300 amino acids, that is about 1,000 bases. Then you have flanking regions. And then you try to put it up as a filter for producing one particular synthetic gene which may function in the context of degrading a protein. And this database has recently come into the forefront, and it's hoped that it will be used by people. I have started using it myself. It's very interesting, but it's still, what I'm doing right now is more like a Google search. Let's hope that one day something will come out of that. Yeah, therefore, finally, the goal appears to be to shift from trial and error to design and verify. And it is believed that tools like this will give a reduction in failure rates in laboratories by about 70%. This number has been calculated optimistically, you may say, but then it's definitely an improvement over much lower numbers in the past. Thank you all.
Thank you, sir. I invite Dr. Madhusudana Rao to felicitate Dr. Aleem Chandani. Okay. Let's now move into our fourth theme, AI for public health and ethical considerations, a timely session addressing some of the most pressing questions today. Each talk will be 12 minutes, followed by 3 minutes of Q&A. Our first speaker is Dr. Krishna Reddy Nalamala, director at the AMS Durgabhai Deshmukh Hospital. Dr. Reddy is a senior cardiologist bringing a practitioner's perspective on applying technology and innovation to improve public health outcomes. It's in that folder. This one. Wait, no.
I thank Madhu for this opportunity, and it's a tough time, almost towards the end of the day, to keep everybody interested. Just one small correction. I'm not speaking as a cardiologist today. I'm speaking on behalf of Access Health International, which is a global health think tank, mostly into the policy research and policy advocacy. So I play dual roles. I'm a cardiologist, also co-founder of Care Hospitals, but today's presentation is mostly with reference to how we are going to utilize a tool, a new tool, in improving the lives of the people. So I think we heard in the first session, post-lunch session, starting from the physical forces in designing and applying the AI in relation to that, drug discovery. And then the molecular interactions, the genomic interactions, then the personalized pharmacogenomics, the clinical medicine. These are all at an individual level applications, but ultimately what impacts all this technology power to translate into population level health benefits. There is a huge gap between what technology can do and how actually it is implemented in the public. So that's what I try to give, how AI can be brought into the public domain. Just a simple outline, since given the 12 minutes of time, I don't go into the details of use cases, challenges, policy options, ethical considerations, and finally, guidance to the public health agencies. I don't think any public health agencies are available here. There are multiple use cases. I mean, a health system is a huge complex system. So starting from your personal health care, you can use in public health, the difference between the population health and the personal health. There is a huge difference. Then you can use in the health purchasing, what we call strategic purchasing. That means how do you drive as an insurer the quality, the best outcomes at the least cost, using the big data and detecting the fraud, analyzing whether the outcomes are linked to appropriate evidence-based practices. This we do at PMJ, as a part of a knowledge partner to the National Health Authority, which is the implementing agency for PMJ as well as Ayushman Bharat's digital mission. We try to apply the AI tools to improve the quality of to the patient. Ultimately, the technology should demonstrate a visible improvement in the health status of the population. We also, I think the whole session preceding me was on the health research, the power of AI in health research, and also health professional education and training. I think this is another subject which covers the entire domain of health systems. Coming to the specific topic of this session in terms of the AI use cases in the public health, these are the common core public health functions, which includes the disease surveillance, the health monitoring and evaluation. That means what is the health status of the population in terms of the prevalence of the disease, incidence of the disease, and its outcomes in terms of the mortality and the morbidity. And thirdly, of course, is the epidemiological modeling, both for chronic diseases as well as during the acute public health crisis like epidemics and the pandemics. And fourth, a core function of the public health is how the public health system educates people on health in terms of the health literacy. Just like there is a literacy gap between illiterates versus literates, there is a literacy gap in terms of people what understand health literacy. What do they actually understand the health literacy? And more so with the infodemic of social media as well as the new tool, toy on the blog, ChatGPT and other things. There is so much misinformation. It's difficult now, at least as a cardiologist daily, I spend more time now to disinform what the patients come with after reading all these things. So again, these are some of the things which, how AI should be applied in terms of improving the health literacy. And more than the health literacy, it's not just information. How you actually apply these tools. If health literacy, the education posters are in English or Hindi, but the patient speaks some other language and the dialect. Now I think the AI has the power to translate same content in a way that that person can understand, that person can perceive, and that person can change the behavior. I mean, these are the things that we are testing in Chhattisgarh in terms of how to apply some of these tools in health literacy and behavior change communication. While the use cases are many, I mean, in terms of the disease surveillance during the COVID pandemic, you have heard an amount of AI applications, especially in terms of the big data analytics, like the mobility data. What Google Maps, if you see the mobility, if suddenly the mobility increases in a hospital, and that was the trigger actually to say that in that Hunan province, there is a sudden influx of the patients, even before it was announced almost 2 weeks before. So that was the power of the big data in terms of assessing what is the mobility type of thing. Though it was used during the COVID pandemic, I mean, how to translate actually into the normal times in terms of the public health surveillance systems. It demonstrated the power, but in terms of integrating into the normal surveillance system, you need to actually revalidate because during the crisis time, the law states that you don't have privacy. In the normal time, we have to preserve the privacy. So there is a total dichotomy in terms of how you actually is the same tool you apply during the normal time surveillance compared to the crisis time surveillance. So while the use cases are many, I think many startups think that this is going to change the public health. But the real thing is, what are the real challenges on the ground in India today? I think we have to be realistic as to at what level of maturity the country is in the digital health transformation. Because every system, every state is at a different level of health system, the digital health transformation. So whenever you apply a technology, you have to apply in the context of the journey, at the stage of the digital health transformation. If a state system is never used IT system for medical records, I mean, they're just using the IT system for billing. If you start with from that trajectory and talk of AI applications, it does not work. Because the data is, whatever you are feeding the data, the AI intelligence is only the quality of the data. So that is just the garbage in and the garbage out. AI cannot filter the garbage. So there is a huge infrastructural gap. I mean, in terms of, because we are talking of AI summit in the next 2-3 weeks, because as a guidance to different countries, especially the global south. I think this summit was meant for the global south. So we have to talk the AI application in terms of the language of what is actually applicable in our context. Let us not talk beyond what is applicable in our context, because we have to travel the journey of the digital health transformation. The human resource capacity, I mean, where are the health informatics people who understands the AI and ML? I mean, they don't understand the digital health. What about AI and ML? So we have to start from there. How do you build the human resource capacity to apply this tool? It is not just enough to have a tool. I mean, just like if I have a knife, if I'm not a surgeon, I will kill the patient. If I'm a surgeon and I have the skill to use that knife, then I will save the patient. The same thing applies to the thing. If you don't have human resources who are aware of the AI technology and its application, what are the unintended harm AI can do? I mean, I see daily, everyday patients, thanks to all these social media and the digital tools, the anxiety levels have tripled. So we don't anticipate that your watch is increasing your anxiety level. There is no regulation on that. It is unintended harm. What you thought a potential that you can continuously watch your heart rate is actually triggering anxiety. So just like any drug, the digital technologies, the AI tools have to be subjected to the rigorous, especially when you are applying into medicine. The first fundamental principle of medicine is do no harm. So did you establish so-called your AI tool is harming patients unintended? You never intended that, but the consequence outcome may be different. So you have to be self-regulated, because no government can regulate AI. It is a continuously evolving system. So we need to have a self-regulatory, a collaborative regulatory system, what we call the responsive regulatory system. So that's where it is coming to. I mean, in terms of the third challenge that we face is the change management. I mean, we have all the tools, we have all the infrastructure. How difficult it is to ask a doctor who never writes even a medical record to now start entering health data into the computer. So, in fact, when we are assisting ABDM implementation, the biggest challenge is not technology. The government has invested into the platform and invested into technology. The biggest challenge is people changing, people trying to adopt that technology. So these are another public health level issues that we need to look into that. All of us are now aware, I mean, everyday newspaper, suddenly there is a digital arrest or something. So the data privacy, the storage and security is actually increasingly we are getting disillusioned because every 1 week you suddenly say that all the airports are shut because the systems are cybersecurity. Something has attacked that. So we have to be cautious in terms of what AI can do, what data can do. In fact, in my own system, I'm very clear that I don't want to remove the paper. I will have the paper, but at the same time, I will capture my essential health data that is required to optimize my patient's outcome. Because I have a security, because patients who are not digitally savvy, you are creating a digital divide by totally making it paperless. So these are some of the implementation level issues in terms of there are variety of technology pitfalls. I mean, I think a lot of people in the technology space speak about hallucinations and the biases that are there. And most importantly, I think we should not create a new divide. Now, already we have enough divides: the caste divide, religion divide, race divide, literacy divide, rural-urban divide. Now we are getting digital divide. That is, people who are digitally savvy, who are not savvy. If they are not digital savvy and you are transformed totally to the digital environment, you're creating a new divide. So it has to be very, very cautiously at a policy level seen that you address the equity, the equitable access to all these technology tools in the population, and also avoiding systematic bias while training these AI tools on the population that you want to train. ChatGPT gives very convincing answers for every query that you give, but what's happening in the black box, we don't know. So now there is a explainable AI, at least it tries to explain how it has arrived at that conclusion. So still there may be, I think we need to verify those things. The third thing is in the policy options. We have the digital public investments. That is, thanks to Digital India policy attention, there is a lot of investments into the public digital transformation. I see walking up, and I have 1 minute? 3 minutes, oh, that's good. Then the digital public goods, I mean, most of the things that where you have the ABA ID or the PHR or the health claims exchange or the consent manager, all these things are nothing but the digital public goods. Because if the governments don't invest and only the private sector and the capitalists invest into that, then there is a huge divide. That means the inequity increases if AI becomes unaffordable. So that's where, from a policy perspective, we advocate that the governments have to invest into the AI infrastructure, the AI computing power, so that MSME, I mean the micro, small, and medium enterprises, they can also access the power of AI. Otherwise, they can't afford the power of AI. So this is what is called as DPI, the digital public investments and the digital public goods. In fact, as a part of the G20, Modi has offered that some of the things that we developed for the vaccine platform, as well as Arogya Setu and now the PHR and other things, to the global south countries, because these are digital public goods. That means they are open sources. People can actually access these open source tools for their own application without investing extra money into that. There is a responsive regulation. I think it's a session by itself. Then most importantly, I think what is going to make a difference is the public-private collaboration. What is critical for any potential for at a country level to happen, how the government is financing this, because already health financing is very minimal, less than 1% public health financing compared to any other country, even the low-income countries. So how it is going to finance this digital transformation of the country. Then continuous capacity building of public health workforce in AI application and oversight. ethical considerations, the human rights, promoting the common good, balancing between ethics and technological progress and innovation. So we have to balance, because we cannot put so stringent regulation that we are stifling the technological progress and innovation. At the same time, we should not neglect totally while it is causing immense harm to the population, because AI has the potential to cause immense harm to the population if we are not cautious on monitoring on that. So these are some of the guidance to the public health agencies and institutions, which I don't want to go to this audience. Before I conclude, I mean, some of these body of work is related to the work that we are continuously doing in the digital transformation of India. Starting with policy research on behalf of Niti Aayog to bring out options to transform India's health system. Then we were involved in the convening strategic discussions during evolution of National Digital Health Blueprint, NDHB. Currently, we are implementation research and support partner to National Health Authority for implementing Ayushman Bharat Digital Mission. So we are trying to understand what are the challenges in implementation and what are the strategic iterative changes that should happen ultimately to realize the potential of ABDM. Then we are in-house developing a lot of open source DPGs in terms of the health management information systems, EHRs, ABDM, enabled wrappers, and also the clinical decision support systems and population level health management systems to demonstrate actually on a scientific basis is actually AI application enhancing the value of care to the patients. So because if you don't increase the value of care, technology has no purpose. We were also involved in generating a report for Amazon Web Services on the responsive regulatory framework, international framework. Then we were involved with UNESCAP for the Digital Maturity Index calculation of different countries in terms of what is the maturity level. We are going to start a multi-country AI regulation maturity assessment on behalf of the WHO Geneva for Asian Development Bank. We run a special theme called Digital Health for Health System Resilience as a part of the Global Learning Collaborative. We actually compiled a model curricula for health informatics professionals by bringing together about 18 academic institutions in bringing out a model curricula for the country for different people. Health informatics for different people, doctors, the nurses, frontline health workers, health managers, public health professionals, and health researchers. I think with this, it's a broad topic, but I just try to give a gist of how the potential of AI or the digital tools have to really make a change in the lives of the people. I mean, unless it changes the lives of the people and unless it is accessible and affordable to each individual, it has no role. I think that's my concluding session. Thank you.
Thank you, Dr. Reddy. No, I think we can take one or two questions. Does anyone have any questions in the audience?
There is a fatigue. So.
Yeah. No worries. Okay.
Okay, thank you.
Sir.
Thank you.
Please wait for felicitation. I would invite Dr. Madhu to please felicitate Dr. Reddy.
Most of the CCMB people know me only as cardiologist.
No, that was very nice talk. I think it is too much to absorb. And give queries on that. Very nice talk. Thank you very much.
So Dr. Suresh, and then we have the panel. Our next speaker is Dr. Suresh Munuswamy. He's the Dean at the School of Digital Health at Malla Reddy Vishwavidyapeeth. Dr. Munuswamy is a technology and innovation leader with extensive experience in applying AI-driven solutions to real-world challenges.
Well, Thank you for the introduction and thank you for the invite, Dr. Madhu. It's always great to come to AIC CCMB and probably talk a lot of common sense. I'm going to talk something that is fairly very common, slightly philosophical, and broadly the objective is not to make you even more sleepy. It's broadly not afternoon and not evening, sometimes called as twilight. And I'll also come to why I'm mentioning this. Philosophical question is, what is health? You know, it's kind of a bit challenging because everybody thinks about healthcare only when you get sick. Otherwise, we are happy leading our lives, doing whatever we can, and then suddenly you fall ill and then you start remembering all the people who are associated with healthcare. Till then, you don't remember all the doctors, nurses, all the associated allied health people. And that's when, if you would want to broadly understand what is health, you will have to start looking beyond disease also. So if you want good health, broad common sense is invest more in positive life. And that's fairly a straightforward idea. But we start thinking about good life or probably life itself only when we are really sick on the bed. Maybe I should have done that, I should have done this. All those so-called philosophical conversations happen only when you are really sick. But if you want to convert that into some kind of a mathematical equation, if I want to increase the positivity of life and decrease or the negativity of disease, then broadly I can say I'm having a healthy life. That's broadly the idea. This is where it's fairly easy to say, but rather difficult to slowly implement. Now, when I say what is life, it's a very philosophical question, which probably everybody would want to answer in a different way, but we are talking about AI, which basically means data and maths. So in a very simplistic way, if you take my life today or your life today, thanks to Dr. Madhu, we have spent 8 hours of our life here. Tomorrow, Dr. Madhu's AI avatar will tell, please walk for 8 hours, and it will continue to talk for another 3 days on the back of our head, but that is not yet there. Maybe sometime later it will come. So today, we have spent 8 hours, and hopefully we go home, we'll sleep for another 6 hours, 7 hours, and then in the middle we'll be eating, and probably another purpose of this event is networking, so we'll be talking to each other. So broadly, this is what is life in a very practical way. And that's what this actually says. We do some paid work, we sleep, we socialize, we eat, we network. But how do we convert all this into data? Because if we do that, then your data points will also tell that you have been sitting far too long today. So we'll have to compensate for all these things in the next 2-3 days. You've been listening far too much AI today. So maybe for the next 2-3 days, let's not listen to AI. So you need to slowly start identifying what is your life and then try to find the so-called right optimal life. And that is easy to say, but a little bit difficult to do. Now, if you want to extend a little bit further, I heard a speaker talk about exosomes, still finding it difficult to pronounce it. So if you want to database your life, then a lot of us here talk about genetics, biology. Unfortunately, it constitutes only 22% of whatever your so-called life, the way that you actually live. And in fact, if you look only at genetics, it's less than 10%. Now, there are a lot of intermediates here, which actually is what connects your life to where you are actually starting genetically. And those intermediates are your individual behaviors. Each of us lead our life in a very different way. Our social circumstances are very different. And again, there was another researcher who spoke about a particular community and how it exhibits responses in a very specific way. And that is actually a variation. Not everybody leads our life in a very different way or very similar way. And then there is medical care. Access to it again is very different. And even the physical environment wherever we are living is all very different. Again, all these things are fairly known. The challenge here is how do I convert this into data? Because if I convert this, if I know my physical environment, if I know my individual behavior, and if there is something that is going to whisper into my ear every day saying, eat this, maybe walk for so long, or probably stand up, or maybe don't talk too much. If I do this every day, then potentially, again, reinforced behavior, behavioral change, communication, all this can actually be practically implemented, and that is broadly a very challenging situation. Now, add one more challenge to this. Thankfully, we are all living longer. Average life expectancy, even 50 years before, was 35 about in our country. Now it is 72. And if you push a little bit further, 100 years, 200 years before, your average life expectancy was only 25. Now it is 72, and in another maybe 20, 30 years, we are all supposed to literally grow older and live older. Average life expectancy in some countries have already reached 80, 90, and hopefully will go to even longer, which broadly means that whisper that somebody has to tell in your ear has to be done for so long, and that is extremely challenging. It's not going to happen physically, or it's not going to happen normally. So again, if you want to put a number to it, I came out with this number of 44,000 days. 44,000 is an approximate number, which if you are going to live 120 years, is how many times that AI should be whispering in your ear telling, do this every day. That's not practically possible. All the data that needs to go into that is again challenging, and that's broadly the challenge here. But if it can happen, potentially you can have negative disease and positive life. So if every day somebody keeps telling you, probably after the 100th time you will start doing it. Maybe after the 1000th time you will start doing it. Thankfully, there are 44,000 times that you can be told, because after 1000 time you will just follow. That's also called as Goldilocks days, and there is also an Indian version, which is why I said it's not morning, it's not afternoon, it's not evening, it's twilight time. If you remember Narasimha Avatar, Hiranyakashipu was killed because he had a boon. He cannot be killed by a man, he cannot be killed by a demon, so he had an avatar. So that's just the specific point. If you can all live your life in a very optimized way, then potentially you can lead a positive life, negative disease. Again, easier said. I'll just quickly go to what we are doing. There are also even more challenges in healthcare. Again, as my previous speaker, Dr. Krishna Reddy mentioned, public health has a lot of challenges. Individual medicine also has a lot of challenges. Key among them, 5As and 6Ls. I will not expand to it. Even more challenges. As an average, Indians go to a doctor only twice in a year, compared to 13, 14 times in countries like Korea and Japan. So basically, all your life, all your disease is managed by those 2 visits. And even that time, the doctor sees you like, 5 minutes, 10 minutes. If you are very lucky, maybe 30 minutes as they write in the textbooks. So an hour multiplied by 72 hours is your entire time you actually spend for your health care. So if you are able to do it a little bit more frequently, maybe once in a month, maybe once in a week, or even once in a day, you are exponentially increasing the amount of activities that you are actually spending for positive life. And that again is extremely challenging to do, very easy to tell. What you need for all those things is data, and again, they're very difficult. Not just data, but you need a mechanism where you can collect data rapidly, reliably, and repeatedly. If you can do that every day, fantastic, because you can analyze it quickly and you can tell something back to you, and hopefully you follow, as I said, the 100th time or the 1000th time, and things will be a lot better. So that's what we developed, a sort of a contraption here. There are a lot of challenges to this. One of this is the language itself. So we came out with an entire UI that does not have any language in it. It's got completely icons only. India is the only country with 22 official languages. all diseases are signs and symptoms. We converted them into icons. Now we are standardizing them also. And then the interventions also, we kind of took language out of the equation. We built around 30-second, 45-second videos. It shows the products in a very standardized way and tells you the processes. Follow it. Hopefully, you'll be learning something. And we put that into the hands of healthcare workers, trained healthcare workers, bought about 200 phones. And a lot of remarkable things actually happened. We identified about 5,000 new cases of lymphatic filariasis. We focused on lymphatic filariasis because our donor asked us to do. Although this platform can identify 150 common conditions, head to toe you can actually screen. And you see that before and after, the swellings have actually come down, and this is not because of doctor visit by a healthcare worker trained within the community, going to homes almost every other week and then telling them what to do, simple exercises, how to keep the entry wound clean, and you can see really remarkable changes. I've shown only about 3 images, but we actually have images of about 350 people, which is not a small number, fairly in a given population. And we also trained our artificial intelligence algorithm to broadly predict. And funnily, AI is also close to this, within almost a 5% difference. So realistically, we can predict how it is going to improve, or tell the patient that if you don't take these tablets or don't follow this, it will actually get worse. And those things we can convert it into images and also train them and show it to them. We also built devices because presently we are limited by the camera on the mobile phone. So now we are trying to bring together hyperspectral imaging, sound and light, so that we can actually look deeper, and the more you look, the more data that you collect, it's going to be much easier. There are some physical products also, but I'll skip those things. Recently applied for a patent. We also applied for around 23 patents and got it awarded for a lot of small parts. This is one whole patent. But this whole platform needs still a trained healthcare worker. It's not going to go along with you. So now we are actually building a robotic dog which will follow you with all the sensors. It will also talk to you, and it will also keep tracking your life. I mean, the security, privacy, we'll talk later. That's a separate discussion. But the idea is, as I said, documenting your life needs to be done. Databasing your life needs to be done. And we are trying to build a dog which can walk around with you with all the sensors and then start documenting your life. But even that, I think, is going to be complicated because it cannot see you 360 degrees. So we are building a drone which will fly out of the dog and hopefully kind of take photos of you at specific points. Maybe while you are sleeping, it will be watching over you. A lot of people die of heart attacks during sleep. And if there is something that's actually watching over you that can give you a call, maybe you could be saved. So a lot of things. Probably in about 2 years or 3 years, I'll be walking around with a dog. These are also PhD topics of my students. We're also building digital twins. So with all the data, we need to replicate you virtually. And then once we replicate you, we can project your life, tell you how your life is going to be 5 years, 10 years down the line. It need not be perfect. I mean, all we want you to put into that so-called Goldilocks zone and say, okay, live this life this way, and then hopefully tell you 100 times or even 1,000 times. In our university, we are building this digital twin lab. That's a real photo. Hopefully, it should be up and alive in another 1 or 2 months. We're also building robotic labs because we need a lab to build our dogs and build our drones. And that's how we are planning to document the life and maybe build an AI agent which will talk to you in your local language, understanding whatever you are doing and telling you how to lead your life in the right way with all the data from you and for you. No data is being sent out. So relatively not much of a privacy issues. Everything happens on the device. Everything happens with your own data only. And broadly, the idea is presently you are born, you are active, and then slowly you degrade, and then slowly you die. But the idea of AI plus life is you maintain your so-called vitality and maybe adolescence, the youth, as long as possible, and one fine day, well, God does make the decision. That's our idea of digital life, AI for long life. I'm also running a podcast. You can listen to more of my talks if you are still interested and not sleeping. Well, so far, thank you listening.
Thank you, Dr. Suresh. Are there any questions? Okay. Great. I would request Dr. Madhu to felicitate Dr. Suresh.
There's always something new, sir. We kind of are in the same events. But, please do
Thank you for your patience. This was the end of theme 4. We will be having a panel discussion in a few minutes. So while they are setting up the chairs, there's refreshments outside. So you guys can just go and grab some refreshments and come back. We'll be starting the panel in 5 minutes. Yep.
T-Labs, we focus and we truly believe that the future of AI in healthcare in India is built with this collaboration in between the research, innovation, and healthcare systems. And today's discussion has actually, put a concrete stone to that belief. So with that, thank you so much to all the speakers who had joined today for their valuable insights. And without any further ado, we move on to the last segment, the concluding segment of today's session, one that brings together the very pillars required to build India's future in bio-AI. For the next discussion on co-creating India's bio-AI stack, I invite our distinguished panelists to take our stage as we begin. Dr. Madhusudan Rao, CEO, AIC-CCMB. Dr. Venkat Shashidhar Manda, CSO at Apollo Hospitals Educational and Research Foundation. Dr. Rashmi Pimpale, CEO, Rich, Hyderabad. Mr. Vamshi Yadav from Vadhwani Foundation. Dr. Kiran Malkote, VP, Strategy and Growth, Avanya Strategy. And to lead this important discussion, we are joined by Professor Madhu Vishwanathan from the Indian School of Business, who is the Research Director at the ISB Institute of Data Science. Over to you, Professor.
Okay. Am I audible to everyone? All right. The last event of the day, and I think it's actually well set, and I want to thank the organizers for setting it up in that way, because I was here for a lot of the early talks, and it was wonderful to hear about all the advances that's happening in different parts of this AI, healthcare, and bio as such, right? And, I started off as an engineer. I was a data scientist at one point. And so a lot of the talks basically resonated a lot with me, and it made me wonder what I'm doing in a business school. But I also realized that being in a business school is that in today's world, I think technology advances have been very rapid, but the adoption of these technologies have not been as rapid as we would wish. And I think if you look at all the advances in AI and healthcare especially, it's no longer about model accuracy, but mainly about deployment, validation, and trust. And I think we had a few speakers before us talking about a lot of these challenges and issues that are going on. And what you're seeing, of course, not just in India, but across the globe, is widespread adoption of AI, especially in healthcare. And the surprising part is not a lot of these efforts are scaling, right? And what do we know with at least evidence in terms of adoption is a large majority of these AI pilots never move beyond this limited deployment. And it's not because these algorithms fail or because validation, pathways, workflow integration, or regulations remain unresolved. It's just that there's something that is missing in this whole chain that happens, right? And especially in India, right? I think we are sitting at a very interesting inflection point. We are right now assembling pieces of a national biostack, and we're going to have a summit which is going to be about that. There are a lot of large-scale data initiatives, the Genome India projects happening, national platforms, India AI Mission, AI Kosh, a lot of AI infrastructure setups is going on. And a lot of this is going towards AI for biology and life sciences. We see that happening. And there's also good academic setups that are going on. I think there's a lot of good work at AISC, bioincubation hubs are happening around major hospitals. And a lot of this is trying to bridge research and deployment, right? Now, what I want to work on, and this is hopefully what we'll hear from this great set of panelists who are coming from very different backgrounds of this ecosystem, is essentially to think in between on saying, how do we move from successes in different parts of this ecosystem to making it work for the whole? Right? And that's what we want to focus on. And when we're looking at building India's biostack, right, the real question is not what AI can do, but what it takes to move from these isolated successes to systems as such, right? And that's the goal of having a biostack, right? I think earlier, I think it was 3 talks ago, where we were talking about, using the UK data sets to build a very nice prediction system, right? Do we have such setups where India can then leverage, and researchers in India, hospitals, the whole ecosystem can utilize that to create something of value for India, right? And that's what the focus of this panel is going to be. We're going to talk about some real use cases, what has worked, what nearly failed, and what we need to build collectively in bio AI to scale responsibility. So that's basically what I wanted to talk about in terms of saying what we want to do. It's, like I said, a great set of panelists with very diverse backgrounds. So I'll start by asking each one of you, and let's work in the cycle where I want you to give me one concrete example of a use case that really resonated with you all. And when you're thinking about this use case, and we've heard quite a few over the day, is what worked, why it worked, and what almost broke, right? Let's start with Vamsi.
Thank you, Professor Madhu. Hope it's audible. Yeah. So I would like to add in one of the use cases I recently studied in the space of radiology triage, where it was using an AI to kind of reduce or give some relief to doctors in terms of prioritizing which scan should position at the topmost in a bunch of different pool of data sets. So essentially what it did was, let's say if we have 100 MRI scans, it gone through every data sets, it studied, and it organized in top 10, giving it a specific serial number of these specific patient requires urgent attention because he's having a critical issue. And that kind of reduced some level of dependency on doctor, but at the same time, few things didn't work out. Reason being very 2 basic aspects. That is, one is intention and trust. Specifically when it comes to healthcare, almost AI is being used in almost all the aspects of our life in nowadays. But when it comes to healthcare specifically, it requires a lot of trust building aspects in between doctors and patients. And even if that trust specifically builds at a specific singular party, that is doctor, but also that requires some level of responsibility on the shoulders of hospital. So due to which the AIs started hypothesizing details and answering hypocritically, saying that this serial number is now being tested critical, while when they manually checked the reports, he was actually fine. So yeah, that's one of the cases that I recently come across.
So let me prompt you a little bit, right? So over here, you were talking about
radio. Yeah.
Did this move beyond a pilot?
Yes, it moved beyond a pilot, to be honest.
And what was the biggest thing that you think they underestimated or overestimated in terms of its implementation?
So they have overestimated that the model could actually handle big set of data. Because they see building a product in a laboratory is different and taking it to real life is different. So when they were doing tests in a lab, it performed really well. But when it comes to our day-to-day life scenarios, it started performing at a lowest rate, and due to which that's when they realize that we need to get back to whiteboard again and we need to build it ground up.
I'll come back to this because, sometimes an implementation that doesn't work can lead to a bigger damage than a half-hearted but still trustworthy implementation, right? So let me shift to Venkata here and have his opinion on these things as well.
Sure. Thank you. So I'll just take his story further.
Yeah.
So basically, there are many reasons why AI can fail work at the lab level and why it fails during the scale-up process. So when you say it is a bio AI stack, there's a different levels, right?
Mm-hmm.
So you have the compute stage, then you have the validation stage. I mean, there are different things. The validation stage, then the deployment stage, so there are different stages in the whole process. So in every stage, there is a front end and a back end process, and there is an intermediate process which ties up the whole ends together. Generally in a controlled environment, everything works, sort of. And as you scale up, these things come into picture. And most probable reason is the clinical validation.
Okay.
That's the patient data or the patient end, which is the major culprit, not entirely, but the major culprit in the whole story. And further, it's a common phenomenon that, okay, this data has been generated with an X machine, this is generated by a Y machine, and then there is, so that is the technical reasons that are there. So most of the time science, what I believe is science is almost 90-95% it works. We know that the science works. But the actual implementation is where it fails. That the execution is where it fails. That is what I have saw in many other things. So at my capacity in the Apollo Research Foundation, so I wear both the hats. Like I take care of the research activities, and there are many startups who come and pitch for the AI models. And in our research foundation, we also develop AI models. And so I sort of know where things go wrong and how actually that can be corrected in the sense. So the major area I feel is the clinical validation and the deployment. And it is also one of the major reasons why hospitals also sort of be very cautious during adoption of these things, because it's a very gray area, right? Like it's a legal thing that comes in slowly. So
I'll push you a little bit more also on that, right?
Yeah.
So you started off with almost model, compute and everything. What about data? Do you think sometimes the data that you use to train your models as well becomes a big part of the prediction, the accuracy?
Sure. Data is the oil, right? The data is the oil and the model is the engine that drives the thing.
Right.
So the oil should be good, it's filtered, clean, and everything. So that is most of the times, as I said, the machines which generate the data, or it's structured data, unstructured data, again it comes. So it depends upon the end AI model one is developing. Like if it's unstructured data, like the cough, the doctor's notes and other things, and if it's the structured data, that is the lab developed data. So, and also the machines, the calibration of the instruments, the calibration of the standards. So all of this, like quality cannot be developed at the end of the thing. Quality has to be developed through the whole process.
The collection.
And it's a collective effort that finally leads towards developing a best AI model. So it cannot be only at the final stage you got the data and you have you're developing a model and it should work. Okay. But and the annotation of the whole thing, it's the efforts by the whole process. So it's the entire A to Z process that needs to be calibrated and standardized at each stage to get a final version.
Okay. Good.
So
So if I were to take a step back and look at history, I mean, the whole hype around AI right now, I think we need to draw a few specific parallels. If you look at maybe a long time back when nuclear power and solar power had come in, right? Before one was safe and the other was efficient. Unfortunately, they were overhyped. And that led to downfall. I think we draw the same parallels for AI in healthcare and life sciences. Don't aim for speed, aim for trust. And that will come with what Sir had just said, rigorous clinical validation. And just a few days back, I was going through the ICMR's guidelines for AI in healthcare and life sciences. And one thing I was really upset about, in fact, when I saw the whole guidelines, they always want a human in the loop. They always want a clinician to take that responsibility or the liability part. I was a bit surprised because I felt, see, if you're using AI, the idea is to speed up the process. And then you put a human in the middle, how will it speed up? And then I realized, see, if you screw up over there at that sort of 5% of edge cases, you screw up, you lose trust. And then you lose trust, it's a problem for the entire AI ecosystem. So even though ICMR, we blame them for being in their ivory towers most of the time, but I think this part they may have gotten right. So looking at that macro level perspective, maybe we need to aim for building trust, and that will only come with rigorous clinical validation. And going back to the first question, I think my favorite use of AI has been something that was already spoken by Dr. Rakesh, where it sort of frees up the doctor from documentation. An ambient AI listening to the sort of conversation between the doctor and the patient. I would love to have that in my clinic so that I can give them my full attention and it's working with me as a co-pilot. It's doing a task shifting. I no longer have to type notes, but I can trust it enough to know that it'll give me a structured output. And I can always edit or modify or take over the reins whenever I wish. But at the same time, see, one thing that we also need to realize is if I want to use it in a, what would it take for me to use AI in my practice? I think beyond that trust, beyond the validation, there should be explainability. No black boxes. That is not something I can use.
So we will touch on those black boxes also, right? As in the sense that do you need to know it as how a data scientist will need to know it, or do you need to know it enough to say, I trust the system, I trust the output?
I think in that case, this was so I was having a very similar conversation outside. I was just talking to somebody about, if you are an engineer, a software engineer, how would you feel about vibe coding? Right? You would say, oh, no, I don't trust the output. But then you would be able to look at the output and know instantly where it is wrong.
Right.
You would know how it reached there. The same thing for me as a doctor, after training for 6 years, plus about 3 years for my specialization, plus 3 years for super specialization, that's 12 years, plus working, gaining that experience. So I know how I reach those, how I make those mental leaps of logic. If I can't see AI making those same leaps of logic, how do I know it's a hallucination? How do I know it's a real output if it can't explain how it reached there?
I see what you mean, right? It's more about trust in the system, and you should need enough data points from the system to provide that trust.
Fair.
Yeah. Rashmi, given that we've talked about systems and everything else, your perspectives on this?
At Rich, so far what we've realized is that a lot of life sciences startups, the science foundation is very strong. And I strongly echo what the fellow panelists have said, that deployment is the real issue. Translation is the real issue. So what we've been always trying to do is to make those relevant connections. If startups need a mentor connection, a startup needs a foot in the door at a big hospital, or want to talk to a clinician, or want to use an equipment in a big institution where they on their own will not be really entertained, or it will take a very long time for them to get there. So those are the kind of interactions that we facilitate. And moreover, introducing startups to the industry, like the startups working on, say, AI platforms for drug discovery, or startups doing blood-based diagnostics, helping them get introduced to the industries, that I think has been the core of what we've been doing. And usually what that does, it's of course a win-win. We all know that the startup gets the relevant connects, they get market access. The industry also gets a platform where they can trust, they can look at several innovative technologies which they can consider adopting, and same as with the hospitals as well. So our focus has also been talking to clinicians, talking to hospitals to get problem statements from there. Because we don't want a startup to build a solution and then go around looking for problems where to deploy this solution. So if the problem statement has come from a surgeon or a clinician, that is a very good starting point, and that is what we have been trying to do. To your other question on what are the challenges, I think there are several, and I'll highlight a couple of them. Like the main challenge is the expectations, how the startups want to see what they get out of it versus how, say, a hospital or an industry a player looks at it. Also, the timelines. Startups work on multiple iterations. They work on a very rapid iterative cycles, whereas industry has a very long forward-looking vision. They want compliance, they want governance. So that is where that friction can come into play. And our role is to actually sit in the middle and try to get them both talking and try to resolve some of those.
Yeah, no, it's a great point you mentioned, because when I teach the class on growth and to startups especially, I talk about some behavioral effect called the 9x effect. And what happens here is startups, when they come up with their products, they overvalue the benefits, they talk about how good it is and devalue existing solutions. Whereas for people who are adopting it, hospitals in this case, it's the exact opposite. So they tend to devalue the startup's innovation, they like the status quo, everything is good, trust, and this big gap is where most of these conversations end up failing, right? So it's a great example that you got. The other Madhu, the better Madhu on the panel, now your opinion, sir.
Yeah, I think Rashmi kind of said many things I wanted to say. But the more important thing here is, for me, looking at various AI and non-AI startups and things like that, I don't think there's a big difference between them, why they succeed and why they don't succeed. It's more to do with how smart is the founder. You may develop a product whether AI based or non-AI based, but how do you evaluate the need for it, and who are your clients, identifying them, and also look at the size of the market and can you scale it up and things like these are all which are very common for a startup journey. Also apply for AI, which is without any doubt. So to give you an example that is with us, see, we have one company called Semantic. Semantic is the founder is a informatics person, and she wants to use that software for analyzing genomic data for actionable outcomes for a particular disease prediction. She developed it and everything was fine. In fact, one of the major things we contributed to her progress was we allowed her to use the data that CCMB generates. That's very important because this is a well annotated data, and the whole thing is under control. So we gave her, so she could train her software on that, and she is able to take it forward. And the kind of added value to that is by her turnaround times are less. But when you look at when she wants to go to the market, there are already very big players already in the market, and recently the Geo bought the MedGenome. MedGenome, and then they crashed the prices. Almost it used to be 20,000 when she started, and now it became almost 12 to 13,000 at that time. She was also playing other things. So now it becomes the so-called advantages of turnaround time and quality of data, quality of the report, are not really flying. So the problem is how do you still push it in a very price-sensitive environment and make sure that your thing goes forward. So one has to add other values to it, and then add other, other inputs into the data so that you can come up with a different way, more enlarged report system, like the one. Then one of the talks, the last slide was, unless you are able to pivot, I think you are in problem. Unless you keep changing, because many people who come to us, they talk about the competitors of today. But by the time his product comes to the market, it'll be 2 years from now, and the marketplace is not the same. So that kind of knowledge is always missing. So I think AI and non-AI, the founder is most important. How many hats he can wear is most crucial. That's what I think is the...
No, I think you all made some really good points. So I will try to bring this back to bio AI, right? So if you think about the bio AI stack that we're envisioning, I think so far a lot of it is thought of like an infrastructure kind of a setup, right? You'll have different access to technology, access to infrastructure, there may be data sets available and everything else. But all of you have highlighted a big point about how this is great, but when it comes to deployment, when it comes to actual practice, there are lots of things that change, right? So let me ask each one of you, wearing your own different hats, to see how those things happen, right? So let's start with Rashmi, and in terms from a investor slash an ecosystem creator, which parts of the biostack do you think are fundamentally misaligned with how a VC or a future investor will look at?
Well, I think one of the key challenges what we have noticed is not having a very clear defined use case when starting out. I mean, a lot of people are working on it, but to know where exactly this is going to be useful, where is this going to find a use case, whether it's in a clinical setting, whether it's an industry, that is, I think, the first conversation any innovator needs to have. And sometimes that is missing, grossly missing, and then it leads to, very long cycles of putting in effort, money, time, and then coming to a point where when you actually go and talk to the customers, it is not really useful. So I think those are the very first conversations that need to be done, and specifically for bio AI, because it involves experts. I mean, unless that expert wants to use your product, it is not going to fly. That, I think, is the primary challenge that we've seen. And like I think Dr. Shashidhar also mentioned that some things work in a very controlled environment, but when these models are exposed to some real clinical settings, say some variability, different populations, different samples, then the actual it may behave very differently from what you had when you had a very curated data set. So that particular thing has to be taken into account when developing these things. And I think the third one I would highlight is a lot of innovators and startups underestimate the requirement of a regulatory pathway. They have these conversations very late in their journey. Be it regulatory, be it validation, and the industry wants it right away. Because if you are pitching to an industry, they will look for compliance. They will look for how have you addressed the privacy concerns. They will look for governance. And if you've not really thought about these things, no matter how good your product is, they may not be able to adopt it immediately unless you go through all of these steps. So I think these are some of the very primary requirements that any innovator or startup should ideally look at.
Vamsi, your thoughts?
Very, well aligned with what Rashmi said. But, as an investor, I might sometimes give a leeway towards regulatory aspects, but I would definitely love to understand how exactly a startup will align with the current regulations in terms of are there right processes to deployment? Is there a long-term feasibility of growth in the venture or the product that they're building? Because understanding those aspects might open up a lot of doors for a startup to kind of get an extent or hold of investments. If they are not aware of couple of layers, let's say how to go from safeguarding their own innovations to also ensuring the safety of the patient. If they don't understand these specific 3-4 layers in between, then I don't think the investors' doors might open, because that's also a liability for investors, and they might divert themselves to taking a lesser ownership and investing in a less innovative startups.
So let me actually ask both of you a related question, right? This is very much from a investor perspective, but from a startup perspective, right? I think Rashmi mentioned about the differences in timelines, and there is also a difference in, like, a startup is looking to survive, right? So what do you do to enable, these offshoots or sprouts to blossom, right? So that is the question that startups wants to know, right? I'm willing to do all of this, but I need some breathing space. So
I have come across a couple of startups who have built their products in 6 months, but again, had to survive the harsh reality of at least cracking a deal with one hospital to go live with the product, which takes like a year or year and a half. So I would really request startups to kind of put in a little more efforts into understanding the market and interact with customers and doctors to understand the use cases a little more. Spend 6 months or 12 months over there. You can build the products later on. And when it comes to specific topic of AI, a lot of them started using wrappers. They're building an extra layer on top of the existing platform. So, which is less innovative, and due to the boom of deep tech and deep science now in India from last couple of years, they have started positioning themselves as deep science innovation or deep tech innovation, which might open up a couple of doors, but after 1-2 interactions, you might lose hope of getting at least 20 lakh rupee grant or a 20 lakh rupee investment from the investors, because that reduces your chances of standing out in the crowd of 200-500 startups who are building similar sort of product, directly or indirectly aligned with your vision. So focus more on innovation, less on using the existing platform, building on top of it. You can take inspiration, but that doesn't necessarily mean you can just source that and build on top of it.
Okay. Rashmi, any more thoughts on that?
Yeah, I think our core role is to make those relevant connections and mentoring, especially because that idea has to be adopted by the startup. It has to get drilled down to them that, okay, even if you don't look at regulatory, if you're not looking at regulatory or validation right now, there will come a point where you will have to do this. There is no escaping from that truth, that you have to go through the rigor of all of this. And that is why we also, in some of our sessions, we do one-on-one sessions with the CDSCO officials here in the Hyderabad zone office. We have done several networking events or one-on-one sessions with clinicians and hospitals, so that the startups get a chance, first-hand instance of talking to the real expert, getting mentoring from them. So all of this, I think, we believe will help facilitate their journey, will help them scale up and go forward in their journey.
Oh, excellent. So let me now actually take the hospitals and the clinicians' perspective on this, right? And Dr. Shashidhara mentioned this about how they do some things internally and some things they also have startups and looking at it. Which parts do you think are more amenable to an internal setup? And which parts do you look for in a startup or an external basis?
So you mean the hospital?
Right, a hospital or a research foundation when you're doing it, right? There's some things that you do in-house And then there are some things where you're willing to listen to ideas from startups and everything else. So where are these areas where you trust yourself more versus you're willing to trust somebody else?
So I'll tell my first-hand experience with my research foundation to start with. So basically, our research foundation here in Apollo Research Foundation here, we specialize ourselves in the area of developing biomarkers and diagnostics. So that's our core strength, and that is the necessity for the hospital. So developing new biomarkers and new diagnostics. And before we start something, we sit down with the clinicians. This is the translational route, translational research route. Identify the gaps, what they are. So we don't develop a product and then go to the doctor. So we sit down with them, come up with the bunch of problems, sit down in the lab, troubleshoot it, come up with some ideas, and then again sit out with them, and then we develop the product.
So it's co-created almost.
So it's like we co-develop something. Yeah. And after we develop, so we also have a sort of an incubation setup there in the research foundation. We develop it, we develop the product, and simultaneously we have a regulatory arm sitting with us who files everything. And also we have a diagnostic arm which takes in the product which is developed, and then we have the, so basically we have an ecosystem from start to the end, and which can facilitate innovation. And also recently we started, we have the AI arm also sitting in the hospital, which has making considerable efforts and developments in the form of AI. So this is what happens in our foundation. So to answer your question, so the core strengths, we believe in the core strengths, and wherever it is outside our core strengths and we don't want to invest on the areas, time and money and other things, we look out for expertise.
Okay. Kiran, your thoughts as a...
I think this is basically an open secret that in general, any product that requires data which is proprietary to the hospital or within their control or grasp, they would prefer to do it in-house. Anywhere. That's one of the reasons ABDM doesn't work.
Yeah.
So I think in general, but I would like to also try to look at it in a different way. See, there are hundreds of startups building in AI, right? It's an AI gold rush. In a gold rush, sell shovels. Try to get your own data sets or try to create sort of comprehensive data sets. You can go to hospitals which are today willing to share data. If you can meet me outside, I can tell you a few of them in confidence, of course. But along with that, look at what all we require in order to build this. What all do other startups require to build this? You need the infrastructure, right? That was the theme one of today. And so many other things which are ancillary to building in this sort of sphere of AI in healthcare and life sciences. It doesn't always have to be that. So I think this is a very important point raised by Professor Madhu on the panel. He said that you play to your strengths, right? So if you are a data guy, play to your data strength. If you have a background in life sciences or medical or maybe something like genomics or pharmacology, that makes a lot of sense. But if you are fixated upon the idea that you have to build, then it's very important to co-create. Either that or expand your team, get some expertise, get somebody who has that domain expertise in the field that you want to build. Otherwise, it's going to be very difficult. And I think the rest of the points have been made very well by Dr. Rashmi and everybody. So I think I'll stop.
We will touch on the data part also because that's a big part of the bio-AI stack,
Absolutely.
right? And we've also touched part on ABDP. And so we'll get, but Professor Madhu, your thoughts on the same question. What is stalling or where do you look for startups? Where is it happening internally?
So the context is investability, isn't it? So in my opinion, I think generally people talk about TRL levels and things like that. But I think for an investor, TRLs are less important and MRLs are more important, the market readiness.
Yeah.
So market readiness levels are more important for investors because that's where he sees what is the runway for that product to come into the market. And, at that level, he also will make a judgment on whether AI based or not wise, it is, the value of that particular product that it is going to. And also some of the point that was talked about, validating the data. Yesterday I was in some meeting in MIT, and only one suggestion I made was exactly what he was mentioning about was on most of the hospitals are not very forthcoming to help a startup, right? So my suggestion to at least the group that there was, can you institutionalize the obligation of the at least state and central hospitals play the role of a stakeholder in the startup ecosystem? When we go to a NIMS or AIMS or something like that, they should be somewhere obligated to support the startup, allowing them to do some kind of a, like what he said is maybe some hospitals come forward to do it, but many won't because it's a data is money, so they don't get out. So at least the government on a top-down approach, they should institutionalize the government hospitals to kind of
Start
support
looking
the.
at it.
Yeah, so that's what I think.
So great point, and I will touch base on all of these, which are also hindering stuff, right? But one last question on regulatory uncertainty, liability, because that's again a big part of the ecosystem that you work in, right? So let me ask you this general question, right? Which is, who bears responsibility when AI system fails? And I want to keep this answer short because I know this can get philosophical and we'll get into a lot of things. But we know that legally what ICMR guidelines are saying. But how do you gauge those things when it's a slippery slope here, right? How do you go about doing this? So we can start from anywhere.
Okay, I'll just try to keep it as short as possible. In fact, we had a very spirited debate during our ISB days on this very sort of subject. So what I had told at the end of that debate was, if I am involved in building that AI sort of solution, then I can trust it because I had a hand in it. So if I don't trust my own work, then what will I trust? So then I would be ready to take liability. But in the current climate, what happens is somebody else is making it. I have no idea what training has been given. And I'm expected to take liability, which is why even though I know that there are many models out there with accuracy levels better than mine, maybe 97% even, and a human maybe 75% right most of the time. But still, I would, or they're actually still marketed as screening tools. They're not marketed as diagnostic tools. That is the reason. If you don't take liability for it, you can't actually call it as a sort of, you actually can't take the credit for a diagnosis. You'll have to call it as a screening tool because it needs to be looked at by a human. So I think I will go with that if doctors are involved in the creation and those doctors are fairly well known, I would still be okay with using them.
What if a system provider like any of the medical device companies says, I will take ownership or...
I am more than happy if they're able to take liability. So absolutely, 100%.
The only thing is they will not.
Yeah, I know.
Dr. Shasidhara?
So I would say at this present moment, maybe a multimodal AI would be a better thing rather than a single focused biomarker sort of thing. So because not all the biomarkers can go wrong at one time. And probably a week ago, I guess, FDA has changed its rules for the AI devices. Right? Yeah. It's a complete rollback on the AI part. So if you are able to predict something in the next 10 years, it is out of the regulatory purview. And if it is 1 or 2 days or 1 week or something like that, it comes under the regulatory purview. So basically the short answer is we are evolving. So maybe we need to have multiple things together, um, rather than relying on one particular component or something like that. So that will help in a better diagnosis, so that at least the risk is distributed on the whole.
Yeah, but I think at least legally people will
But that-
who am I looking at, right?
That doesn't
Yes.
answer who takes liability, because nothing can be 100%. So let's say you take multiple biomarkers, all those things. Let's say even then the AI makes a mistake. Who takes liability?
Professor Madhu.
If a diagnostic product comes to me that is based on PCR versus AI, I'll take the PCR.
Okay. So I think that kind of summarizes the current state of world as far as liability is. And as the panel mentioned, I think this is a very evolving space as far as liability at least goes. I do want to step back and I want to start seeing what about the bio AI stack, right? And if you look at the AI stack, we talked about different components. So quickly, can you tell me essentially data access and quality? Okay, what is missing? What do we need to do to get there? And I think Professor Madhu had a very good suggestion, right? And I've always wondered why in India we don't have enough data to do things. Part of it is we do have huge government organizations which are constantly collecting data. I don't know if they're collecting and storing data, but they're definitely collecting data in many different ways and providing access to people in a better organized format can start providing some resources. But any other thoughts on data access and quality? Yeah.
Adding on to Professor Madhu's take on collaboration between state and central government hospitals, government could take a step into building a network wherein all the hospitals can bring together the networks, the data sets, and help their own models train on those data sets and build something out of it. Rather than reinventing the same wheel in multiple hospitals, they could collaborate and build one single model which can be used across hospitals, not only government but privates as well. Because this rush and especially training AI models has become like a government will. It's become very slow, very capex driven, and gestation period has also increased into deploying the model in the market. So yeah, that's my take.
Yeah. What about clinical validation? I think you mentioned that was the most important part of this AI stack, right? So what can we do to make or bring more relevance to the clinical validation setup for a bio AI stack?
So data, quality data, and I completely second Dr. Madhu's view, like state and center. And another state and center should initiate a pan-Indian database for getting data. But the problem again is different hospitals have different machines, different quality, different. So there's no uniformization of the data, no standardization of the data. So somewhere something has to start. That something actually is basically a common uniform thread where data can be normalized or standardized at a regular pace, and there should be an central repository. Maybe there's so much of research happening by all the institutes and everything. Maybe they should mandate the data to be stored from all the projects, so that that's one way to start. And regarding the clinical data for the validation, so there are many initiatives that are started, but the basic problem lies in non-silos. Basically, the information is in silos, and it's not standardized and not normalized.
So very similar set of things which are stopping, right? Standardization, lack of collaboration, cohesion, because we are working in silos across things. what about the next part of the whole thing? And I'll turn to both Kiran and Rashmi on this. Is essentially deployment and workflow integration, right? When you think about bio AI stack, and you both have been talking a lot about that. So, what can we do there?
So I think, see, if you're actually talking about having this kind of a data repository, make it mandatory for both the state and the central governments to provide that kind of data. You already have ready-made sites for trials and pilots, right? These same sites from where you take the data can serve as multimodal pilots. You can have a multi-center pilot, which will obviously give you stronger reports, stronger results, and you can go back and reiterate if you need to do something else. But see, at the same time, there is a very sort of important point here. If you're talking about the state machinery, if you're talking about the state infrastructure, I am not sure at this point of time whether they even have the infrastructure to support regular PHRs. AI to dur ki baat hai. So what I would say is, see, just like, if we were to build an AI for that, how to get structured data out of unstructured data, maybe that's a good starting point. Because then you can use that now structured data to train your sort of AI further. And maybe that is how we start doing more and more. So you sort of first effort, build on it, and then get to where you want to go. Maybe we have to do it that way because most of our data is unstructured. You will find handwritten notes, you will find sort of illegible handwriting most of the time. I mean, it's a meme and a joke about how we doctors write. So that is true, unfortunately, in most of the cases. But even if you ask somebody who has been writing handwritten notes throughout his life to suddenly start typing, I think we already saw that in one of the talks where they had to sort of use 2 fingers to type, right? And that is a challenge. Look at the number of patients in India coming to a doctor. It's not humanly possible for a doctor to enter structured notes for every single patient. And that is where my favorite AI tool is still the sort of ambient AI listening and providing a structured data. If you can push that forward, maybe that solves the structured data problem. And then maybe we can start to build on that.
Yeah. Rashmi, your thoughts?
I'll only add to what Dr. Kiran said and highlight a very, very basic problem that we encountered when we had a conversation with one of the biggest public hospitals here in Hyderabad. The leadership there was very ready to do whatever it takes. But the main challenge for them was the time and resources. He told us that we are supposed to see about 500, or we have the capacity to see about 500 to 600 patients a day, and we end up seeing more than 2,500 patients per day. And if you are telling us to do anything that adds to our effort and adds to our time, it is not going to happen. So I think what needs to be looked at is how are some of these basic challenges going to be addressed? If the doctors there or the pathologists there or even the general physicians there are willing to put in or do extra, how can some of the other things that they do can be made easier for them? So I think it just boils down to very, very basic challenges to facilitate something like this.
Okay, so I'll come to questions after my last question here. Okay, so last question is,
when I said about hospitals, what I meant was not their data. I'm talking about, we get a lot of startups who have some AI-based software to be tested, and then, they wanted to test it or beta test it in a hospital. Where at least there is some annotated patient data will be there, test it on them. It could be autism or it could be a sepsis or something else, So there is a data there are a few patients, so he can go and test the tool. I was talking about that. I'm not talking about the hospital data per se to be used in here.
Yeah.
I just wanted to.
Yeah. So actually, thanks for the clarification. And we'll start with you on the last question because you had also mentioned it before. And I just want to ask, if India were to invest in one public good for over the next 2 years, right? What do you think it should be?
I think one thing that comes access. I mean, one of the things I was saying in the morning about AI's power is in equitable health access, which is something is extremely poor. If you look at across various countries and in India, I think we are somewhere at the bottom in terms of access to good health care. So I think that should be how do we use AI to meet that requirement? I think that should be our focus, because there are so many tools where we can do point of care. In fact, in the morning there were several talks about where you don't have to do a specialist at the village, but you can solve the problem still. I think that's where I think we should spend a lot of time.
Yeah. Vamsi?
There is something like a validation infrastructure to help early stage startups, at least in healthcare or bio AI space, to validate their innovation before deploying or even going to pilot testing. That will give them an extra leverage in terms of how accurate the current scenario of the product is and how feasible would it be before deployment and actually taking it to the direct end consumer, that are the patients, and how trustworthy the tool might work in the hands of a doctor.
Nice. Rashmi?
I would think of an end product or an output to what I would like to see. I would like to see, and that is also something that we are working on at Rich, is more number of biobanks in public hospitals. Because that is where, that is going to be the gold mine for research, for diagnostic purposes, for pharma, for startups, everything. And then again work backwards to the data that it generates and the kind of information or the patient information over a lengthy period of time that the clinicians get, and how they can improve their diagnosis once they have, say, a 5-year period of data. So that is something that we are working on currently, and I'm really hopeful that it sees the light of the day someday.
Okay.
So I think there are actually two things over here. One, I would like them, if possible, to open up the public healthcare system to young builders. Because I think the most important time that we can spend is in developing the question. If we can shadow the healthcare workers, whether a doctor, whether a nurse, or even an Anganwadi worker, I think they do
Asha
great jobs.
workers,
Yeah, Asha workers. Shadow them, because you're building for them ultimately. If you sit with them in a sterile consultation room and talk to them for half an hour, versus going with them, being on the job for, let's say, a week, going to where they are going, looking at the specific challenges. यहाँ पे network नहीं आ रहा है, यहाँ पे signal नहीं है. All those things, how do you overcome that? Then that will give you an idea about what the pain points truly are. And then maybe you can have a really, really good problem statement, and that may have a much bigger impact on healthcare than we do right now. And I think the main thing over there is, see, the size of our country is often cited as a big barrier in sort of doing, or rather for the government to do these things. But I would say that we ask our government to be accountable. So this is just an example, for example. So there are certain cesses collected on sin goods, cigarettes, alcohol, etc. None of them are earmarked for health. Can we ask them to earmark it for health? Maybe that's a start.
Okay. I will stop with the public good part of it. Dr. Venkata.
So I think the one most important thing, at least the government can create, is a sort of a national consortium, an Indian consortium, which can actually create actually access for the data, and which can give access to the data and validated data for the validation. I think that should be the ultimate goal. So only because unless you create access to quality data, you can't have a quality app. So it's the building blocks which needs to be built.
Okay, excellent. I will now open up for questions. Okay. Yes.
quality of data is it very bad? I don't know. The reason for it is, see, when we look at election things, there were so many, gaps in collection of data and enumerating it and things like that. But still, the overall thing seems to be okay. I mean, the predictions. I don't know whether AI can solve this problem of quality itself. I don't know that.
I think there's a lot of money spent also in the elections part, which compensates.
I'm just saying, as a data part of it, can AI also come up with a way to solve its own problem of quality of its own data?
I think that's a different discussion. I have thoughts on synthetic data and the issues with synthetic data as well. But I'll open up for questions. Yes. I'll start here and then I'll keep moving around. Yeah. Rohan, Krishna.
Yeah, hi all. So, I'll address the elephant in the room. Everyone expects everything free of cost. Just because hospitals are public hospitals, state hospitals, government hospitals. I'll give you my example. I work in India's largest tertiary oncology center. The government pays me 9 to 5 to perform a certain job. I do that, I go home every day. If beyond that job I'm asked to do something else, which I might do, there are no incentives to do it. The incentives have to align. I have a tumor tissue bank that goes up to 6 years. Complete pathology, imaging, radiology, blood, tumor tissue, all the works. If a startup comes to me, I ask them, what do I get out of it? I built this repository and I have to go back, I have to get the data. Do I get 15% equity? No, you get an academic paper. Why? See, we are willing to work in the public sector. It's not that we are not willing to work. What startups need to be sensitized is, they need to open up. If you offer the right incentives, if you look at academics as partners, co-builders, somebody who you can offer equity in your company, some stake in this, then they take ownership of this. They are more than willing to do this. The incentives don't align. We do not have this culture. I'll give you a simple example of United Imaging. You see, United Imaging, one of the largest stakeholders, equity holders in United Imaging is Tsinghua University. They hold 7% equity. That is because United Imaging trains all their algorithms on the academic data that comes out of Tsinghua University. This sort of a model will never work out in India because most startup founders do not have this mentality that, we need to co-build with academia. Unless these incentives align, there's no, reason for somebody in a public hospital to go out of their way to curate data, share it with everybody. I mean, everybody has to work together to find models.
I think you've brought about a very interesting point, and this is part of how the committee has been set up as well, right? In the sense that you're right, in the sense that I think academy, industry, and government collaboration itself has not really happened. I wouldn't be so nihilistic in saying it will not happen. I think there is good chance it will happen, but we just need to start figuring out how to make it happen. Your thoughts on that?
So I'll just end it with this. So the way to make it happen is if the incubation system and the government policy system, who are the mentors, train them in this thought process. That is where it has to start. That it's okay to share some equity or some part of your company as long as it helps speed up product development.
It's more like a culture thing, right? It's okay. It's okay for all of us to grow.
Yeah.
Your thoughts?
Is a hospital or a institute like ours, usually for example, in his case, he's the guy who developed the database or data bank, and how much of the, obviously when there is money, there is also distribution pattern. How well the hospital developed a process for this distribution of whatever that money comes in. Say, for example, 6% equity. How much the inventor will get? Does he get 4% or 2%? Does the hospital has a policy on these things in place? Unless it has it, these things don't move. In fact, there's the same problem we face in our institutes because when money is there is always, let's do it tomorrow. I mean, people don't want to discuss it.
Yeah.
So if these processes are in place, I think many things will fall in place.
By the way, just as a reflection, China has done a very good job on that front. the US, despite what is said, the state schools have not been very successful at commercialization. It's the private schools that have done an incredible job of commercializing. So there is different patterns and different setups to learn as well.
My query is about the rural sphere. Everything doesn't seem to work there. Supply chain management, simple things like that, right down to telemedicine, all the big words. So, any initiatives in that direction, or anyone has any comments on that, please?
I think it's...
So basically, Apollo has a telehealth program, and it's one of the oldest telehealth program in the country actually. And it's being operational from the past 8 or 9 years, I guess. And they're not only catering the Indian subcontinent, they're also catering to the African subcontinent. So that's the thing.
There's one other initiative that we are trying to do along with the government. There's going to be a blockchain-based sort of authentication for healthcare providers. So that is one thing to check sort of unauthorized, or what we call as jhola chap doctors in the rural areas. But again, see, when you don't have access to a doctor, anybody who calls themselves a doctor will do. Right?
Yeah, hi. Well, okay, so one question here and then one question over there and then, okay, one more. So last three questions of the day.
I had three, but I'll make all three as part of my one question and make it three parts to my one question. First question is about the data. When we said let the government institution take the leap forward to train for the data modeling. When we talk about lifestyle diseases and a lot of these things, will it work? The AI models trained on only just the different spectrum of government population, would it still be, can we extrapolate those AI models to work in the private sector when we commercialize? Question number one. Second is about the data ownership. Who exactly owns the data, right? When we say hospital owns the data, is it hospital's data or patient data? And then according to that, we need to identify who plays the role. And then startup, giving out the equity to the ecosystem partners is also about how do we collaborate and what, I wanted to touch base, but sorry. So let's first talk about the first two parts. How do we address that? And sorry, I'll just add, in the Western world and many places, we see that these ecosystem players play a role early stage, during the early phases. We need to collaborate during the early phase, help the startup in the early phase of the survival, compared to everything, okay, पहले कर लो, करने के बाद सब help करते हैं. पर करने के टाइम पे, स्टार्टअप इंसेप्शन के टाइम पे अगर आप थोड़ा सपोर्ट करते जाओगे, तब जाके हम सस्टेन भी कर पाएंगे. And I'm a startup founder, so generally what happens is like a startup founder versus everybody else. So could we just help with that narrative?
So I can at least say one or two things in the sense of, if you think about data ownership, I think the DPDP Act that is in process, the guidelines have come out, kind of tells you what it is, but there is an exemption clause over there which says, if it is about public benefit and everything else, it's okay. So those guidelines still need to be fleshed out in more detail to figure that out. In terms of data for government versus private, there are selection issues all the time with data. And I think a lot of it boils down to what is transferable from one setting to another setting. And I think people who are working in this space like you are, you will know that there are some things you can say with confidence and some things you can't. So that's my opinion on those two things, but please.
So I'll just quickly answer your first question. See, if that is the reason for clinical validation, so if I could understand this sort of correctly, would you be able to get the same kind of results using government data for lifestyle diseases? That's what we need to find out. That's what validation implies.
Correct. So then the applications will have to be validated in government and in private both, right? So we cannot just say that it's only the responsibility of the government or the government institutions.
No, but it's government only gives you the data. Rest आपको करना है. In the sense validation.
पर हमको आपके साथ करना है ना, hospitals के साथ. See, hospitals don't open up the data easily, and that's the biggest challenge. So now, if we are training it on the government data, we want to also.
It's a wish list.
दोनों को parallelly develop करना पड़ेगा, तब जाके equivalent output आएगा. And coming back to Sir's question about the failures of AI companies in the pilot phase, see, we have trained on a very limited set. How much percentage of error are we talking about? Did we just have 10% error आया और हमने पूरा AI को neglect कर दिया, versus did we do corrective actions to recalibrate your AI algorithms? And that's where we need support, saying, okay, yes, it failed in 10%, but it's working in 90%. So let's correct those 10% with the real world data. So when you go out in the world, of course there is a gestation period of these algorithms. During that phase, the industry has to support more, saying that yes, it is failing in certain amount. I mean, I have developed some of these algorithms for data compression when it was in the early stage. It worked in few cases. There was 1 or 2 cases it didn't work. So we had to recalibrate a lot of things. And we had the bandwidth in the Western world with finance and the resources. Could we have the similar bandwidth in India? What we lack in startup world is the intent to make the entire thing work, and the funding part, which everybody wants startup to do everything. However, how do we sustain with so much of responsibility? And the last question is responsibility. Who takes the responsibility of AI algorithms? If you are building it collectively, could we collectively take a responsibility, please?
No. So that last question we'll answer later.
Sorry.
But your question, sir.
Since we have a panel of opinion of policy setters of the country, we may say, is the government even listening to clinicians? I'm talking from the clinician perspective. We are discussed, where does the liability lie? Ultimately, the liability lies with the clinician. ECG algorithms I've been seeing for the past 20 years, and I still find mistakes in them. Where does the responsibility lie? You say collection of data and all that. Ultimately, what's the term? Fiduciary? The clinician is a fiduciary. He has no control over where it is stored and who is hacking it. Yet he is responsible, and he is the only guy liable for it now. When we are talking of collecting data in the right, collecting data in the right perspective, and working with industry, collaborating with industry, the NMC norms do not let me engage with industry at all. I can't be a consultant. I can't be a teacher in a government institute, and I can't be a consultant like IIT professors, IIM professors, consult industry. I can't be a consultant to the industry at all. The regulatory framework from the clinicians or the hospital's perspective is totally inimical to the development of any combined or collaborative setup, because there are just too many liabilities and there is just no benefit seen for me as a clinician at all. Not only there is no benefit, there is a disincentive for me.
So this is my perspective, and of course the people.
So are the regulatory people looking at it from my perspective?
I was going to say that is a government listening? Answer is yes. Are they acting on it is a different question. But they are definitely listening. They're aware and they're trying to do what they can. But others who want to chime in, please.
I think those are all excellent points, and on different occasions I've made some of them myself. So I totally get where you're coming from, sir. Unfortunately, there are no easy answers. What happens is we have a culture of trying to build or trying to make laws for edge cases rather than for the majority of law-abiding citizens. We try to go after that 2% or 1% who are breaking laws, and in that we make life miserable for the rest. Unfortunately, hopefully things should change. That's all we can say.
The trend seems the other way around.
I know, but this is a different discussion. Let's take the last question, and
I think mine is also along the lines of what others have been asking so far. So, I mean, I will not elaborate, but from each of your point of views, are you bullish that all this AI and healthcare strategy that the government is so focused on, is this the right time for it, or are we as a nation jumping the gun? Because clearly there are issues. The regulatory policies are still shaky. Ethics, nobody has spoken about. Data, I mean, liabilities with the clinician that has been stated. Is that truly fair? We all agree that it's not. Patient data protection, the neuroethics, and just in general, the bioethics of it, it's not in place. And also, as it was spoken that some AI algorithms, we don't know how they will respond once more and more data is fed into them. We all know that fundamentally AI LLMs are capable of catastrophic forgetting and things like that. So considering all this, what's your stand? Are you still bullish that this is a good time for India to do this? Or do you feel that there's a need to reevaluate?
So I will start this off as always, and Professor Madhu can also add in, is I'm actually very excited, and I think you're getting the strong sense of AI and everything else. I think the technology is there. I think there's a lot of good stuff that can happen. What I believe is missing is just coordination, getting a lot of things aligned, working around culture, perspectives, changing incentives and how it works. But I also think we are at a very big inflection watershed moment. I think it's not about should we act now, which is about how much should we act. Okay, and I think the better we get at acting today is going to define how we are going to be in the future. We have all the tools that are available. But
we should be bullish. There's no question about it. It's like you compare with other technology that came before, like nuclear or solar, whatever. Unless you get into it, you won't know what it is. But as far as this is concerned, AI doesn't have probably, the power of AI is unquestionable. And in so many aspects, it has a lot of value addition for Indian problems, whether you call it last mile, this thing, or many things, whether it's agriculture, it's a climate, or any of them. I think AI is going to make a big role, a big contribution. There is no question about it. And I think we should go ahead and do it. Unless you do it, you don't know how hot is the land. We'll find out on the way.
all right. So I think I'm going to end the thing today, and I want to thank the panelists for a great set of discussion points. I want to thank the audience for staying along for such a long time, and I hope it was worth it. I do want to emphasize with this last thoughts, right? I think we do end up celebrating a lot of pilots and small victories. I think it's about time to start building systems. And I think everybody wants to. It's just about policymakers and other stakeholders to figure out how to make that happen. And so it's about coordination across hospitals, across capital providers, across startups. And that is how we think the BioStack is going to actually create a Viksit Bharat, right? So thank you all.
Thank you, Dr. Madhu Vishwanathan. I request you to felicitate the participants, the panelists.
I was going to say it's been a Madhu all along. Yeah. Thank you.
I request Dr. Madhu to felicitate Dr. Madhu now.
We already have this photo.
Thank you.
But thank you.
She's not here. As we come to the close of the day, we would like to sincerely thank those of you who have stayed with us throughout. We hope you had an enlightening session today. I now invite Mrs. Ritika Marampalli from AICCCMB and Dr. Kiran Milkote from Avinya Strategies to deliver a vote of thanks.
Thank you, everybody. It has been a long day of marathon insights, and I think it is great to end the session by going into the last panel, the practicalities of building a bio-AI stack in India. As we wrap up, my role is now to briefly look back at the ground we covered today at Elan. If I were to summarize the day, I think I would say it's been a journey of silicon to society. We started this morning by establishing the foundation, looking at the hard infrastructure of compute and sovereign platforms with insights from CDAC and AWS. We learned that without this digital muscle and backbone, AI remains just a concept. And from the infrastructure, we moved to the real-world application with the flash talks. It was quite inspiring to see startups, for example, Garba AI, Centella, Logi AI. They actually proved that AI is already in practice and they're solving real problems on the ground. Post-lunch, the conversation shifted to the rigor required in research. A special mention to Dr. Rakesh from AIG Hospitals, who showed us the huge strides they have made by building together with doctors and AI experts. Along with the insights from CSIR-CCMB and IIIT Hyderabad, this session proved that in healthcare, speed cannot come at the cost of scientific validity. We then tackled the crucial question of AI for public health and ethical considerations. And this reminds us that trust and equity are the ultimate currency of adoption. So speed cannot be the only factor. We need to factor in trust. Otherwise, we risk losing the entire ecosystem. And finally, we close with this last panel on the bio-AI stack, discussing how we must co-create solutions to truly de-risk this sector. As we saw on the panel, the technology is ready and the capital is curious. The missing piece is often the bridge between them, and I hope today we have managed to build a few of those bridges. However, beyond just giving this brief summary, we also want to leave you with a concrete sort of conclusion. Today has proven that AI and ML are indeed actionable, and this isn't science fiction anymore. But for these models to work effectively in the Indian context, we need data, ground-level data, and lots of data. Therefore, we are formally proposing that AICCCMB steps up as the nodal agency to initiate this data collection. And we need a central force to aggregate high-quality clinical data to fuel this entire ecosystem. And we believe this is the place to start. To formally close us out and thank the partners who made this possible, I'll now hand over the mic to Ritika. Thank you.
Thank you so much, everyone. First, I would like to invite Dr. Annapurna. She is representing BFI today, and BFI has been a very important part of our journey from the last 2 years. So briefly, I'd just like to give the mic to Dr. Annapurna to talk about BFI.
I think I've run my mouth enough today, but yeah, so I'm representing BFI, which is Blockchain for Impact. So our name is a little misleading in a way. Even though we are called Blockchain for Impact, we don't necessarily just work with blockchain technology. So we are essentially a philanthropy that supports biomedical innovation. Under this, the reason we are called Blockchain for Impact is an acknowledgement to the community that has put in the money for this philanthropy. So under this program, under the BFI umbrella, we have several programs. We've partnered with AIC. We've also partnered with research institutions, including CCMB. And our idea has been to support innovators from various backgrounds. And we actually have a lot of exciting programs that are coming up soon, some of which I've been speaking to the founders and innovators here. One thing that I would like to mention, since there has been a lot of talk about collaborations and people from different backgrounds and expertise coming together and working together, that is literally the ethos of BFI. That is really what we are trying to do. And towards this, we've made some efforts. We've literally gotten people from different backgrounds, put them in a room and told them discuss. and we've created analysis and white papers out of it, and that is being used to inform our program strategies going ahead. So we've also developed this platform called as Interconnect. It's called Interconnect by BFI. Again, it's been envisioned as a social media for innovators. Essentially, let's say you're an innovator and you need a certain collaboration support, certain funding support. You come to this platform, post your idea, and ask, claim your exact ask. And we're trying to get people from different backgrounds on this platform so that the right people can see your ask and reach out to you, and collaborations can build. So please do check out the platform and keep an eye on Blockchain for Impact socials and our website. We'll keep announcing new and new programs that will be beneficial to the ecosystem. Thank you very much.
Thank you, Annapurna. So with that, I think I'll close the very, very long day we've had. It was a very information-heavy day, but I am so thankful to all of y'all because y'all stayed back and you'll have made it to the end of the day. And I know that everybody is, trying to get back. So very, very briefly, I just want to thank our collaborators, ISB, D Labs. Erin, where are you? Erin, I think Erin left. Avinya Strategies. Thank you so much for curating this. Thank you. And I want to thank CCMB for hosting us. The director has always been very generous with us, and the whole entire CCMB team sitting right here has been very supportive. I also want to thank each and every speaker, each and every delegate who's been here, because I was told multiple times today that, it's not just the curated speakers that we had today, but also the curated audience that we had. So I hope everybody had an enriching time. And next, I want to thank our team, which is the backbone. So all of us, all of our team which is here, thank you so much. And with that, I want to thank all of y'all and wish you all a very good night. Drive safe, everyone.